Well, hello, Internet, and welcome to the biggest video I have ever made. This is basically a 100% free, full Udemy course all crammed into one video. There are hundreds, if not thousands, of examples in this. All the code is organized and available for free on GitHub, and best yet, for the rest of this video, there are no advertising. As you can see, everything is well organized on GitHub. And there is a ton of code in all of these examples. There isn't just a little tiny bit. Here is just a taste. All right. And I have a lot to do, so let's get into it. All right. So in this tutorial, I'm going to be using Visual Studio Community, and you're going to be able to get that at visualstudiomicrosoft.com/VS for Visual Studio /community, exactly like that. And you just click on download and you download it, and it's going to work on Windows as well as on Mac. But of course, I'm going to be using Windows for this tutorial. Then whenever you open it up, here is Visual Studio. And first thing we're going to do is we're going to go into File, and we're going to go New, and we're going to say Project. And something like this is going to pop up. What's most important, however, is the Visual Studio C# right here. That's what you want to have selected. All right, you're going to click on Next. Then you're going to decide where exactly you want this to be stored. I'm going to select a folder for it. And we're going to start off just leaving the project name be console app 1 because this is a tutorial, and that's fine. And we're going to click on Next. I'm using .NET 6, which is the latest version. All very good. Click on Create. And whenever you do that, you're going to see a window that looks kind of like this. So what we're going to do is, this is our program, our main application where our main function is going to be. And we're going to come in here and change this up, of course. Now, very first thing I'm going to do is I'm going to type in using and system. And this is going to import a namespace called system. And it has a whole bunch of classes, which also have functions inside of them. And what it's going to help us do is, let's say if we want to print something to the screen, without this, we'd have to say something like system.console.write and so forth and so on. But whenever we have system inside of here, we can just type console write like that. And that's we'll be making namespaces of our own actually right now. Now, my interface probably looks different from what you're used to seeing. I enlarged it a little bit. And how you can do that is you can go into Tools and then go down to Options. And I enlarged my entire environment right here. But I think I want to enlarge my main text area. So environment is the entire text on all of the different screens. And where I want to also enlarge it is in the text editor spot. And let's say that I want to take this up a notch so that you can see it. It's set 24 is the maximum. Let's try 30 and see what that looks like. So I'm going to say OK. And now you can see the text here has enlarged a lot. Let's give ourselves some more room so we can type. Now, the very first thing I'm going to do is I'm going to define my namespace. So I'm going to go namespace like this. And I'm just going to go with console app 1. And then we'll be able to pull from all this code that we write here later on. Not right now. We'll get into classes much later. I'm going to define that my class is going to be called, public class is going to be called program. And like I said, I'll get into classes later. Basically, what classes allow us to do, to be very, very brief, is to try to model real-world objects in code. And later on in the tutorial, for example, I create warriors that fight to the death. And in doing so, I create a class called warrior, and I define all the different abilities the warrior has and the different attributes the warrior has, and that is all put into a single class. But we're starting off very simple here right now. And mainly what we're going to do inside of our classes is just have a main function that is going to execute code. And all of our code is going to start executing in our main function. So I'm going to say static. And what static means is that this function can run without creating an object previously. So we define classes, which are like blueprints for creating objects of that class. So if I have a class called dog and I create a version of that dog, then that would be called an object. All right, and static just means that if we want to go and use this function main, then we do not need to create an object called program to be able to execute it. Don't worry if this doesn't make sense. As you see numerous examples over hours, all of this will completely make sense. So static doesn't make sense, don't worry about it. When I type in void here, what that means is our function called main is going to not return any values. That's what that means. So it's going to execute, it's going to go and do some things, but one thing it will not do is it will not return any value after it's done executing. Then what we're going to do is we're going to define string. This is a string array. An array is just a bunch of boxes that contain data inside of them. And in this situation, what we're going to contain inside of here, inside of the string array called args, is any data that is passed to our function when it executes in a terminal window. Again, you're going to see a terminal window here in about 5 seconds. So let's just show you a terminal window to clear this up. If you want to print to the screen, see, I didn't have to type system. I just typed in console. And I'm going to go WriteLine. And then inside of this, let's just do the obligatory hello world, just so you can see everything. And you're also going to get to see the console window. So we have all that there. Let's save that. And I'm going to come up here, just so you can see it. And I'm going to click on this little play button up inside of here. All right, so let's click on the play button. And a console window is going to open up right here. And if we zoom in, you can see it says hello world exactly as we would expect it. Okay, so good stuff. All right, so that is the console window that we are referring to. Now there are a bunch of different console methods. I'm going to show you a couple of them, some of them fun. All right, so let's say we would want to change the text color inside of our console. We could come in and we could say console and foreground color, look at that, just pops in there for me, is equal to, and then you're going to say console color, and it defines yellow by default. I'm going to have my text be black. So let's go black like that. And then let's say also that I would like to change the color of the window behind. Well, that's actually going to take two different commands. This first one is going to change the background color only behind the text. And to do this, I can say background color. There it is. And there it is. And I'm going to have it be white. Now, if I want the background color to apply to the entire window, what I need to do is say console clear like this. And there we are. So there is our new application, and we can run this also. And here now you can see that we have our window. It cleared the window, so it doesn't show the hello world anymore, but it's showing me that it is black text on a sort of white background. I guess that's Windows version of white. And of course, if we didn't take the hello world part right here, and let's go and throw it after all of that. I'm going to be deleting this in a second, so there's no point in clearing that up. Let's go and save this, and let's go and run it again. And now you can see the hello world part is actually displaying here using our black text just as we would expect it to. Now what we're going to do is do a little bit of interaction with the user. So this time what I want to do is, previously I used WriteLine. What WriteLine does is it inserts a new line after it prints out text. Well, let's say I don't want it to do that. So I'm going to use write instead. I'm going to say, what is your name? Like that. And then maybe I'll put a space here at the end of it. Okay, so it's going to print what is your name, and then directly on that same line, the user is now going to be able to enter their name. Now we are going to go and store text like names and letters and numbers and what for, and inside of what is called a string. And I'm going to just call this is creating a variable called name that is of type string. We're going to get into the different data types here as soon as this is done. Now, if I want to read information from the user, I can say console and read line, and that is going to go and accept user input on the console and then store whatever they typed in into name. Then after we have that, I can say something like hello and print out a real message using the person's real name. So I'm going to say WriteLine, and I want to insert the variable's value. When I say variable, I mean the value stored inside of name directly inside of quotes. To do so, I'm going to go and put a $sign here, and then I'm going to say something like hello, and wherever I want the value stored inside of name is going to go between curly brackets, and of course close off that with a closing quote. And from now on, I'm just going to hit Control F5, so I'm not going to click on this anymore. That is the shortcut. So Control F5, and what is your name shows up directly inside of here. And I can come in to this guy, and I'm going to type in Derek. All right, can't do that at the same time. So let's type in Derek like that. And now you're going to be able to see what is your name, Derek. Hello, Derek. Okay, so good stuff. Exactly right there. All right, so let's get this out of here and let's close that. Now I want to talk about variables. Now, variables are just going to be used to store different types of data. And we're going to use very specific types of data, either because it's going to allow us to perform certain functions on that type of data, or it is going to conserve the amount of space that I want to set aside in memory for storing the values that could potentially go into these different variables. Very first thing I want to do is I want to create a Boolean, and it is going to be called can I vote. And these Boolean values are either going to have true or false values. That is it. And whenever we get later on into conditional statements, which are going to execute different code depending upon different conditions, you'll see more about Booleans at that point in time. We also have integers. Now, integers are going to be 32 or 64-bit, and we're going to say console, and I want to go and actually print out the biggest integer you can possibly have. So I'm going to go here, and I'm going to say biggest integer, and I am also, another way, you saw that I used that $sign previously to directly insert the value. We can do it that way, or we can also come inside of curly brackets and label these 0 through 1, depending upon what value we want to store inside of here. And to get the maximum size for an integer, you just say int and max value, like that. And that is going to give us our biggest integer that we can possibly store inside of our integers. Let's go and copy this. And then let's make a copy of it, and I'll show you the smallest integer you can store. So this was going to be the smallest integer. And to get it, guess what? This is min value instead of max value. Let's do a little bit more, though. There are also going to be longs, and you're going to see the biggest long we can have. And let's make this biggest long, like this. And they are going to store 64 bits in size. And then we just type in long here instead of int, and we're going to get that. And let's go and let's just leave that as min. Let's leave it as max. I have to change the text somewhere, so let's just change it here. So the maximum value for a long, and copy that. And this is going to be the smallest value. And inside the description for this video is a link to whatever you could possibly want to learn about C#, all in one place. All right, let's do some more before we output this. Let's say we want to be able to use decimals. That's the thing with integers, there's no decimal points. Well, if you do that, then you're going to want to use a decimal data type. So a decimal, let's go and create one. I'll call this decimal I value is equal to, and let's go and throw in a big value inside of here. Boom and boom. And you're going to end this with a uppercase M. Then I'm going to also come in and I'm going to create another because I want to show you the precision that you get from a decimal data type. They're basically going to store a 128-bit worth of decimal values, which are going to be accurate up to 28 digits, which you will see. So I'm going to go decimal, and I'll say big num is equal to, and I'm just going to throw a large number inside of here. So this, and let's throw that inside of there. Good. Now what I want to do is go and add them and show you how precise they are. So I'll say console, WriteLine like this, and then inside of here, I am going to go to quotes, and I'll go decimal and pi plus big num is going to be equal to, throw this inside of here like that, and then I will go and get this value. So I'll say decimal pi val plus decimal big number. And let's go and put this on a separate line just so you can see it a little bit better. And there it is. And let's go and run this now. So run it, and we're going to be able to see these values. So the biggest integer you have right there, and also the smallest integer, and the biggest long, and the smallest long. And you can see here where we were adding our different values working with decimals. Like I said, they have 28 digits worth of precision in just the decimal part. So let's go and get rid of that and get rid of that. All right. What is the biggest decimal, you may ask? Well, let's just go and grab this and copy this and paste this down inside of here. And so this is going to be the biggest decimal, biggest, B-I-G-S, and decimal. So decimal. And to get that, you're going to type in decimal max value. So decimal and max value. Max value. And if we go and run that, you're going to see this big number, and there it is. All right, so decimal is quite large. Okay, let's get out of that. And also, we're going to work with doubles. So let's just go and get rid of some of this excess. So there it is. And doubles are going to be 64-bit float types. And let's go. Did I save that? Yes, I did. Okay, so this is going to be the biggest double. And let's go get this. And we're just going to change this into double and max value. Max value. And let's go and do some more with doubles here. Let's say that let's move this over also. There we are. All right, so what else would we like to do? Let's find out how precise a double is. So we'll say we have double, and double pi value is equal to, and I'm going to copy pi right here because I don't have it memorized to numerous digits. All right, so we have our double pi value, and then let's go and copy this also so we don't have to type this out again. Paste this inside of here, and I'm just going to call this big number again. So big number. And let's throw in a whole bunch of zeros. So let's just paste this and paste that inside of there. And then after we do that, let's go and copy this big guy right here. Biggestest. I just realized I typed biggestest. Biggestest. No, that's not good. All right, so let's copy this also. And let's paste this down here to see exactly how precise these are. So this is going to be double. And I'm going to say that I want, let's go right here, and we'll say pi plus big number is going to be equal to, and then to get this value, I'm going to go get rid of all of that, go down to the next line, and I'm going to say double, and I want the pi value plus and double, and I want the big number, and there that is. Why don't we go and also do pretty much exactly the same thing for floats. Okay, so let's copy all this. And let's come down here. So first we're going to have doubles, then we're going to have floats. So we're going to say, and the difference in them is how accurate they are. So let's go and change this to biggest float, and all of them are decimal numbers. That's what every single one of them is. So that, and then we'll go and highlight this and change this into float like that. Max value, that's fine. And then we'll go and have this be FLT. So FLT, and these are not going to be as accurate. And the difference here is with floats, when you define them, you're going to end them with an uppercase F. And let's go get some more of them. So like this. So when you're working with decimals, you end those with an uppercase M. When you're working with floats, you end them with an uppercase F. When you're working with doubles, which is what you'll very, very commonly use, you're going to have nothing at the end of the definition for that. So this is going to be float. So let's just make it FLT, pi plus big number. And then we are going to just change this to float pi value. So FLT pi value and float big number like that. And let's go and run it. Oh, there's a build error. No, I don't want to change that. Oh, this should be float also. So float like that and run it. And here we're going to see more information. Kind of like that. Okay. Whoop, there we are. So you can see the biggest long. Well, it says biggest long. That's not good. Let's go back. So it's not long. It's biggest double. So biggest double. Don't want to cause confusion. So save that. Run it again. And here we are. So here is our biggest double. And you can see the biggest float. Quite a lot of difference between them. And you can also see here that doubles are 64 bits. And you can see the precision that we would get with a double versus a float, which is a 32-bit. Double precision is 14 decimal digits, while the precision on a float is only going to be 6 digits. Now, on top of these data types that you just saw, which are the most common data types you're going to be using, there are other different data types. There's bytes, characters, which hold a single character, and S bytes and shorts, and unsigned integers, unsigned longs, unsigned shorts, and you can see how large those different values are. And this is also how you make comments inside of Visual Studio, and also what you would be able to do. Let's go and get rid of everything except for this. If you would want to have a multi-line comment, you could go and put a slash with a star, and then you could go multiple different lines afterwards. Let's say you want to have other data types, and then you're going to close that off with a star and a forward slash, and that ends your multi-line comment. All right. Now, something else that is very useful is to be able to convert between the different data types. So let's go and let's create a Boolean, and I'll call this Boolean from string. You just have to make sure that whatever value you would convert into is going to be logical. So for example, you wouldn't put like a letter or something inside of a Boolean necessarily. It wouldn't make much sense. So to do this, what we're going to do is we're going to use a function that is specific to each of the different data types, which is going to be called parse. So what we want to do here is we want to convert this is going to be a string, and we want to convert it into a Boolean. So we could just throw this in here as a simple string. Let's get rid of that guy that slipped in there. So let's have this be true instead, like that. And let's go and do this with a couple other different data types. So let's go like this, and this is going to be an integer, and we're going to convert from strings into integers. So this is going to be int from string equal to, and we want it to be turned into an integer, so we put that first, and then we go parse, and then we list the string version of it. And you could also store a string inside of a variable and then just put the variable inside of here. That would also work. Let's also go and create a double, which is going to be a double value that we get from a string input. So again, you put double, what you want it to turn into, and parse, and then you could list 1.234, whatever you would like. Okay, so that is how we can convert from strings to different data types. Now let's say you want to convert a double into a string. So let's create a string, and we'll go string value is equal to, and I'm going to say double from string dot to string. And that is all you need to do, and that is going to allow you to convert from the function to string is going to allow you to convert from any double into any different string that you would like. Let's come in and let's say we want to verify this by getting the data type that this has. So we'll say something like, whoops, didn't mean to do that. Back, whoops, there we are. Let's go console like this, and we'll say WriteLine. Again, that adds a new line. And I'm going to use my $sign so I can just go and place the actual data directly inside of here. So I'm going to say data type. And if I want to get the data type of a variable, I go string value, for example, and get type like this. And there that is. And that is going to get me that. I just have to make sure I have my closing quotes at the end of it. And let's do a couple more. Let's say that I want to cast a double into an integer. This is called explicit conversion. And it's considered explicit conversion whenever you are going to be losing some data. All right, so if I convert a double into an integer, that means I'm losing all of the decimal values that are stored inside of the double. So let's create a double here. So I'll say double, and if I can type it, and we'll say double number is equal to 12.345, and then I'm going to say console and WriteLine. So there that is, and let's throw this here, and then I'm going to say integer like this, and I'm going to get the integer representation of that double value. Now, if you want to convert to any different data type, all you do is put the data type you want to convert into between parentheses before the value you're converting into an integer. So this is a double. We're converting it into an integer. All right. Then this is called explicit conversion. We are losing data whenever we complete this conversion. There's another version called implicit conversion, and that occurs anytime you convert from one data type to another in which the smaller size type is being converted into a larger type. So no data is being lost in that circumstance. So I'm going to say int num is equal to 10. And then if I wanted to go and create a long, which is bigger than an integer, I can go long num like this is equal to int num like that. And in that circumstance, you are not going to lose any data. And if we come in here and zoom in, you can see whenever we checked for the data type, it says that's a string. And you can see that integer is printed out with 12. We lost the 345, which were part of the decimal inside of our double. All right. So there is a lot of information on conversion. And what I'd like to talk about now is how we can format our output. All right. So we're going to come in here and we're going to be using console again and WriteLine again. And let's say that I would want to format this as if a value, as if it is currency. So I'm going to mark this as currency like that. Well, what I can do is between the curly brackets, I can just simply say 0:C, and it will automatically format this value to 3.455 as if it is currency. Let's go and just copy this because we're going to do this a bunch of different times. I'll show you other different ways to modify this in your output. Let's say also that we would want to pad with zeros. So let's call this pad with zeros. I can go and say that I want to have at least 4 spaces inside here. So I'm going to go D4, and I'm going to leave this be just 23 in this circumstance. I'm going to show you what it looks like whenever I output everything. Let's say that I only want to allow for 3 decimal places, even though there's going to be more provided. So I'm going to say 3 decimals. I can just come in here and say F like this and follow that up with 3. And then we can go and there's only 3 decimals here now, so I'm going to go and put another couple inside of there. And also another way we can do this is, let's say we wanted to automatically have commas added inside of it. We could come in here and go N and 4, and let's go and change this into 2300 or something like that. Okay, let's run it. And then if we come in here and look at it, you're going to see that, yes, indeed, this was converted into currency. Then on top of that, it was padded with zeros. We said that we wanted to have 4, so it filled in the rest with zeros. I said that I wanted it to be converted to 3 decimal places, and it automatically rounded it. And then it also added in all of my different commas. And as the tutorial continues, I'm going to do more with generating random specific types of output as needed. Okay, so now we're going to talk about strings. I'm going to show you a ton of string functions. And like I said before, strings just store a series of characters. Let's just create a string. Let's call this random string. And then we're going to say this is a string, right, like that. And there you are, you created a string. Now, what can we do with them? Well, we could get the number of characters in our string. So we could do something like console WriteLine. And let's go and change this. Well, let's just leave that inside of there. And I'm going to go string length. And then I'll go and get this value out of here. And I'm going to put this on through the next line. And then I'll just go random string. And then follow that up with length. Exactly like that. Let's go and print out a couple more just to get a couple things on the screen at the same time. We're also going to be able to easily check if a string contains another string. So let's just throw this here and we'll say string contains is. So we'll check if it contains is, and then it's going to return either true or false. So we're going to get rid of that, and we will say contains, and then we will check if that exists. And whenever we get into conditional statements and things like that, you'll be able to also check out that. Oh, I forgot to put a closing parenthesis. All right, so what else would we like to do? Let's say we would like to check or get the index. So maybe we went and checked, does is exist in this string? And if it does, I would like to get the index where is located. So we could come in here and we could say index of is. Exactly like that, and closing parenthesis again. Let's go and do some more. Let's say we would like to remove the number of characters starting at a specific index. Well, let's say remove string, remove string, and we just come down here, and instead of length, we're going to say remove. And we're going to say we want to remove from index 10 through 6. And let's do another one. Let's say we would like to add a string starting at a specific index. How could we do that? Well, we can go, I'm just printing these out so that we get the output, which is the actual string after we make our changes. So I'm going to go insert string, and then hopefully you'll be able to see how the string is changing as we continue. So we'll say insert add index 10 the word short. So we'll go short like this and closing parentheses. And let's say that we also would like to replace a string. So let's replace a string inside of a string. So let's go put this inside of here, and we're going to say this time replace string, and like this, and then we will show our output directly inside of here again. And on the next line, I'm going to go random string dot replace, and I want to replace the word string with the word sentence, like that, and closing parentheses. And let's go and do a couple more. Let's paste this inside of here. Let's say that I would like to compare strings. And on top of that, I'm going to show you how to ignore case. And to do this, let's go, whoops, there's string length, I already have it. So what I want to do is I want to compare the strings. They're actually characters, but they're strings in this situation. A to B. All right, so we have our output. And then after this, I'm going to say string, I have to get rid of this part. I have to say string dot compare and A to B. And then if I just did that part, it would not ignore case, but I want it to ignore case in this situation. And if I want it to ignore case, I go string comparison. Is that showing up? No, it is not. Comparison and ordinal ignore case. There we are. And I throw in my parentheses, and I think that's a good amount of information. So let's just go and run this. And if we run it, you're going to see here is our output, and string length is 16. Does the string contain the word is? Yes. And that comes back true, of course. Index of is starts at the index 2. If I wanted to come in and remove a string, you can see now that it just say this is a instead of saying this is a string. And then I inserted short string inside of there. And then I replaced the inside of our string, the word string with the word sentence. And then I did a comparison between A and B. And the way that works is whenever you compare strings, it's going to compare the very first letter inside of the string or number. Unless it is the same, then it'll continue onwards. Maybe it makes more sense to actually just show you what you'll get. So basically, if you do this comparison, you are going to see. Now you saw that it had a value of 1 when we did this string comparison. That just means they're one character apart. So basically, if you get a value that's less than 0 returned, that means that string 1 precedes string 2. If you get a 0 returned, then that means that they're equal. And if you get a value that is greater than 0, that means that string 2 precedes string 1. So that's what those individual values mean. Let's continue. And why don't I do a console, whoops, didn't mean to do that. Let's do a console WriteLine, and then let's just throw in some dashes just to break up the information that is being displayed on the screen. And then we will continue. So let's just move this up here. There we are. I can start right at the top. Okay, so let's do another one. So I'll do console write. That is perfectly fine. And what I want to do this time is I want to check if strings are equal, but I'm going to show you that also how the ignore case works. I'm going to compare an uppercase A to a lowercase a and show that they work. So I'm going to say A is equal to A. In this situation, it will. So let's throw that there. And then we are just going to say string and equals, like that. And we'll compare the uppercase A to the lowercase a. And then we'll do a string comparison again, and we will ignore case. So let's just go and grab this and copy and paste that inside of there. And then throw in another parentheses and a semicolon. So maybe let's move this down a line so we can see it, our new content a little bit better. Let's say that I would like to add padding to a string whenever it is output. Well, we can do console, and we'll do a WriteLine again. And there's WriteLine. And what I want to do with this specifically is I'm going to say, let's just type in something like pad left, and then throw that inside of here to get our output. And then on the next line, I can do random string and pad left. And let's do 20. And then we'll say that we want there to be periods inside of there. Let's also do a pad right. This is going to be very similar. So let's throw this inside of here, paste that there. And this is going to be pad right instead. And for pad right, let's just change this to pad right. So RIGH. Okay. What else would we like to try? Let's say that we want to trim white space. So that means that we want to get rid of any excess white space at the beginning or the end. So we'll go trim like this. And then I'm going to have random string. And then we just simply call trim on this. So I'll say trim like that. And also, let's say that we would like to make our string all uppercase. We'll throw this inside of here, uppercase. And then to get that, you just go random string, and then you're going to say to upper. So I'll say to upper, like that. And then we have we need an extra parenthesis. We're going to do almost identically the same thing, of course, if we want it converted into lowercase. So just change this to lowercase. And then this is going to be to lower, like that. And what else? Let's come in and let's actually go and use format to create our strings this time. So what I'm going to do is I'm going to say string, and I'll call this new string equal to, and you call string dot format. And I don't think I've used multiple variables before inside of here. So let's go and do that. So I'll say something saw a and throw. See how I have it as 1 now. And we could, this is like a Mad Lib type of thing where you just insert random words in the and throw 3 inside of there. All right, and then down here, we can jump down and we can say Paul and rabbit and eating and fields. If you don't know what Mad Libs are, they are, it's kind of a book, and it basically has, whoops, I thought that would work. All right, let's get rid of that altogether and just type it again. It's a book that just has empty spaces, and then you fill in the spaces with random words. It's like a children's book, kind of, I guess. So that's what those are. And you can also add new lines to your strings. So let's say instead of doing our normal console write line, we could come in and do write. You know, nothing shows or there is no new line added with write, of course. But you could go and add one because sometimes you might manually need to do this. That's perfectly fine. And another thing to know is there are things called escape characters. So for example, if you wanted to use a double quote inside of your string, you couldn't do that because the compiler wouldn't know which double quote was the end of the string and so forth. So we have these things called escape characters. And let's go and do a comment. So an escape character would be something like this, and a backslash with a quote, 2 backslashes if you'd like that. You also have tabs. Okay, there's a whole bunch of them. So in some circumstances, what you would like to do is use the string verbatim. That means that the escape characters are completely ignored. If you ever find yourself in the situation in which you would want to do that, all you do is put @ like this, and then you could say exactly what I typed, like that. And then you could throw a new line in here. It's just going to print as a new, it's not going to print a new line. It's going to actually print backslash and n. Now, of course, if you're having double quotes and stuff, that can cause some problems. But in general, that's pretty good. All right, so let's come in and let's look at our new content. And you can see that I was able to pad left by putting periods in there. We also padded on the right, and I said I wanted a total of 20 spaces taken up with what is output on the screen. And I trimmed the string. I put it in uppercase, lowercase. You can see the little Mad Lib thing where I inserted all the different words. And then you can also see that the backslash n showed up whenever I said that I wanted to use a verbatim string. Okay, so that is a lot about strings, and we will cover more about strings as the tutorial continues. But now I want to talk about arrays. Now, as I've said before, an array is just basically boxes inside of a bigger box. and then they're going to contain multiple different values, all of the same data type. And each item is accessed using an index or a key. And the very first index is 0, and then they increment up from there. So let's say I'd like to define an array which is going to hold, it's going to be an integer array, and it's going to hold 3 values. Arrays have fixed sizes. Very important to know that. Okay, so let's say I do something like favorite numbers, and I would say new and int, and then I would say 3. Okay, so that's how we go and create an integer array that has 3 spaces inside of it. If you would like to add a value to it, you could do something like favorite numbers and 0, and we will say equal to 23. All right, now we can also come in here. Let's say I wanted to go and get that value. So I could do console, and let's just do WriteLine, and I'll say favorite num at index 0 and go and get that value out of there. You could do so, and I just say favorite nums like that, and then I go and throw in that index that I'm looking for. Let's continue. Let's say I'd like to create another array, and it's going to contain customer names, customer first names. So I can just go string like this. I don't have to define how many spaces because I'm going to allocate all the spaces whenever the array is created. So I'll say something like Bob and Sally and also Sue. Okay, so that is how we create those using the curly brackets. You can also use var to create arrays, but the values, again, must be of the same type. So let's say I wanted to say something like employees, employees like that is equal to, and I could say new, and then I could throw in some random names. So I could say Mike and Paul. Let's give Paul an uppercase P, and let's also say Rick. Okay, so that is my list of employees. You can also create an array of base objects, which is the base type of all the other different types. How you do that is you say object like that, and then I can say random array. So this is a way around inserting values that are not necessarily of the same data type. 1, 2, 3, 4. Okay, and there we are. If you wanted to get the type, you could come in and we could say console, and let's use WriteLine again. I can say random array 0, and let's go and get this value out of here. And what I'll do is I'll say random array and the 0 index and call get type like that. And there we go. And let's say I'd like to get the number of items inside of an array. Why don't I go and just copy this so I don't have to keep, even though tabbing in isn't that big of a deal. All right, so let's throw that there. And I'm going to call this array size. So array size. And to get our array size, there is a lot of consistency inside of C#. A random array. See if you can guess what it is. It's length. And there it is. Okay. You can also use a for loop, which I haven't covered yet, so I'm just going to cover it right now. And what we're going to do is cycle through our arrays. And that's all it does. It's basically going to generate a index value. You saw that we were able to access them using our index values. And we have to define that it is an integer. And I'm going to say that we're going to start at index 0. Then you put a semicolon. Then you're going to have a condition that is going to define how long you continue cycling. Well, we're going to say we're going to continue cycling as long as j is less than the random array length. Now, if we have 3 items inside of it, they're going to take up 0, 1, and 2. If we asked for the length, it's going to be 3. So if we wanted to get the index values from 0, get the index values 0, 1, and 2, well, in that circumstance, it's going to work. So all we need to do is go random array, and then length. Look at that. And Visual Studio is so intelligent, it automatically knows what I want to do before I do it. Okay, so let's paste in our console write, and I'm going to say array, and I'll throw in 0. Whoops, I already have it in there. What am I doing? And so this is array, and then after this, let's say I want to get the value. So I'll say value like this, and that I'm going to label as 1. Then I'm going to move this down to the next line, and I'm just going to output. I'm going to leave. Now, let's change that. Let's just get rid of the whole thing. Let's go and J. That's going to give us our index value, and then I also want to get the value that is stored at that specific index. And I think that's enough information for us to go and run this. All right, and if we run it, you're going to see that I had 23 stored in the index for our favorite number array. That you could see I was also able to get a string back, and the array size is 3. And then we cycled through the array we created, and we output both the index as well as the value stored inside of it. So good stuff. What else would I like to do here? Well, we have things called multi-dimensional arrays. And let's come here and let's do another console and WriteLine and do a couple dashes inside of here just to show that this is new output. So what we're going to do is I'm going to basically create a multi-dimensional array. And whenever you define an array, you are basically saying you want to create boxes stacked vertically, okay, not horizontally, vertically in a column. Now, if you would define a multi-dimensional, what it's going to do is it's going to also create rows. So let's go and create one. So I'm going to call this string like this, and I'm going to call this customer names is equal to new, and these are going to be strings. And I'm going to say I want this to be 2 rows by 2 columns. And then after this, I'm going to start putting them inside of here. So I'm going to say Bob, and also I am going to say Smith. Okay, so I got those inside of there. Then I'm going to go down to the next line that comes after this, and let's tab that in, and let's also say Sally Smith. So I have Sally and Smith. So Smith, like that. And then we have our closing brackets, and there they are. Okay, so that's going to create a multi-dimensional array. Now, if you want to get a value inside of the multi-dimensional array, you just use indexes again, just like we did before. So let's say we wanted to go console and WriteLine, and I'm going to say I want to get the multi-dimensional value, and get this here for that, and grab this, and then we're going to get it by saying customer names and dot get value. Did it get me that? Yes, get value. And I'm going to say index 1 and 1, and then closing parenthesis, and there it is. Let's go and run that. So run it, and we're going to be able to see here that we were able to get Smith. Well, that's not very useful because there's 2 Smiths inside of there. Let's go and change that. So let's say 0, 1. Okay, let's get our different version inside of there. All right, and in this situation, it gave me Smith. What is going on here? Did I spell something wrong? Okay, let's get rid of this. And yeah, let's change this to 1 and change this to 0. Okay, so there we are. And let's run it again. And here you can see that we were able to get Sally as our output. Okay, so why is that exactly that we got Sally? Well, quite simply, what this is saying is it wants you to get row 0, or row 1, I mean. And that, remember, this is the 0 row, so this would be Sally right here. And then I want to get column 0, and this works out as column 0. Okay, so that's why we get those. Now let's say that we'd like to come in here and cycle through our multi-dimensional array. Well, we're going to do pretty much the same thing. We're going to say for int j is equal to 0. And then while j is less than customer names. And again, I'm going to get my length, all that information, all good. And let's come down here. And then what we're going to do is we're going to do basically the same exact thing, but we're going to have another index. We have two indexes, so we have to generate random indexes. So we're going to just change this to the letter K, this to the letter K, and this to the letter K. Now that we did that, we're going to be able to come in here and cycle through all of those. So let's do WriteLine, and then let's go and print those out individually. So I'm going to say 0 like this, and then I'm going to go and get the customer names. It's just going to print out first names and last names, but it's going to do that separately. So I'll say J and K, and there we are. And then at the end of this, maybe I want to do like a console and WriteLine. So I'll do WriteLine like this, just to give me another empty space. Now, if you would create an array that is going to be like, let's say you have an array that is 2 rows like that, and 2 columns, and then 3 with like a third dimension. You could think of this like a stack of 3 spreadsheets with 2 rows and 2 columns worth of data on each of the different pages, if that helps. So let's go and let's create that. So I'm going to create an integer array here, and I'm going to call it random numbers. So rand nums, and let's go and give them a whole bunch of values. So I'm going to say 1, 4, 9, and 2. Let's throw that there. Then I can actually pass an array to a function. And you've heard a lot about functions, but you've never actually created one. Let's come up here to the top of our application. And where I want to do, or where I want to put this function, I'm going to put all my functions right up here. And I'm going to actually define that this is my function area. So let's just call this functions. And then I will put another one inside of here, another comment that is going to say end of functions, like that. And then we'll throw in some new dashes, okay? So basically a function is just going to have a name. Let's go and create one. So you already saw some of this stuff. I talked about static and void and all that stuff previously. But basically, I'm going to say this is also static. What does static mean? I don't know if you remember, but static means that we do not need to create a new object for our class program to be able to call this function, okay? That's all that means. This is also not going to return a value. We're going to be doing a lot with functions here very soon. The name of the function is going to be called print array. And then you're going to have the things that are passed to it. Well, I said I want to pass an array to it. So you just say, if it's whatever the data type is for the array inside of there, then we're going to say that we want the name. These are called parameters that are passed to a function. And we're going to say that inside of our function, we are going to call this array that was passed inside of here int array. And then let's say I wanted to have some type of message that I output, okay? And then in all of your functions that you create are going to have curly brackets, and the function definition is going to be that which lies between the curly brackets. So what I'm going to do here is another way to cycle through an array. We talked about for. Well, you can also use another handy dandy tool called Foreach. And with it, you can just say int k in int array, and it automatically figures out the length of your array and only cycles as long as there is more content in the array. So we're going to go in here and say console WriteLine, and then inside of here, I'm going to get rid of this, and I will output these values. So I'll do this, and then I will output whatever message it was that is passed to the function. So we'll say something like message, and then whatever we want to output inside of there. Just something random to do inside of our code. All right, so then we have all of this all set up, and I can just copy print array, and just remember I want to pass a integer array inside of here as well as a message. So I'm going to come down inside of here, and then inside of the function, I have to pass an array. I have rand numbers, and the message I'm going to pass in front of it is going to be Foreach, like that. Let's go and actually run this because I've had a couple different things go on here. All right, so let's go in, and you can see that we printed out the customers, Bob Smaith and Sally Smith, and then you can also see I was able to cycle through all of those array values using Foreach, just like that. All right, so let's do some more. Let's go and get another one of these consoles with a bunch of dashes inside of it and throw it right here just so we can see where our new output is coming from. You can also sort arrays quite easily. So we can do something like array.sort, and we'll do random nums like this. And we can also reverse a array. This isn't going to put them in reverse sorting order. It's just going to reverse them. So I'll do random nums like that. And let's throw that in there. You can also get the index of a match inside of an array. So let's do something like console and WriteLine. And I'm going to say 1 at index. And let's go get this value returned. And I'm going to say array dot index of, and pass in random numbers and 1. And yes, I need another parenthesis there. Let's say I'd like to change the value at an index. So let's go random nums. There we are. And let's do set value 0. So 1. There we are. And what else would we like to do? Let's say we'd like to copy part of an array to another array. We could do, let's create another integer array, and let's call this source array and equal to 1, 2, and 3. There we are. Whoops, hit the wrong thing. There are curly brackets around that. And then let's create a destination array. So I got that and destination array. Let's make this TEST array. And to get it, we're going to go like this. And I'm going to say new integer and 2. And I'm going to say that I want to start at a specific index. So I'll have this be 0. And then I'll have another one. And it's going to be length is going to be equal to 2. Then what I can do is I can copy values starting at index 0 and up to a total length of 2 spaces. Let's move this up here a little bit. Just by going array and another array is equal to array and create instance. Good, got it. And this is going to be type of, and it's going to be int. And then I'm going to put 10 inside of here. Now we can take all of that information and let's go and actually copy it. So we'll say array.copy like that. And it's source array, starting index, destination array. And we're going to start at the 0 index and the length of that item. And let's go and print our array just to see all of the changes that we have. So destination array. And let's also print copy inside of there, just as a message. What else would we like to do? Let's say we want to, there's another way we can create an array, and that is through the use of create instance. So we just say this is an array, another array, let's call that, and is equal to array dot create instance, and we have to tell it what type it is. So I'll say type of int, and then the length is actually going to be 10. So let's just change that to 10. And let's say also that we'd like to copy values in our source array to a destination array. Well, we can do that also. So we'll say source array and copy to another array and 5. And then let's cycle through all those using Foreach again. So I'm going to say Foreach, and this is an integer. Let's use m in another array. And then after that, we will just output all of these to the screen. So I'm going to say console WriteLine, and I'll say copy to, just so it's a little bit easier to see where this information is coming from. And we will throw m inside of there, and of course close that off. There's so many other things you can do with arrays. Let's run this. It's starting to get a little busy. Okay, so you can see how all of these are going to work. So one at index, you see we get a value of 3. You see we were able to copy those. You saw that we placed values starting at index 5 inside of there, and also that there are 0 values in all of the other individual places. Whenever you create an array, it automatically has default values of 0, which is also important to know. All right, good. And let's try one more example. Let's say we would like to search for an element that matches a specific condition that we have defined. So let's create another integer array, and let's have this be number array is equal to, and we'll get into like Lambda functions later on. Don't worry about what that means right now. That'll allow you to do all kinds of string manipulations. But let's say console, and let's do WriteLine, and let's say that we would like to get values that are greater than 10. Okay, grab that, and then it's going to insert those array values. So we'll say array and find, and you pass it whatever you're searching for, number array, like this, and then you have to put your condition inside of here, which is just simply greater than 10, like that. So that's pretty cool stuff. All right, so that is a lot of information on arrays, and I'll be covering, of course, more with arrays as the tutorial continues, but now I want to talk about conditionals, and specifically if, else, and else if. All right, so whenever we are using conditional statements, there's two important ideas you have to understand. There are relational operators. This, of course, is greater than, less than, greater than or equal to, less than or equal to, and not equal to. Now, in some circumstances, you want to stack, or you want to perform multiple different relational conditionals. And whenever you want to do that, you use and you use or, and you use not whenever you want to convert trues to falses and falses to trues. That's why we have those. All right, so let's go through an example. Basically, what I'm going to be provided with in my program is an age, and let's have it be 17. And what I want to do is I'm going to say if the age is greater than or equal to 5, and, so I want to have multiple conditions inside of here. So I'm going to say, and the age is less than or equal to 7. Well, in that situation, I'm going to tell the student to go to a specific type of school. So it's going to output either elementary, middle school, high school, college, or it's going to say retire or something like that. All right, so we're going to say WriteLine, and we're going to say go to elementary school in this circumstance. And let's throw in, there we are. Okay, so it's going to do this, and it is going to output that if those conditions are indeed true. Now, we also want to do if the age is greater than 7, then we want to do something different. Age is less than, so we're getting rid of the equal sign in this situation, and we're going to change this to 13, exactly like that. Well, in this situation, the student should go to middle school, so we'll say middle school. And we're going to have another condition. And this condition is going to be if their age is greater than 13 or less than 19, like that. In that situation, they're going to go to high school. So high school. And then if as a default, what we can do is we could say else, and this is going to handle every other condition that we could have, age-wise anyway. We could say go to college in that circumstance. And let's close this off and close that off. All right, and there is that situation. And we could also come in here. Why don't I do another, just so I can demonstrate or. So if we have something like if, this has nothing to do with this string of conditionals here. One of these is going to be picked. But what I want to do is just demonstrate or. So we can say something like if age is less than 14, or if age is greater than, say, 67, we could say something like you shouldn't work. Okay, so this has nothing to do with school. It's just like something random. So we'll say laws will not allow you to work or something. I don't know. So it says to console, obviously you can work if you're over the age of 67. I'm just throwing some ideas inside of here. So here we are, and you could say you shouldn't work. Go retire, or if you're under 14, whatever. Okay, I don't know how I accidentally slipped into the world of trying to explain when somebody could work, but we did. Okay, so let's do another WriteLine here before we get more confused, and I'll also demonstrate not. So let's go something like not true. It's just going to turn trues into falses and falses into trues. That's what it does. So we can do this. Oh, and another thing you can do is you can go and add, you can put a plus sign inside of there if you so wish to get combined strings here for output also. So there's something else we're able to do. All right, good stuff. And if we go and we run this, you can see that we get a result over here that says go to high school, and it also turned a true into a false. And the reason why we didn't get any output for the other one is because the age is 17 right here. And that means that person should work. Another conditional you're going to likely come in contact with is what is called a ternary operator. And it's best to see them in action to understand them. So let's say you would want to assign one value depending upon if a condition is true or another value. So you're going to list the value is going to be stored in can drive. So we're going to say if the age is greater than or equal to 16, and then you're going to put a question mark. If this condition comes back as true, it is going to assign the word true to can drive. And if it comes back as false, it's going to store false inside of there. So that is a ternary operator. And another way of doing pretty much exactly the same thing that we just did with if and else if and all that is with switch. And switch is used whenever you have a very limited number of options. And so let's go and show you another example. So we'll say switch like this, and we'll throw age inside of here. And then after that, let's just move this up here. We're going to say case 1 and case 2. Whoops. Case 2. Like that. And this is going to match both. If their age is 1 or 2, it's going to output this specific piece of information, this specific string. We can say go to daycare, something like that. Both of those are going to work. And then if you want to break out of the switch statement and never check anything else afterwards, you put break. And there that is. Let's do another set of conditionals. This is going to be almost exactly the same. So let's just copy this and let's just come right down here. Whoops, back there, throw that there. Now this is going to match 4, 3, and 4. So we'll throw those inside of there and we'll say something like go to preschool. Preschool, like that. And again, the break statement does the same thing it did before. Let's throw in another situation. We'll say case 5. Well, in this situation, we're going to say that we want our student to go to kindergarten. So we'll say go to kindergarten, like that. And then we could come down here and just have a default value. And this is going to be if nothing else comes back as true. And if that happens, we are going to say, go to another school, go to another school. We're fed up and we just want this to have some output. So we'll say, go to another school. And another thing you can do is you can also jump out of a switch statement with go to, and it will jump to wherever. This is bad practice. Don't do this, but I'm just showing it to you just in case you ever see go to somewhere. You could have other school like that. And then what you could do down here is say other school, and it's going to jump to this keyword down here. And in this situation, we'll go console and WriteLine, and we'll go elementary, middle, have them figure it out. High school, that's good enough. Okay, so high school and good stuff. So there it is, all right? And that is how goto works also. And let's go and run this. So boom. And oops, no, I don't want to run it. Where do I have a bug? And I don't know. Let's see here. Where is it at? Oh, I see. I forgot to put break inside of here. Whoops. Break. There it is. And now it'll go away. And now we can run it. And we can see our output here is it's going to another school, and it lists elementary, middle, and high school. Okay. Good stuff. Another thing we can do is you can compare strings using equals. Another thing that is useful. So before we fall out of this, let's just come down here and let's go and create two strings. So I'm going to call one of the strings name2, and I'll have that be Derek. And then I will have another string, and it's going to be called name3, and it's also going to be Derek. So let's throw that inside of there. Okay, so we have those two. We can say something like if and name2 and equals, like this, name3. And I'm going to do an ordinal comparison with these. I'm going to say something like string and comparison. There it is, like that. And ordinal. All right. And do I have that covered? Yes, I do. So in that situation, I can say the names are equal. Console dot WriteLine and names are equal. And it's going to come back as true indeed if we run it. And names are equal, of course, does show up inside of there. See, names are equal. All right. Forgot to show you that before, and I'm showing it to you now. All right, so good stuff. And now we're going to get, I know we covered looping, but I'm going to get more into giving you a couple more examples so you completely understand it. And we're going to start with the while loop. Okay, so now let's talk about the while loop. Basically, you use a while loop when you want to execute as long as a condition is true. And what I want to do is I want to create a while loop that is going to cycle through numbers, and it's only going to print out odd numbers. Now, with while loops, your index, like we had with the for loop, is actually going to be outside of your looping structure. Then you're going to have your condition, and I'm going to say while I is less than or equal to 10. So I want to print those values out. Then what I'm going to do is I'm going to say if and I modulus 2 is equal to 0. Well, in that situation, we know we have an even value. So I do not want to, I don't want to print that out. So what I'm going to do instead is just increment that value. And then what I want to do is I want to jump back up here where the while loop starts and continue incrementing. Now, of course, with I having an increased value. And how you do that is if you want to not continue executing what is in the while loop, you just say continue, exactly like that. All right, so if this condition is not reached, then we do want to print. But let's say on top of that, if we ever get to a value where I is equal to 9, we want to jump out of the loop and not check anything further. All right, we can do that also. We can say if I equal to 9, well, I want to break and stop executing the while loop altogether. So I'm going to jump down here, and the while loop is no longer going to execute. But, however, I said I wanted to print my odd numbers, so I'm going to say console, if I can spell console correct, and WriteLine, and then I'm just going to output that value, and then I'm going to say that I want to increment the value of I because I want to get to the even value, and so forth and so on, and proceed through what we were doing here before. All right, so good stuff. Let's go and save that, and if we run it, you're going to see that it does indeed print out those even values right here. Okay, so 1, 3, 5, and 7, but it doesn't print out 9. Why? Because of our break statement. All right, so good stuff, and there is an example of a while loop, which you will see more of as we continue. Now what I want to do is I want to talk about a do-while loop. And you're going to use a do-while loop whenever you must execute the code at least one time. So what I'm going to do here is I'm going to institute like a guessing game. So I'm going to say random and new rand is equal to, I want to generate a random value. So I say new and random like this. Whoops, how'd that happen? All right, so there we are. And what we're going to do is we're going to create a secret number. So secret number is equal to rand.next. And then you put inside of here the minimum value and the maximum value you want to generate. And then I'm also going to have the number that was guessed by my user. So I'll say number guessed is equal to 0. And then I'm going to output onto the screen console WriteLine, and I'm going to say random num like this, and I am going to say secret number like that, and then close this off with a parenthesis, and there we go. Now with the do while loop part, the guy that we're here to talk about, we're going to say do, and the condition's actually going to come down here after the loop has been executed at least one time. So we're going to say we want to continue looping as long as the secret number is not equal to the number guessed, right like that. And then you have a semicolon here at the end. So inside of the do part, we're going to ask the user for a number, and we're going to say enter a number between 1 and 10, like that. And that is going to allow them to now receive a value. All right, so we're going to say number guessed is going to get the value, and we are going to convert this from a string into the value they enter that they provide to us is always going to be a string. So we want to convert it into an integer. And something else I should have mentioned up here, it goes up to 11 but doesn't include 11. Sorry if I didn't say that. I don't think I did. Okay, so there we are. It's amazing how quickly it gets that. All right, so it's going to convert this string that it reads from the user and converts it into an integer. And it's going to continue on. Then what we're going to do after the do while loop ends, we're going to say console and WriteLine, and we are going to say something to the effect of you guessed it, it was, and whatever. All right, and then we'll go and throw the value inside of there, which is going to be our secret number. There we are, and there we go. On top of this, just to save time, I am also going to print out the random number. Oh, yeah, I got that there. Okay, so good stuff. Let's go and run this now. And you can see right up here, we have our values. So it says enter a number between 1 and 10. I actually have to go outside of here to be able to provide this value. So I'm going to say 5, and that didn't work. So you can see we have a value of, it just didn't tell us anything. So now what I got to do is just continue entering values until I guess it. Whoops, and oops, I accidentally hit enter, which caused an error. I hit enter 2 times. So let's run that again, and let's do it right. All right, well, I'm just going to have to do this the long way. So 2, 3, 4, 5. There, I got it. And so our number was 5. And we could do other cool things like we could say higher or lower and things like that. I'll leave that for your homework. And there we go. So there is a useful example of how we can use a do while loop. Now what I want to do is I want to briefly talk about exception handling to ease you into it, and then I'll get more into exception handling later in the tutorial. Basically, we use exception handling to catch errors that could crash our program. So let's say we're going to do a division by 0 problem, and we are going to handle it. So let's say we have a numerator of 5 and a denominator, which is going to be number 2, which is going to be equal to 0. Okay. Now, what I want to do here is you're going to have to surround all of the potential problems in your code with what is called a try block. And what we're going to do here is I'm going to say console and WriteLine, and I'm going to say 5 divided by 0 is equal to, this is going to throw an error, and we are going to catch it. So we'll throw that right there, and then down here, and then I'm going to call a function, get more into functions here in a minute, called do division, like this, and we will pass a number 1 and a number 2 inside of it. So let's come up here inside of our function area, and static, again, what's that mean? It means we don't have to create a specific object of type program to be able to use this function. Okay, then we'll say double x, and we will say double and y. All right, and what I'm going to say here is if y is equal to 0, then what do I want to do in that situation? Well, I'm going to say that I want to throw an error, and I'll say new system, like that, and dot, and this is going to be a divide by 0 exception, and close that off and throw a semicolon inside of there. And otherwise, that means there is no error, no potential for an error, and we will say x divided by y. There's our function. Pretty simple stuff. So now we will come back down inside of here, and we will catch this error down inside of our main function. We always have to, if you have a try, you have to have a catch. So I'm going to say catch, and I'm going to catch the divide by 0 exception, and ex, and then I'll come down inside of here, and I could say something like you can't divide by 0. So let's get this. Whoops. Let's come down here, get that out of there. And I'll say you can't divide by 0, like this. And then if I want to get some additional information on my exception, I can say console and WriteLine. And let's say that I want to get the message. That's good, like that. So let's get that and output that. And then on top of that, let's also say I want to get the name here. So that's good. And get rid of this part right here. I'm going to say get type, like that. And then I'll say dot name, like that. So we know this is going to throw an error because you can't divide by 0. All right, and more. So let's come down here. We can catch multiple different exceptions. Maybe something else happened. This is the default exception. You shouldn't use this unless you use it last, and because this is going to catch every single potential problem, and we want to try to work with problems that we expect so that we can easily solve them rather than completely crashing the whole program. So we're going to say WriteLine, and typed in console 2 times. Let's get this out of here. So there that is. And I will say WriteLine, and I'll say something like, well, I don't know anything because this catches every single possible problem. So I'll just say an error occurred, like that. And then let's go and get some more information. Let's say that I want to get the same information. So let's grab this, copy that, and we'll paste this down inside of here. And there we go. Then after we have all of these exceptions caught, if you ever always want to provide some type of cleanup Like, for example, let's say you had a database connection open and you want to close the database always, no matter what happens, whether we have this exception handled or not. Well, what we're going to do is inside of our finally block, this is always going to execute, and we are going to go and just simply put out a message that says cleaning up, and whatever cleanup is done will be done. All right. So there you go, an example of using exceptions. And whoops, there's an error. I do not want to build it. Okay, so where's our error at? Do division. What's wrong with this? Okay, I see. Like this, and throw that there. Wait a minute. Okay. Oh yeah, that's gonna work. Okay, good. Let's run it, and you can see here that we do indeed have a problem. It says you can't divide by 0. It prints out the exact exception name that triggered it. And you can see here also that cleaning up shows up there. And there you go. That's a quick example of exceptions, and I'm going to cover them more later on in the tutorial. But now I want to talk about string builders. Okay, so of course you wouldn't know this, but every time you change a string, what you're actually doing is creating a brand new string. And this is very inefficient, especially if you're working with large blocks of text. And string builders, however, actually allow you to change the text directly in memory rather than making a new copy. And how we create one is we say string builder. There it is. And I'm just going to call this SB is equal to new. And whenever you create a string builder, by default, they have a default size of 16 characters. But what's good about it is they grow automatically as needed. So we're going to say string builder, and like this. And then let's just throw some text inside of here. So I'll say random text like that. Okay, so we have that. Let's make that uppercase just so it looks fancier. Okay, let's go now, and let's say that I wanted to build a string builder that has a defined size. Well, it's almost exactly the same as what we have here. So let's say we want to paste this inside of here, and let's just call this string builder 2, new string builder, and let's throw some different text in. So we'll say something like more stuff that is very important. Okay, and let's say that we want our default size in this situation over here. Whoops, put that over there. Let's move this out here. We don't even use this. Let's just get rid of it altogether. All right, now we got more screen real estate. So I'm going to say important, and I'm going to give it a size of 256 characters instead of the default 16. All right, now we can go and get our default size from this, or get our, well, let's say we want to get our maximum size. So I'm going to say that I want to go console and WriteLine, right like that. And I am just going to simply come in here and change this guy right here. And I'm going to do something like capacity, and then this, and output that. And to get that capacity, this is the default size for our string builder we pass in, or our maximum size, I mean. So here is capacity, so T, there we are. We can also come in here and get the length of the text stored inside of it. Boom. And let's see if you can guess what that is called. If you guessed length, you are correct. So let's go length and throw length inside of there as well. You can also add text to a string builder. So let's come down here. How you do that is you go, let's go string builder 2. We can say append line, and we'll get this, and we'll throw in a new line, and more important text is going to be placed inside of there, right where we have that. You can also define culture specific formatting. So let's go culture info, and we'll do English US is equal to, and culture and info dot create specific culture. And we're going to use English US in that circumstance. We can then append a formatted string. Let's go and create a new string inside of here. So we'll go string and best customer is equal to, and we'll say Bob Smith, and then sb2 dot append format, and we'll use English US, and on top of that we'll say best customer and put old Bob inside of here. There we are, and there he is. He's our best customer, and close that off. We can also output a string builder. So we're going to do console, WriteLine, same stuff as before. And we're going to say sb2.toString. We're going to use toString a lot. And close that off. What else would we like to do? Let's say that we would like to replace a string. We can say sb2.replace, and we'll do, let's say we want to replace text with characters. And what else? Let's do another console out and toString to show how that changed. So we'll just copy this, paste that down inside of there. You can also clear a string builder. So you do that by saying clear. There we are. And we can also then go and do some more. Let's append another one just straight away by saying sb2 dot append, and we'll do random text like that. We can go and check if string builder objects are equal now, and we'll say WriteLine, WriteLine. And to do that, we go and get the string builder name we want to compare, follow that up with equals, and then the string builder we want to compare to. And there's that. What else would we like to do? Let's say we would like to insert another string at a specific index. We could say sb2 dot insert at index 11, and what we want to put inside of here is that's great. And anything else? Yeah, let's go and also print out our string so we can see it again. So WriteLine, we don't want that. Let's do this one right here. Whoops, let's grab this one right here. Copy that, throw that down inside of there. And what else would we like to do? Let's say we want to remove a number of characters starting at an index with a length. We can do sb2 dot remove 11 through 7, and then let's go and output our new string again. So let's go copy that and our new string builder. There we are. So there's a whole bunch of different things. Let's run it. And we typed everything in correctly. And you can see here our capacity, which is the maximum size, 256. Our length was 33. That's the number of characters inside of it. And then you can see the multiple different changes we made as we went and manipulated our string builder. So string builders, as you can see, are quite easy to work with. And of course, they will also be covered a little bit later in the tutorial. But I've been beating around the bush here and doing a little bit here and there with functions. So now I want to cover functions. All right, so as you have already seen as we've been coding along here, functions are basically going to allow us to avoid code duplication. It's going to provide much better organization, and later on in the tutorial you're also going to see that they are also going to help us simulate different systems. And the basic layout for a function is going to be like this. You're going to have your access specifier and access specifier. You may say, what is an access specifier? Well, let's go and look at that a little bit closer. Access specifier is going to determine whether the function can be called from another class. If it's marked as public, it can be accessed by another class. If it's marked as private, it can't be accessed from another class. And if it's marked as protected, it can be accessed by another class, or it can't be accessed. Let's put can't. How did I do that wrong? Can't be accessed by class, but it can be accessed by a derived class. And that means, don't worry about it. Whenever we get into object-oriented programming, I'll cover protected in more detail. But basically, that is all you need to know about it right now. So that is what our access specifier. Just think, it's either public, meaning it can be accessed from another class, or private, which means it can't be accessed from another class. All right, so just know that. Then what do we have? We have the return type. You've already seen void. That means we're not returning anything. This could be an integer. Let's say we do some type of addition or something. That's the return type. Then you're going to have your method or function name. Functions are referred to as methods, and methods referred to as functions. We'll get more into that when we get into classes and such. Don't worry about it. Parameters, we've already talked about that. These are values that are passed inside of functions. And then you have your curly brackets and the body of the function inside of there. Let's go and create a function. Okay, so here's where we have all our functions right here. And let's create a function that is what you've seen before. So we're going to have static. I've already talked about private, talked about static. Void, what's that mean? It's not returning anything whenever it's done executing. And hello, say hello. All right. So this is something that we've already defined. We've used this code already previously in the tutorial. So inside of this function, we're going to create a variable. This variable exists only inside of this function and nowhere else. I'll show that through examples as we continue here. We're going to have it be name, and we're going to say that it has no value. All right. So what's this going to do? It's going to say, what is your name? So what is your name? And like this. And let's do write instead of WriteLine so that it doesn't skip to the next line. What is your name? Da, 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 da. Good stuff. All right. So now what I want to do is I want to save whatever they have entered inside of here. So I'll say console and read line. Good stuff. And then I'm going to say console like that and WriteLine. Let's do WriteLine instead. And I am simply going to say to the user, hello, and whatever that user's name is that they just provided to me. So I'll say name like that. Okay, so there we have our function. And how do we call it? We just say hello exactly like this down inside of our main function, and it executes, and it's wonderful. Let's run it. And I'm going to type in Derek here like that. And now you can see the input. So it says, what is your name? And I type Derek, and it says, hello, Derek. Okay? Very, very simple type of function. Let's go and get a little bit more complex now. So let's create a function that adds values. Let's just get rid of this. We don't need this anymore. And let's get rid of this, of course, because the function doesn't exist. All right. So let's say that we want to create a function here, and it is going to be passed two values, and it is going to sum them. So I'm going to say static again, double, and let's call it getSum. And you have to define the type for the value passed inside. You can provide a default value. If you do that and they do not provide a parameter value, then it's going to use this default value. We say double y is equal to 1. So we're going to have both of them be 1. And now what we can simply do is just come in here and say return and x plus y. Exactly like that. And that's going to work out wonderful. And then we can come down here to our getSum part, and we can call for this to execute. So we're going to say that we want to create a double, and it's going to be x is equal to 5, and then another double, and y is going to be equal to 4. And then we can go console like this, and then we can go and call our function. Let's get this out of here, and we will instead say that, well, let's just call it x is going to be, well, let's not do that. Let's do a little bit fancier. We'll say 5 plus 4 is going to be equal to, and whatever our value is, like that. And then we will simply say get sum, call our function, pass in the values for x and y. Exactly like that. And if we do it, what is wrong here? Oh, I need another parenthesis. There, error went away. Let's run it. And you can see here that yes, indeed, we got 5 plus 4 is equal to 9. Okay, so that's how we can pass parameters in and also return values on top of that. Something that's kind of interesting, let's say that we went up here and we see we have a value of x here and a value of y here and x and y down here. I just want to demonstrate something. You would never do this in a million years, but I just want to demonstrate actually changing these values. So I'm going to do something like double temp is equal to x. Okay, so we have that. And then what I'm going to do is I'm going to say x is equal to y, like that. And then I'm going to say y is equal to temp. Okay, so in this circumstance, I change the value of x to the value of y. All right, now I have x and y down here also. So does that mean that those values are going to be switched down inside of here? Well, let's go and find out. So let's come down and just simply output this. So I'll say console and WriteLine, and we'll say, hey, what's the value for x? Because we changed it in the function. Does that mean it has been changed outside of the function? Does that make sense? Let's go x like this and like that, and save it and run it. And we can see that, see, x is a value of 5, but in the function we changed it to 4. What does it do here? It stays the same. Whatever happens in the function stays in the function, and it is not going to be changed. So what is happening up here is x is actually not being passed inside of it. Only the value for x, which is 5 right here, is being passed. So this name x here is a completely different x here. And it's very important to understand that just because they have the same names does not mean that they are going to work in exactly the same names. Another thing that's very interesting, let's get rid of this, is you can actually have a parameter passed and then have its value assigned inside of the actual function that you're working with. Let's get rid of this. That sounds confusing. Let me show you an example. So let's put this up here, and then we're going to create a function. And what we're going to do is it's called an out parameter. So we're going to say static. You may never use this, but I like to cover everything. So I'm going to call this double it, and it's going to be passed int and x, and then I'm going to say out like this. This is actually used in database programming very often, which is probably where Microsoft got this idea. So what this is going to do is it's going to have solution be equal to x, let's just go like this, times, whoops, hit the wrong button, times 2. Okay, so that is defined right there. And what's cool is we're actually assigning the value of the solution here inside of our function. Then what we can do down inside of main, whenever we call this, I can keep that on the screen, I can actually come in and I can go double it like this, and 15, and out solution like that, and pretty neat. And then what we'll be able to do is say console and WriteLine like that, and I'll go and put quotes and I'll say something like 15 times 2 is equal to, and throw that there, and this here, and then say solution right like that. So pretty cool. Oops, I forgot to define solution outside of here. So let's go solution like that. Oops, that's fine. And then let's run it. And you can see that it actually is able to work. So we were able to double that value that was passed inside of it. So pretty neat stuff. Another thing that's cool is we've always passed values, but it's actually possible to pass by reference so that you can actually have change the value inside of the function and have it change outside of the function as well. So let's say we have something like int number 3 is equal to 10 and int number 4 is equal to 20. Well, we can go and create a function. So first off, what I want to do though is I want to say console and WriteLine, and I'm going to do before like this, before swap, and I'll say number 1 is equal to hit that there, and number 2 is going to be, I'm I'm going to output both of these values and then change them, and you'll see how they change. So I'll say number 3 and number 4. So that is before any changes have been made. Now what I'm going to do is I'm going to create a function called swap. And what it's going to do is it's actually going to swap those values, and the swap will actually, basically the value for 20 is going to be assigned to 3 down here inside of main. So how you pass by reference, I'm going to make this public static void like this. My function's called swap. How you pass by reference is you go ref like that, and now you have access to the value outside of your function. I'm going to do the same for both of them, int and number 2. And let's say, whoops, let's make this will be 3 and this will be 4 in this situation. And then I'm just simply going to go and swap the values. And this is an interesting concept to understand, especially later on whenever we start getting into algorithms and things like that. So I'm going to take number 3, I'm going to store it in a temporary value. Then I'm going to get number 3 and assign it the value for number 4. And then I'm going to store the value of temp back into number 4. All right, so neat stuff. Now what I'm going to be able to do is come down inside of main. I'm going to call that swap function. So I have to go exactly like this. They're passing a reference of number 3 and number 4 to the swap function. And then what I can do is get this guy, copy this, and you're going to see how the values have been changed outside of the functions. We'll call this something like after swap, and you can see those stay exactly the same. And we can go and run this, run it. And indeed, if we zoom in here, you can see the value before the swap, 10 and 20, and after the swap, they work out, or they are maintaining their change even outside of our function. Another thing is you can also use a variable number of parameters passed to a function. So let's say you don't know how many different parameters are going to be passed. That's perfectly fine. We are going to just come in here and be able to accept any number. All right, so just understand that, well, let's just go and create it. So this is going to be, it's going to return a double in this circumstance. So I'll say double, and let's call, we used get sum, let's call get sum more like that. And we are going to just pass in an array, and it has to be called params like that, and double. And then I'm going to call the name of this is actually going to be nums. Just understand, if you have any other parameters that are not going to be infinitely long, this part right here always has to come last. All right, that's all you need to know. Get rid of that. And we're going to say double sum is equal to 0. And then we're going to use our for each block to come in and say int I in nums. The nums part was passed inside of our function. And then we'll just sum all these values that are passed inside of here like that. And then we can come in and go return and sum. There it is. Good stuff. So now what we can do is we can come down here to get some more. Let's copy get some more. And no matter how many values we pass inside of here, it's going to work. So we'll say get some more, and we'll say something like 1, 2, 3, and that will work. Why don't we go and print that out? I think that works a little bit better. So we'll say console. Whoops, console didn't work in that situation. Let's get this out of here. Console and WriteLine like that. And we'll say 1 plus 2 plus 3 is equal to, and then we'll go and get our value that is going to be returned to us from our function. So let's go here, and then let's go and get some more. So we'll copy that and paste that right here. Well, I should have got rid of that. Let's get rid of it. There it is. It's gone. And throw that right there. All right, good stuff. And then we can go and run it. And it doesn't matter how many values we put inside of there. It's always going to work. As you can see, 1, 2, 3 is equal to 6. All right, good. All right, and we can close that and keep on going. Another trick we have here is we're actually able to pass in our parameters in any order if we use what are called named parameters. So let's create another function, and I'm going to call this print info. It's going to receive a name, and it's going to receive a zip code like that. All right. Now what I'm going to do is I'm going to say console and WriteLine, and I'll say a little bit like that, lives in the zip code, 2 words or 1 word? I don't know. It's 2 words in this circumstance. There it is. And then we'll come down here and we will output both. So we'll say name and zip code. All right. Now what we're going to do down here that's going to make this a little bit weird is we're going to call these out of order. I'm going to pass the zip code first, even though it's second, and the name part second, or the name part second. All right. So we'll go print info. There it is. And how we use named parameters is we can say zip code like this, and 15147, something like that. And then we will say the name like this, and we will say Dark Venice. And there it is. There it is, and run it. And you can see that it's still going to work even though they're out of order. See? There you are. I do not live at that zip code, but either way. And so there's named parameters and how they work. Now, another thing that's really cool, and let's get rid of this, is that we are also going to be able to use what's called method overloading. And what that means is that we are going to be able to create functions with exactly the same name, but they can actually be passed different types of parameters. So let's create data types. You'll see. Okay, so let's go, and I'll have this, and I have a function called getSum2, and let's say that it receives a double. It has a default value of 1, and another double, y is equal to, give it a default value of 1 again. And what it's simply going to do is it's going to return x plus y. All right, so very simple, easy to understand. Now let's say that we also want this function to be called and can receive strings. We can set it up that way. So let's just change this to string. And let's change this, quote that, whoops, 1 like that, and change this to string. And now the same function name is going to be able to receive either strings or doubles. Either one will work. And then down here, what we're going to have to do inside of our function is to convert these into doubles. So I'm going to say double, and I'm going to call this double x. So get rid of this part. So we'll say double x is equal to, and we'll say convert to double. You can use all these great functions. And then we'll also do the same for y. So we'll go like this, paste this inside of here. And we'll say double y is going to be equal to, and let's convert this from a string into a double. And then what we'll be able to do is quite simply just say double x plus double y, exactly like that. And then what we'll be able to do is inside of our main function, we're going to be able to pass these inside of it. So we'll go right here, and we'll say console and WriteLine, and then we will say 5.0 plus 4.0 is going to be equal to, and whatever the output is for that, and then we will call getSum2, and then we can say 5.0 and 4.5. So in this circumstance, we're passing a double inside of it. Why didn't it print that? There we are. Okay. Also, however, we're going to be able to pass inside of it a string representation of both of these. So let's highlight these, and whoops, 5.0 and 4.5, and they are also going to work, 4.5, exactly like that. And if we run it, you're going to see that, yes, indeed, we are going to be able to work with strings or doubles with our great function. So, or overloaded functions. Okay, so there we are, and good stuff. And for right now, that is all we're going to do with functions. Much more is coming up, however. And up next, I'd like to talk about date times. All right, so now let's talk about date times and time spans. Now, I am going to create a date time using probably the most important date in history. I'll say date time like this, and then you define your year, and then your month, and then your day, exactly like that. And then what we'll do is, let's say I wanted to get the day of the week. I could do something like, whoops, console and WriteLine, and we'll just say day of the week, and go and get this by simply coming in and saying awesome date dot day of the week, day of week, like that. And there we go. Oops, forgot to put the parentheses in here. There we are, and now that's fixed. All right, let's do a couple more things before we output that. You're going to be able to change values. So we could do awesome date is equal to awesome date, add days, look at that. And let's change that to 4. And then let's say awesome date and equal to awesome date. And we'll say add months. Where's months at? There it is. Add months. And we'll change this to 1. And let's go and let's just copy this. So I'm going to copy that, paste this inside of here. And I want to add years. So I can say years, and let's add just 1, whatever. That's perfectly fine. And then let's come in here and copy this and output this. And let's just get our new date. So I'll say new date like that, and then go awesome date, and then just call for date to get that. All right. What else would I like to do? Well, let's talk about time spans. They can be used to define a time. So we could say time span, and we could say something like lunch time is equal to new time span. There it is. And let's go like this. And then let's just change this to 12. And let's change this to 30 and 0. And we don't need the additional time one there after that. And what else can we do? Well, we can go and change values also. So we could say lunch time, there's lunch time, is equal to lunch time. And let's say we want to subtract, and we're going to create a new time span. So we'll say new and time span, and we'll go and just have this be 0 and change this to 15. So 15 like that. And then let's come in and output that. I think I have, yes, I still have that. So we'll say new time, output that. And then we'll use lunchtime and convert this into a string. So we'll say lunchtime dot to string like that. And throw in another parentheses. And I think everything looks good. And let's go and run that. And there it goes. So if we zoom in here, you could see the day of the week on that specific day was Saturday. And you could see here all our first date, and then also our time span and how we were able to change it from 12:30 to 12:15. Okay, so a couple little things to mess around with there, and you should just go in and play around with it if messing around with date times is important to you. Otherwise, I'm going to briefly talk about enumerated types. And like I said, we're going to go and define enumerated types is whenever you want to create a data type that is going to be of a limited number of possible values. and they are going to operate kind of like with key value pairs. And basically why you would use them is they allow you to use symbolic names to represent data. And so what we're going to do is we're going to, let's come up here, maybe right here after our function area. And we are going to define some different colors that are going to be available for our fictional car. So we'll say, caps lock, okay, car color, like this. And that is going to be the name of our new custom type. And we are going to say that that it is represented with a byte. And then we just do key value pairs. So we'll have orange, and we could have it be 0, or we could actually come in and give it a value of 1. And what it'll do is automatically increment then for all of the other different enumerated types that you have. So you don't even have to put them in there. Blue will automatically just be 2. And we're going to say that we want green, and also that we want red and yellow. There we are. And then after that, let's put this onto a separate line. And while we're up here, why don't we, inside of our functions area, actually create a function that works with enumerated types. So I'm going to say static. What this is going to do is it's going to output the color that is represented with what we pass into it, the enumerated type car color, and it's also going to print out the code, which is going to be like the 1s and 2s and 3s and 4s. So we're going to go static. It's going to print it out. It's not going to return it. And we'll say paint car, and it's going to get a car color passed inside of it. Let's just abbreviate that as CC. And then inside of here, we're just going to do a console WriteLine like this. And then we'll say the car was painted, and this is going to output the actual color, and the code is going to come after that. And let's come down here and on to the next line. And to go and get the color, by default, it just is whatever the variable's name is. And then to get the code associated with it, you just convert that into an integer, right like that. Okay, so let's play around with these. All right, so we'll go down inside of main. I'll go car color, and let's just call this car1 is going to be, and if we want to assign one of those enumerated types, we go car color dot, and let's make it blue. And then we can call our custom function that we created, paint car, and there's paint car, and we want to pass in our color and see exactly what comes back. And if we do, we could see what we wanted, which is the car was painted blue with the code 2, exactly as we see. And we're going to do more with enumerated types. I just wanted to briefly cover them before I start jumping into more heavy information, which is going to be classes and objects, which is going to come up right now. All right, so we are going to come in here and we are going to create some custom classes, and they are going to allow us to model real-world scenarios. So I'm just going to right-click over here, and I'm going to say that I want to come in. So I'm just going to come over here and right-click on the console app 1, and I'm going to come down here where it says add, and then specifically what I want to add is a custom class. And I have C# items selected right here, and I'm just going to come in and name this animal. We're going to model real-world animals inside of this, and then again, as the tutorial continues, we'll start getting more specific on what we're working with. So what are we going to do here? This is going to be defined as class animal. There it is. And what it's going to do is you have to think about when you're trying to model real-world objects, how are you going to do it? And one of the things that we would like to do is to describe the actual attributes of an animal. So we could say things like the animal's name, that's an attribute that an animal would have, and a sound that it would have. Well, inside of C#, whenever we're talking about creating classes, which are blueprints for creating objects, and those objects are actual animals. So this is the blueprint, and then you're going to have an actual animal that's going to have its own specific name and have its own specific sound it makes. So we have these attributes, and they are called fields inside of C#, as they are in most other programming languages or object-oriented languages. So what we're going to do is we're going to mark this as public and say this is a string, and it is a name. Okay, so every animal we create is going to have a name. We're also going to create another string, and it is going to be a custom sound that our animal is going to have. Now, whenever we create animals, they are going to have to be assigned default values, or if none are provided. Otherwise, we will go and receive names when the animals are created and sounds and assign them. Where we initialize, that's called initialization, inside of our class, is in what is called a constructor. And the constructor has exactly the same name as the name of the class and the object itself. So we're going to say if they try to create an animal and they don't pass along a name, we're just going to assign them automatically the name of no name. Likewise, no sound is provided, so we will say that that animal has no sound. And likewise, let's say that we would like to track the number of animals that we have that are ever created. Well, we are going to go and do that also. So we're going to say every time an animal is created, we're going to go and store that information. But what I'm going to want to do here is I'm going to want to store that inside of another variable. And I'm going to make this static. What static means, it means that if we want to access it, these actually belong to the class. So this number is going to be the same for every single animal object that is ever created. It is not a number that is specific to an animal object like its name or the sound that it makes. So this is something that I would like every one of them to have the same number of animals. So each object that is created of type animal is going to have access to actually get a hold of this value, but this value is not going to be different for every single object. Okay, so we have our number of animals, very important. So let's get back to this guy and let's go and create our animal. Oh, we don't want it here. We want this outside of this. All right, so let's throw it down here. All right, so there it is. And let's go here. And then what I'm going to do is just automatically increment number of animals every time we need a new animal, or we created a new animal. Okay, so there that is, and there that is. All right, so that's the first constructor. But what do we do if they provide us with a name, but they don't give us a specific sound? Well, this is just another form of method overloading, which we saw previously. And we can come in here, as long as the attributes are different in some way, we can go and use the same method name. However, we are going to have different attributes. So what I'm going to do is I have string here. Oh, let's just tab that in there, do this. And we'll have name, but we're not going to get past a sound in this situation. Let's just tab the whole thing in. All right, good. All right, so we have this. So let's go and assign a default name. So no name. But if they provide us with a name, we're going to be able to work with it. Then what we're going to do is we're going to say this name is equal to name, whatever they passed in, or it's going to be no name. And we know they're not going to be able to pass us a sound because we do not have that as a parameter in our constructor that we're using. So what we're going to say is this sound is equal to, and we're going to change this to no sound. So we know we'll always have that. And then, of course, we're going to increment the number of animals. So let's just copy this, paste that down inside of there. And also, if you're referring to, if you see the word this and you don't know what that means, what it does is it actually refers to the object's name. So that's just some other piece of information that's useful. And why don't we just use the object's name that we created in our program? Well, this is like the chicken and the egg type of scenario, in which this is the blueprint for creating animals. It is created first, then we use the blueprint to actually create animal objects. Well, that animal object's name doesn't exist, so it's very useful to use this to be able to access it. Okay, hopefully that makes sense. For some reason, people get confused about how to use or what this is. It's just like a way of, it's just like saying if somebody you don't know their name, you say he or she or whatever you say. All right, let's do this. Now in this situation, we are going to receive both a name as well as a sound. We're going to define some defaults directly inside of our parameter area. So we're going to say the default is no name, and here the default is going to be no sound. But we expect to be able to get a value passed back to us. Then what we're going to do, we have this guy right here, and we're going to, I don't know why that went up there. Let's go and get rid of this. So there that is. Throw that inside of here. Here's our parentheses, and let's just copy this out of here and paste it inside of here. And let's get rid of this altogether. There's that. And here we will assign either the default or we will assign the value that they passed over in this circumstance. And we'll say this name is equal to the name passed in as a parameter. And then let's go and increment the number of animals just like we did previously. All right. I think that is enough in regards to creating constructors now. And what I'd like to do is talk about the capabilities. Now, whenever we are modeling the capabilities of an animal, what we are working with are methods. These are special functions that exist inside of classes. Let's create one, and let's call it makeSound. And what it is going to do is whenever it's called, it is going to say whatever the animal's name is, says whatever its sound is. So let's come in and we'll say console. So it's definitely possible that it says no name, says no sound. You know, that's something that is possible. Not convenient, but possible. So we'll say says, and there we go. And now what we can simply say is name and sound, and they will automatically go inside of that method. And another thing we would like to do is to be able to get the total number of animal objects that are created. Now, like we went up here and put this as static, we also would like this function to be static, meaning we could get the value of the total number of animals created without creating an animal object just to do that. Wouldn't make sense. So in that situation, this also is going to be static. It's going to provide an integer. I'm going to call this get num animals, and it does not receive any parameters. It's just providing a value. And what does it do? It returns the number of animals, exactly like that. And that is all we're going to do for this simple class at this point in time. Let's go and create another class, however, that might be a little bit closer to a real world scenario. However, let's create something that we're going to be calling shape math. All right. So what this is going to do is it is going to work with what are called structs, which are quite similar to classes. And in our main program here inside of program CS, we are going to actually create structs, and I'll talk about them as we continue there. But you know what? Maybe we should jump over into main and actually go and start working with the animals right now. I think that it's like kind of like, what do I want to do here? I want to work with that. Let's go and create shape math first. All right, so we're going to go over to console app and write, and we're going to come up here to add, it doesn't really matter when we do it, and class, and then we'll call this shape math. So give it the name of shape math. All right, good. There it is. Okay, so what are we going to do with our shape math type here? Well, this class is only going to contain static methods, and it's going to do things like get areas depending upon what type of shape is passed inside of it. So I'm going to say public static. Again, anytime you see static, that means that we do not need to create a object to be able to use it. So it is going to return a double, and let's say get, whoops, it must know that I like to use get at the beginning here, and I'm going to have a string, which is going to be of type shape, or is going to be called shape, and it is not going to have a name, and then it is going to have double and length 1, default value of 0, and then it's also going to have double and length 2, which is going to also have a default value of 0. Now, what I want to do with this is I'm going to perform different array calculations depending upon whatever string was passed inside of this. So I can come in here, let's get rid of this, and we'll say if and we'll use equals from our string library. So we'll say equals rectangle. So we'll say rectangle like that. And then we're going to compare it to shape. So whatever that string is called, and then we'll do string comparison exactly like we have, and ordinal ignore case. I like both of those. So let's just use our default we have. Let's put this on a separate line, however, because that's getting a little long. Well, if it has that, then we want to return, and we will return length 1, but we will have it be length 1 times length 2. Okay? So that is, if we have a rectangle, just multiply the one length times the other length, and boom, now you have your special rectangle area function. Then what we're going to do is we're going to say if, and let's go and just copy this whole thing. Let's just copy it. So we'll go like this, copy, and paste it inside of here. So we'll say if string, and in this situation, we're going to say triangle. So if they threw in a triangle for our actual string name, well, in this situation, we're going to compare these, and if it comes back as triangle, then we're going to do length 1 times length 2. So get this, and divided by 2. And that's going to give us our triangle area. And otherwise, let's say if they pass in a circle instead, let's just come out here, circle like that is the shape. Well, in this situation, we want to go return, and let's just get rid of all of this. And we'll say 3.14159 times the math function of power of length 1 to the power of 2, and that is going to provide us with our area for our circle. And then what we'll do is, otherwise, if they didn't send any of those, we're just going to return -1 because they didn't provide us the information that we were expecting. Okay? So that is a way of creating like a utility type of function instead of, or class, instead of what we've been used to. All right, so now let's go over into our program area, and let's go and actually use these guys. Very first thing I want to do is I'm going to create a struct. And what a struct is it is basically a user-defined type. And much like classes, they have fields as well as methods. So I'm going to create a struct, and I'm going to call it rectangle. And for homework, you can go and create the circle ones if you would like to try that out. So we'll say struct and rectangle. It's going to have public double length, and it's also going to have public double a width inside of it. You could go and create a constructor method as well. So let's say public rectangle and double, let's just make this L is equal to, give it a default value of 1, and then double width and give it a default value of 1 also. And then look at that, it went and just, whoops, I went and took away what it was giving me. It was giving me all that good stuff so I didn't have to type it out, and I was dumb and accidentally got rid of it. So let's go like this and get it back again. There we are. So there it goes, and it's automatically going to assign those values for us. Now what I can do is come in here and actually create this. So let's go out of here, and we are going to calculate our area. So we'll say area like this, and this is not useful. So we'll say area like that, And what this is going to do is return length times width. So length times width, exactly like that. And now what I'll do is I will show you how we can use this similar information to calculate the area in multiple different ways. No, actually, this needs to be placed outside of main, inside the class, but outside of main. Sorry about that error. So like this, paste it inside there. Okay, so now we can come in and start messing around with these different classes that we have. Very first thing we're going to do is we are going to come in and we're going to create a rectangle using our struct. So I'm going to say rectangle, and let's call it rectangle1. Then I want to add values. So I just say rectangle1 and dot length. And let's have this be equal to 200. And then I'm going to say rect1. I'm using the struct version right now. I'm trying to show you this in multiple different ways and different ways to use it so that you can decide on your own which you'd like or which you would prefer. Then I'm going to say WriteLine like this. And I'm going to say area of rect1. And we can use our struct area function here. So there it is, like that. And then we can just go rect1 dot area and create that. So there that is, and there this is. Now what we can do is we can use a constructor to actually create the rectangle also. So we're going to say rectangle, create a second rectangle is equal to new rectangle. And let's have that be 140. Just to try something different. If you want to assign one rectangle to another, it's very important to know that you are actually setting the values and not creating a new reference. So we're going to say rectangle 2 is equal to rectangle 1. And then we can say rectangle 1 dot length is equal to 33. And we can go and actually type this out. So console WriteLine, and we can verify this. So length like that, and let's go and get these. And then we'll come down here and let's go and get that second rectangle's length. So length like that, and there we go. And what else would we like to do? Well, why don't we just jump in here and start playing around? Well, let's run this. Okay, so let's run it. Oh, there's a build error. What's wrong? What do we have here that's incorrect? Oh, it's actually giving me an error because I had this misplaced bracket inside of here. Okay, so we have that set. And let's come in again and let's run it. Okay, so what we can see here is that we have the area of rectangle 1 is 10,000 and rectangle 2's length is set for 200. So let's go and look at that. And we can see that that's correct. 200 times 50 does equal 10,000. And whenever we went and took the value in rectangle 1 and assigned it to rectangle 2, it was originally 100 and now it's 200. So that was output as well. All right, so good stuff. And that's how we can work with structs. Now what I'd like to do is go and actually create our animals. So let's create an animal and let's call it Fox. And how you do that is you say new, and we're not going to assign any names in this regard. What we're going to do instead is come down here and say name is equal to, and let's say the fox's name is red, and we'll say the fox's sound is equal to raw. Okay, well, there that is, and we just created ourselves an animal. Now what I'd like to do is come in and get the total number of animals that have so far been created. Remember I said we do not need to create an animal object to be able to get this information, but we want something inside of there. So I'm going to say number of animals like this, and we will output it. And that's expected to give us a value of 1 because we just created one animal. So we'll say animal dot, and we're actually referring to the animal class name whenever we are typing animal there. And that is how you're able to access static values as well as static functions. Okay, so that's expected to give us a value of 1 because we've created one animal. You can also create static utility classes. So let's come in and let's do console WriteLine again. And I'm going to say area of rectangle and go and throw 0 inside of here. And then on my next line, I'm going to call ShapeMath, our special class we created. And I'm going to say get area, and I can pass in the word rectangle because we know how to get areas for rectangles, and we could throw 5 and 6 inside of here. Whoops, put the wrong, there we are. And what else is there? I think that's pretty good. Let's go and actually run this. So run it, and we see that we have our original information, which is our areas for our struct rectangle. We have number of animals is 1, as we expected, because we only ever created one fox. And we also found the area for our rectangle using our ShapeMath class by passing 5 times 6 inside of there. Now, we're going to be doing much more complicated things with classes, but before I end this part of the tutorial, very, very soon. But something that I have not covered that I think is very important to cover before I drop out here right now is what are called nullable types. Now, data types by default cannot have a value of null, and this is sometimes a problem because often null is needed whenever you're working with things like databases and such. And you can actually come in here and create a null type in a lesser used way by just going int and a question mark like that and say, well, I'm just going to throw a random number in there just to throw something in. Okay, and we can assign it a value of null in that circumstance. And if we got rid of this, it would cause, say, now it's red, and it says represents 30 to cannot convert null to an int because it is a non-nullable value type. But by putting this question mark inside of here, that's going to allow us to work with null. And we can also come in and check for null. So we could do something like random number is equal to null. And we could go and output something. So we'll say something like console WriteLine, and we'll go random number is null. And that's going to give us a positive in that situation. And you can also check for null in other ways. So you could say something like if and random number and has value. And then what we can do is come down and also output the same thing, that it is null. So there's 2 different ways to check for null types and also a way to actually store null types inside of here. So very useful. Let's run it. And you can see that in both situations, we do get random number is null. Okay, so something important that popped into my head that I thought would be useful to cover because we're going to talk about it later. And now I'm going to talk about new classes and new objects. All right, so now what we're going to do is we're going to take our animal class and we're going to make a lot of changes to it so that I can cover public, private, protected, constants, read-only fields, and setters and getters and properties. I think that's everything. And so let's just come in here and we're continuing with what we have, and we're going to make some changes here as we walk through here and I explain a couple different ideas. One thing is what we call setters or mutators. And what they do is they protect our fields or our attributes. And so, for example, if we have a bad name passed, so let's say we deem a animal name with a digit inside of it as being a bad name, we can go and reject that. So what we're going to do is we're going to say public void, and I'm going to call this set name. And it's going to be passed a new name that the user wants to change for the animal. And what we want to do here is we want to check if the name passed inside of it has any numbers inside of it. And how we do that is go character is digit, and it will check every character entered, and if they enter something that has a number in it, we will reject it. Otherwise, we can say this dot name is equal to the name they passed inside of it, which is perfectly fine. And if it does have a digit inside of it, we're going to reject that by saying this name is equal to and no name. So there it is. And then after that, maybe we give them some type of an error message. So we could say something like name can't contain numbers, like that. All right. So this is a valid setter specifically for name. What else would we like to do? Well, if we have a way for them to set the name, we should also have a way for them to get the name. And these are called getters or accessors. And one of the main reasons why you would use them is to provide custom output. So let's say we have height stored as a in meters or in inches or whatever. See, if you say what's the height of this, it could become confusing. So what we could do with the getter is actually provide that information, so meters or inches or something like that in the output. In this situation, we're just going to say return name just to keep everything very simple. Another thing we'd like to do, let's go and do much the same with the sound. So I'm going to say public and string sound. Let's go like this. And you can also define your getters and setters through what we call properties. So you can see right here, it automatically just did it for me. And that's going to return the sound. And then with the setter part, we could do something a little bit more custom. So we could say if and value length is greater than 10, well, we'll deem that that is not valid. So we will say sound is equal to no sound. And I'm just throwing in just any reason to reject the sound. There's, no other purpose inside of that. So we'll say console dot and WriteLine. Whoops, meant to hit WriteLine with a tab. And then we'll say something like sound is too long or something. So sound is too long. And then we have that. And then what we could do is we could come in and say else and sound is equal to the value that we have assigned to it. All right. So that's how we can set that up. Let's come out of this area right here. And you can have the getters and setters generated for you also. So let's say I wanted to assign each animal an owner. I could have public, and it'll have a string return value, and then we'll have owner. And then inside of here, we could say get and set. And then we could have this be set to default of no owner for, owner, like that. And so it depends on if you want them to be set or you don't want them to be set. Where do I have number of animals? I have that stored inside of here from the last one. Yeah, static int number of animals. Let's go in here and let's also increment this using a method. So I'm going to come in also and say public. So let's say that we want to go and store more than one animal and number of animals. We want to increment by more than one. That's something that could be possible. Well, in this situation, we'll have everything handled with a method. So we're going to say number of animals like this, and then we'll say get, and we will go return number of animals like that, and then afterwards we could say set, and the number of animals is going to be incremented by whatever value is passed or is assigned to the number of animals. All right, and number of animals. Why is that not giving me a name? Type animal already contains a definition for number of animals. Oh, okay. Well, I'll just go and fix that. So we're going to come up inside of here and let's make this public. And then I'm going to make some changes to how we are accessing the name and sound, because up here I have them all set as public. Well, if I do that, it sort of defeats the purpose of having these be having them have setters and getters. So what I want to do instead is to mark them as private, and then they can only be accessed through their setters and getters. There's no other way to get access to them. So mark both of those as private. One thing that's important to know, however, is if we mark them as private, that they are not going to be accessible by subclasses. And what that means is I can inherit every single thing, the properties and the functions inside of the animal class, into a new class called dog, and then go about making changes as I might deem fit. And if it's marked as private, we wouldn't be able to access that. Protected fields, however, can only be accessed by methods in the class, but they can also be accessed by subclass. And it's up to you whether subclasses mean inherited classes, and it's up to you whether you want those or not. Another thing is I'd like to define a constant just to define one. And we can define constants in classes or outside of them. So let's say that I want this to be called shelter, and this is going to be called Derek's home for animals. All right, just to throw something inside of there. And what else would we like to do? Well, I'd like to define an identification number for each of my animals. So I'm going to come in and have this be public. And then I'm going to define this as read only. Read only. And read only fields that are set at runtime in constructors can't be changed. So I think that's good. We don't want our ID numbers to be changed for our animals because that wouldn't make any sense. What else would we like to do here? Well, make sound. Am I going to have to make any changes to it? I don't think so. Let's go up to our constructors and see if there's anything that makes more sense here for them. I'd like to have a default constructor that I would then use for everything else. So I'm going to have this be public animal. And then what I'm going to do is I am just going to come in and I'm going to get rid of all of this, because what we can quite simply do is just simply come up here and go this, like this, and define this, the values we want inside of it. So it would be no name and no sound, exactly like that. And that would automatically set those. And then we put empty curly brackets at the end of it. So this is the default animal if nothing is set. And let's go and create another one. Why don't I just go and get rid of all this? So I'm going to get rid of these default constructors that we created in the last one, and we're going to make better ones. Okay, so what I'm going to do here is I'm going to create a constructor that is going to be called only if a name alone is passed and no sound. So I'm going to go public, again, animal, like that, and then I'll have string and name passed inside of it. And then what I can do is go this and name, and for our other value we will say no sound because none was provided. And then again we will throw empty curly brackets after that. Then what I can do is create the constructor that's going to make all these error messages go away. So this is going to be the constructor that receives parameters. I'm going to call this animal and string and name and string and sound, like that. Then we can come down inside of here and we can use our setters. So I'm going to say set name equal to, and it's going to be the name that they passed inside of it. And then for sound, we can say sound equals to sound, exactly like that, and that also works. Now let's say that we want to increment the number of animals using the property we created. We can say number of animals like this, and let's come down here and make this uppercase. So there's number of animals. And where am I? I lost my place. Okay, so this is actually calling that method down there to increment the number of animals by 1. And then I need to define my read-only value, which is the ID for my animal. So to do that, I say random, and we'll go rand like that is equal to new random like that. And I will do ID number and equal to rand. And then I need to go and generate a big number that hopefully we have no chance of getting any other types of animals inside of it. So I'll do 214-748-3640. I don't think we have to worry about having any more animals than what we have right there. And I have make sound set, I have set name set, I have everything else here set, and it doesn't look like I have any errors. And so let's go over into our program area now and start messing around with our new class we just created. All right, so I'm going to go into here. I'm going to get rid of this struct. We do not need it anymore. And all of the code is on GitHub, and there's a link in the description, of course. And then we'll go into, here's main. We don't want any of this stuff that is inside of main. So let's just keep going down here until we get to this part and delete it. All right, nothing else here that is of importance. So now let's go and create a new animal object. So I'm going to go animal. I'm going to call it cat is equal to new and animal. All right, so we have a new cat animal. And if we would like to set its name, can't set it directly anymore. Now we have to use our setter. And I'm going to say Whiskers is the cat's name. And then after that, I can also go in and set the property, which also calls our method. And this is going to be for sound. And I'm going to say meow. And you can see here how they're different. So we have set name and set sound. So set name is structured like this. It's just going to verify that there's no number inside of it. And while sound is going to be set up right here, and we have our getter automatically set up here and our setter set up like that. So that is the difference that we have in how we have those set up. And like I said before, this way of setting up sound right here, this is called a property. This is the best way to set it up. Not like this with separate getters and setters. I just provided that as a way of looking at the right way versus the wrong way. But I'm going to keep it like that. I'm not going to change anything. Clearly, you can go in and change anything that you would like to change with them for homework. Okay, so now what I'm going to do is I'm going to say console, and let's do a WriteLine, and I'm going to say the cat is named. And let's get that value, and says, and let's go and get that value. And I can go and use my getters, cat dot get name like this. And I can go and get my sound by saying cat dot sound. Again, you see the properties are much easier to understand, and that's why you should use them instead of using these methods. But like I said, perfectly fine either way. Now what I'd like to do is say that I wanted to assign a owner for my cat, and it is going to be me. So I'm going to say Derek, like that. And then I can come in and get the cat's name as well as the owner, who is me. So console dot, and let's do WriteLine again. And inside of this, I am going to go and get the cat's name. So there it is. And owner is, and then owner, whoops. Yeah. Owner is, and get my name. And there it is. And then we can go and get both of them just simply by saying cat dot get name like that, and cat dot owner like that, and close those parentheses. All right, what else would I like to do? Well, I'd like to get the read-only ID number for my animal. So why don't I just copy this whole thing? So copy and paste. There it is. And what I can do is I can say shelter ID is. So I'll say shelter ID is. And then I can get the name just like I always got it. And if I want to access the ID number that's stored inside of there, remember it's read-only. I just say ID number, like that. Whoops, it's ID num with a capital N. And anything else I'd like to do? Yeah, I'd like to test my static property to show you how to access those. So console WriteLine, and here I'll say number of animals, and let's leave that there. And let's just do a number sign of animals, and like this, and this should be changed to a 0, however. And then to get access to that static property, you just call the class name followed by number of animals, exactly like that. And that's good stuff. And we can run this to see it work. I think it'll work. Yeah, it looks good. And then we can come in and look, and it says cat is named Whiskers and says meow. Whiskers owner is Derek. You can see my automatically generated ID, and the number of animals is equal to 1. And I think that is clearly a better way of structuring a class using properties. All right, so now what I want to do is talk about inheritance and a bunch of related topics as well. Now remember, I said that if we have a subclass, we are not going to be able to access this name field from it. And a subclass means that we're going to create a new class that's going to be based off of everything an animal, but it's going to make a couple different changes. And that subclass's name is going to be dog. Now, if I have this instead of marked as private, but I have it marked as protected, that means that it can be changed inside of our subclass. And as you're going to see, that's something that I will want to do. I'm going to get rid of a couple pieces of information that are stored inside this class. I mainly created them just so I could demonstrate them. So I'm going to get rid of all of this information. And whenever we talk about classes, well, if we have a inheritance situation, this is kind of jargon, but it's something that's important to understand. If we use inheritance, which means we go and get all the properties and methods inside of this animal and put them into a new class, once again, it's going to be called dog. This is called a is-a relationship. Now we have another type of relationship when we're creating classes or whenever we have properties inside of classes, and this is called a has-a relationship, and it's often referred to as a delegate. So what we want to do here is we want to mark this as protected, and we want to have this be called animal ID info. And let's go and create this class. So I'm going to go up here where it says console app, and I'm going to say add and class. And the name of this new class is going to be animal ID info. Exactly like that. And as you're going to see, as we do more and more complicated things here, we are going to go and set them up in numerous different classes. So inside of this class, I'm going to have public and int ID number, and I'm going to create the getters and setters. So I'll say get and set exactly like this, and we will set this to 0 like that. Then what I'm going to do is I'm going to say public string, and as you can see, makes sense for animal to have a has-a relationship with both of these. So there's the getters and setters, and then we're going to mark this by default as no owner. And there we go. So the ID number and the owner is going to be stored inside of it. Now back into animal. There it is. And protected animal ID info is stored right there. And I'll call this animal ID info. And we'll say equal to new animal ID info. Whoops, info. There we are. And there we go. All right. So now what I'm going to do inside of here is create a method that's going to set this information. So I'm going to say public void set animal ID info. And it's going to receive a integer, an ID number, and a string, which is going to be animal ID info. And Is there anything else that I would like to do with this? Whoops, well, that's not right. That's going to be owner, I mean. All right, duh. Okay, so owner. There we go. All right, and then what I can do is go and call animal ID info dot ID number and have it be set to whatever the ID number is that was passed inside of it. Animal ID info dot owner and have that be set to whatever the owner was that was passed inside of it. Then I can also provide this information. So I'll say public void and get animal ID info, and then we will print out a custom message. So it's going to be console and WriteLine, and inside of it we'll go and set this up so that we can put the variables directly inside of here. So we'll say name like that has the ID of, and then we'll say animal ID info dot ID number and is owned. Whoops. Let's go and turn on the wrap. And to do that, we go tools and options and text editor. Text editor, where is this? There it is, text editor. And then you're going to go for C# general, and then you're going to look for word wrap. Click on that, click on OK. And now it'll automatically word wrap around so that you keep everything here nice and neat. Okay, so we'll say owned by and animal ID info and get the owner information and throw this here and throw that there. Okay, what else would I like to do? Well, I'd like to set it up so that the make sound function can be overwritten in the new class that's going to inherit everything from this class. So I'm going to say public, and I'm going to mark this as virtual, and that just allows me to override it in the subclass, which is going to be called dog. So I'll say make sound like this, and what we're going to do is we're going to have the dog make more than one sound. And here I'm just going to say console dot WriteLine. Whoops, WriteLine. Let's get rid of that. WriteLine. There we are. And inside of here, I'm going to say name and says whatever the sound is. So let's get our sound, and there we go. And what other changes would I like to make? This is perfectly fine. This is going to be perfectly fine as well. And the animal here also looks pretty good. We went and changed this. Why don't we set up the name properly so we don't have that? And let's get rid of I think you get the point of how the get numbers is going to work. So we're just going to get rid of or get the number of animals that are created. Let's just get rid of that altogether. We don't need that anymore. And what else would we like to have change here? Well, I said that this is messy with the way that we're handling the names, so let's get rid of that. I said to do that for homework, but you know, that was in the last video. And instead, what we're going to do is do the same exact thing we did for sound, but we are going to do it for name now. So let's go like this and paste that right there. And I'm just going to change this to name like that and return. And this is going to be name as well. And we said we're not going to allow them to have values that are digits inside of them. I guess I should have saved that. But let's just have this be if, and then what we did was we said, let's just get rid of all that. Name dot any and character dot is digit. So that's going to block them from using numbers inside of their animal names. And we just need another parenthesis here to have that be set right. And then this is going to be name is equal to, and we'll say no name. And we could say can't use numbers in name. That's good. And then otherwise, we will just set the name to be equal to no name. And then down here, we will set the name to be the value that was assigned to it. Okay, so now name is just as good. It's set up as a property, just like sound is set up. And any other things that I would like to do. Yeah, I might as well come in here and also handle, well, we don't need owner because we don't have this anymore. I'd like to talk about inner classes. It's actually very common to create classes inside of classes. And whenever you do this, these are normally considered to be helper classes for the outer class. And what we want to do here is judge the animal's health. So I'm going to go public, and then inside of here, let's call this public class animal health. And it is going to judge if the animal has a healthy weight or not. So I'm going to go public bull healthy weight. And it's going to get double and height. And obviously this isn't scientific. This is just me throwing some more functions in here just to do something useful. All right, so we have healthy weight. And then inside of here, what we're going to do is I'm going to create another double. I'll just call this calc is equal to height divided by the weight. And then I'm going to say if the calculation is greater than or equal to 0.18 and the calc is less than or equal to 0.27, well, in that situation, I will return that yes, they have a healthy weight, and otherwise I can say else, and I can just say return false, I mean. That works perfectly fine. All right, just to do something a little bit different there. Now what I'm going to do is I'm going to create my dog class and inherit everything from animals. So I'm going to say add and class, and this is going to be called dog. So we'll go dog like that, and we'll click on add. Now remember, I said that I want to inherit everything from my animal class and put it inside of my new dog class. Well, to do so, that's all you have to do. And you're going to get all the fields and methods automatically inside of your new class. Now, what I'd like to do is I want to add some additional properties to make it more dog-like. So I'm going to say, hey, my dog can make more than one sound. So I'm going to go sound 2 and automatically generate my getters and my setters for dog 2. And I'm going to have the default second sound just be grr, like that. All right, so we have that set. And I said that over inside of my animal class, whoops, I don't even need this anymore, so let's just get rid of it. Here's animal. And where is it? I have the make sound function, and I have it marked as virtual. Well, I want to be able to change this inside of my dog class. So what I'm going to do is I'm going to say public, and to show that you want to override that original function in the animal class, you go override void and make sound. Now, if you call make sound with dog, it's going to use this version of make sound instead of the animal version. So I'll say console, and I'll just overwrite this. So I'm going to say WriteLine, and then inside of here, I'm going to say name says sound, and also sound 2. So there is sound 2. And then close that off and close that off. And it's giving me an error because I accidentally jumped out of the class. So let's go up here and paste that in there. Okay, so now all those problems are gone. All right. So now what I have to do here to finish up everything is just create a custom constructor that is also going to allow the animal. It's basically going to initialize everything that's different about dogs, which is sound 2, and it's going to let the original animal class handle everything else. So just like always, the name of the constructor is the same as the name of the class, so it's going to be dog, and I'm going to receive a string, which is going to be name, that I'm going to have a default value of no name for it. And then let's go to the next line. I'm also going to have a string for sound, which is going to be equal to no sound. And then also another string, because our dog is more intelligent than your average animal. Sound 2 is going to be equal to no sound 2. I don't know, something fun like that. Then what we can do is, if we want the original animal class to handle initializing the name and the sound, we could pass this over to the animal constructor and just pass name and sound inside of it, and it's automatically going to work. But we have to handle sound 2 on our own, and to do so, we say sound 2 is equal to whatever sound 2 was that was passed inside of it. And there you go. There is your slightly more accurate, very slightly more accurate dog class. So now what we're going to do is we're going to go over inside of our program area and mess around with it. So we have animal, whiskers, new animal. What we can do here, since we now have the name set up using the properties, is we can go and create new cats. Let's just get rid of all that. And we're going to say animal, and let's call it whiskers. So let's go whiskers like that is equal to new animal. And then let's get rid of the semicolon, and inside of it directly call the name. So we'll say name is equal to whiskers like this, and the sound is going to be equal to, yes, I know cats make more than one sound, but I'm just playing around here. And then go and throw a semicolon at the end of that. Now what we can do is then, so the cat is still going to be considered a regular animal, but we're going to create a new dog type. So we'll say dog, and let's have the dog's name as Grover is equal to new dog. So there that is. And name, let's change this to Grover. So Grover like that. And the sound is going to be equal to wolf. And we'll also say that it is going to have a second sound. And our second sound is going to be equal to grr. All right, good. And then that's also a semicolon at the end. And then I can demonstrate changing the protected field sound here by just saying Grover dot sound is equal to, and let's change it to wolf. Okay. All right, so a big wolf instead of a little wolf. And then I can come in and I can say whiskers dot make sound, and whiskers is going to be able to make a sound. And then I can also say Grover dot make sound. And there we go with that. I can also come in and set, let's just get rid of all of this information because a lot of it doesn't even apply anymore. Let's come in to the, let's set our animal information for whiskers. So this is going to be set animal ID info, and we'll say 1, 2, 3, 4, 5 for whiskers, and whiskers is owned by Sally Smith. And then we'll do the same thing for Grover. Let's just copy this, paste this inside of here, and let's move this up here so you can get more information on the screen. And here, this is going to be the second animal we create. Let's increment that, and let's have this be Paul Brown, like that. And then we could say that we want to get whiskers animal information. So get animal information for whiskers. And what else would we like to do? Well, I should go in here and test my inner class that I created. So I'm going to say animal dot animal health, and I'll go get health equal to new animal and dot animal health. All right. So now that I have that all set, I could come in and say console dot WriteLine, and what do I want to do? It didn't take WriteLine. All right, there it is. And I could say, is my animal healthy? And like this, and then I could plug in the information. Of course, it would be even better yet if I stored the height and weight for the animal, but didn't do that. Don't worry, we're going to get into much more complicated things. And I'll say get health dot, and then I'm going to call healthy weight, which is right here, and I'll just pass in 11 and 46 inside of there. What else would I like to do? Let's go create a couple more animal types. So I'll go animal monkey is equal to new animal and set the name for it. Whoops. Yeah, it corrected it for me automatically. Great. Let's say our monkey's named Happy, and our monkey says E. I don't know what a monkey says, something like that. And a semicolon. And let's go and create another dog on top of that. Animal, let's call it Spot, is equal to new dog, and name is equal to Spot, of course, Spot. And we'll be able to demonstrate here how we're able to access overridden methods, even though Spot is an animal. It inside of the dog class here because, well, we see right here, because this is marked as virtual. If this wasn't marked as virtual, we couldn't do that. Let's also come in and say sound is equal to, I don't know, and what else would we like to do? Sound 2 is equal to, and maybe he has a weird grr noise he makes. Okay, so there we are. Created all those different types of animals. Now we can come in and say spot make sound like that, and it's going to automatically make the right sound. And I think that's enough demonstrations for this. Let's go and run it. Uh-oh, we have a bug. Where is our bug at? Oh, I see. Over inside of animal, I need to change this. I forgot that I had streamlined everything. Let's get this, put that there. We say name is equal to name, and sound is equal to sound. That, did I get rid of all the bugs? I think so. Let's go and run it again and find out for certain. And nope, there is a bug. Okay, let's figure out what that is. All right, and looking at the code, one thing I noticed, probably because I crammed all this code together, this is supposed to be set for Grover, because we want both of them to have an owner. So let's save that. And another problem we have here, we don't need this else part inside of here. We could just go and get rid of that altogether. And let's just get rid of this. And we could set this to name is equal to value, like that, just to get rid of the else that doesn't need to be there. Anyway, okay, good. All right, so I ran it again. I'm still getting an error here. As you can see, what it's saying is, I guess this is a good thing. We can work our way through an error. All right, so it's saying that throw argument null exception argument, and and it says animal line 49. So we're going to investigate that. That's where we have, see, it says 49. It's better to check at the end. So let's check animal 49. What is going on animal 49? So we can figure this out. Animal 49. What is different? Okay, so I basically did exactly the same thing with name as I did with sound. No, I didn't. Look at that. I have value and I accidentally wrote name. All right, that'll get rid of the error. Okay, so let's save that. Jump over here and let's run it. And that did it. Okay, make sure you don't put name inside of there. Use value, of course. And now we can see here, Whiskers says meow, Grover says wolf and grr, Whiskers has the ID, da-da-da-da-da. Is my animal healthy? It says true, and Spot says wolf and grr. All right, so there we go. We're ratcheting up the complexity of our classes, and in the next video, I'm going to continue doing that. All right, so now what I want to do is to provide another deeper example on polymorphism, which we'll talk more about, along with abstract classes, base classes, and a whole bunch of other different topics. What I'm going to do here is sometimes we want to define a class that we don't want to be instantiated. We don't want an object created for it. And in those situations, we would use what is called an abstract class. So let's come in here and let's create one. So I'm going to say add and class. All right, and what am I going to call this? Well, I'm going to create a shape class, and then I'm going to create I'm going to inherit from it with a circle and a rectangle class. So what are we going to do here? Well, I am going to change this to abstract, and that just simply means that it is not going to ever be instantiated. All right, got that set up. So what are we going to do? Well, inside of it, let's try to get that in position. I'm going to go and create public string name and getters and setters. Look at that, created it for me. Good stuff. So now what I want to do is you can define non-abstract methods inside of an abstract class, and how you would do that is you would say public and virtual. We saw virtual here a little bit ago, and this isn't going to return anything, and it's just going to be called get info, and it's not going to be passed anything either. And what it's going to do is it's quite simply just going to come in, and let's call WriteLine on this, and it's going to say this is a, and print whatever the value for name is. This is a, and throw name inside here. Well, this will be capitalized, so name like that. And then, whoops, throw in my quotes, and there we go. All right, and that is all this is going to do for us. Now, if we want subclasses to override this method, we can mark it as abstract. And another thing to know is you can only make abstract methods inside of abstract classes. So we're going to go public abstract double, and we're going to demand that area be inside of it. And there you go. So there we went and we created our shape class. Now what we want to do is we want to create a circle class that is going to inherit and then recreate everything that is inside of our shape class in its own special way, and then add in anything else that needs to be done. So we're going to say add, and I'm going to say class, and this is going to be called circle. So circle like this, and add it. Okay, so what are we going to do inside of our circle class? Well, we're going to say class circle, and we are going to inherit everything from our shape class. Exactly like that. Oh, I already have the curly brackets inside of there. Okay, so what are we going to store inside of it? Well, with circles, we are going to have a double, which is going to be our radius, and there's our getters and setters created for us. Then we're going to also have a constructor that is going to receive a radius value. So there that is. And what are we going to do here? Well, we're going to have radius stored inside of this. And then also I am going to have name be assigned the value of circle, right like that. All right, so this is all that our constructor is going to do for us at this point in time. Now what we want to do is we want to come in here and override the area method. So I'm going to say public override double, and this is area. And what are we going to do here? Well, we're just going to return the calculation value. So we can call math.py times math, and we'll get our, math, and get our power function. And then inside of here, we'll have radius to the power of 2. All right. And that's all that's going to need to do. Now for our get info area, let's come in and let's just retype this. I'm going to override that as well. So I'm going to say public and override void get info. And nothing else changes here. And what I want to do here is first to execute my base class version of getInfo. And then I'm going to come in and I'm going to say console WriteLine and, let's get this in here. Got a little bit fancy. All right, so let's go get this. And we're going to say it's going to automatically print circle inside of there, by the way. And I'm going to say it has a radius of, and get whatever the radius value is. So there is our radius value, and then close that off. All right, so good. And now we have everything that we want from our circle class. Now, let's save that just to make sure it's saved. I'm going to do now pretty much the same thing for my rectangle class. So come in here, go class, and then this is going to be called rectangle. There we are, and add that to it. And inside of our rectangle class, how many things are we going to change? Good number. All right, so let's say class, and this is going to be rectangle, also going to inherit from our shape, and I already have those curly brackets, don't need those. Okay. And then come down here, and we are going to have 2 different fields inside of here. So we're going to have a double, which is going to be length and getters and setters. And then we're going to also have another one, double, which is going to be width. Look at that. Okay, then we're going to have a constructor. We're going to say a public rectangle, and it's going to receive a double, which is going to be the length, and also a double, which is going to be a width, and then it is going to store those different values. And then we're going to say that the name for this is rectangle. And there we are. Now I need to come in and override my area method. So I'm going to say public override returns a double and area. And here I can just simply come in and say return, and it'll be length times width. And there we are. Okay, so we have all that set. Now I need to change my my get info. Why don't I copy the circle version of this? So I'm going to go copy this and then jump over into rectangle and just paste this down inside of here, paste that there, get info. Again, we're going to execute the base version of get info, which is going to print out the name. And then I'm going to say it has a length. We're going to have length inside of here instead of, and this will be length, like that. And then we'll say, and a width. So let's just say width of width. And it'll throw that inside of there for output to the screen. And we don't need this extra space here. Okay, so there we go. We created all of those. Now we can go in and we can actually work with both of them inside of our main function. So let's come into our main area. And inside of here, we can store our shapes in a shape array as long as any shape stored inside of it contains subclasses of shape. So we can say shape, there's a shape array, and we could say shapes is equal to, and new, let's throw our curly brackets, new circle with a radius of 5, and then also a new rectangle, like that, which is going to have a length and width of 4 and 5. So very easy to store those. Then we can come in and cycle through the shapes and print out the areas because everything that is needed is already there. So we can say for each and shape S in shapes, and this is true even though these are circles and rectangles instead of shapes. They're still ultimately shapes. So we're going to cycle through all of these. First thing that I would like to do inside of here is go and get the shape that we're cycling through and then call getInfo on it. Don't need to do anything else. I'd also like to come in, let's do, and print out our area. So I'm going to say WriteLine, and let's get rid of this part right here. And instead, we'll change this into 0 and area. And let's say that we want to format this to only say, like, to have 2 decimal places or something along those lines. We could say F and 2. And I don't think we need to do anything else with that. And then we'll just say that we want the name, and also we want to calculate our area, like that. And then we have to throw in another parentheses here to close that off. And another thing is you can use as to check if an object is of a specific type. So let's go and try that out as well. So I'm going to go, let's keep it in the same area here. So I'm going to say circle test circ is equal to S as circle. And then I can say if test circ equals null, then I'm going to say console WriteLine, and this isn't a circle. Oops, I think that's all that I want to do there. And then you can use is to check the data type as well. So you can use as or is. So let's go right here and we'll say if S is circle, then we could say this isn't a rectangle. All right, so let's copy that, paste that right there. This isn't a rectangle. And there we are. And is there anything else that I would like to do? Yes, let's demonstrate polymorphism. So this is the for each. I want to get out of that area. And I'm going to, basically what you can do, I'm going to create object and circ1 is equal to new circle 4. And then I'm going to say circle circ2 is equal to, and what I'm doing here is basically you can store any class as a base class and then call the subclass methods even if they don't exist in the base class, but you have to go in and cast them to that specific type for that to be able to work. So we'll say console, and let's do WriteLine, and then inside of here we're going to say quotes the, and get the name for the circle. Area is, and let's output that value as well. So I'll go get this, and then what we need to do is just go circ2 dot name and circ2 dot area. And that is all going to work as long as you cast it. All right. And that is all we need to do as long as there aren't any errors. And it looks like it worked great. Okay. So let's zoom in. You can see as we're cycling through here, this is a circle. You can see it has a radius of 5 prints out. You can see it calculated its area. You can also see, remember we are currently looking at circles, and it says this isn't a rectangle versus saying it is a circle. Then we have a situation in which we are working with a rectangle. It says this is a rectangle. and it prints out the length and the width. It calculates the area. And again, this isn't a circle. And then finally, with our last example there, even though I marked the object as type object, it was still able to calculate the area because I was able to go in and cast it to the proper type. All right, so there is yet another example of how we can work with classes, abstract classes, override methods, and more. Now what I want to do is talk about interfaces, and I'm going to provide you with actually 3 examples. One is going to be not complicated at all, and then we're going to proceed to being more and more complicated. So I'm going to create, let's go here and go add, and I want another class, and this is going to be called vehicle. So vehicle, and that's good. And you have to think, okay, what do we need with our vehicle? Let's create another class. Let's create our interface too also. So let's come in here. And basically an interface is a contract. And it basically just means that if you inherit from the interface, you must implement certain methods defined inside of the interface. So let's create that. Let's work with the interface here first. I think that makes more sense. And basically, there's nothing in an interface except for abstract methods. And like I said, they're basically like signing a contract if you go and inherit from them. And another thing that's important to know is interfaces commonly have names that are adjectives. And on top of that, it's very common and with objects, it's normally nouns. And it's also important to know that it's considered common to start interfaces with a capital letter I. Now, this is an interface. So let's get this and change that to interface drivable. And interfaces can have properties. So let's go in. I'm doing here. Let's go right here. And I'm going to say that we are going to have wheels if it's going to be something that is drivable, and we're also going to have speed, and there that is, and have that implemented. Okay, and then what we do is we are going to put in some different abstract methods inside of here. So we'll say move like this and close that off, and then void, and another thing our vehicle must be able to do is to stop. Okay, there you go. There is our drivable interface. Now, inside a vehicle, we are now going to implement the drivable. So we'll say that we want a class called vehicle, and it is going to inherit everything that is in drivable. Then we are going to come in and let's say what exactly, I mean, we're basically trying to create a real world object. So what does a vehicle have? Well, one thing a vehicle has is a brand name. So we're going to call this brand and get that set. Then we're going to come in and create a constructor for this. So I'm going to say public and vehicle, and I'm going to say string and brand, and I'm going to give brand a default value of no brand. So there that is. And I'm going to say int wheels are equal to 0. And let's have that be implemented here. So let's get rid of that. This is going to be passed inside of here. So I'm going to say, and let's put it on separate lines also. I think that makes more sense. So we'll say int wheels is equal to 0. And let's put this here, and we'll say that it also, has a speed, and we'll give that a default value of 0 as well. All right, now that we have that set, we can say brand is going to be equal to, there we are, the brand. Wheels are going to be equal to wheels, and speed is going to be equal to whatever speed they entered. And these have to be uppercase. Wheels and speed. and they are going to match up. Speed, there we go. They're going to match up with what we have in our interface. See, wheels and speed. There they are. Okay, so now that we have that set, what we need to do is go and create our properties from our interface. So let's get out of this, and I'm going to say public double speed, and let's go this and getters and setters, and then we'll also say public int, whoops, it put it up there for me, there we are, and now we have wheels set up as well. And now we need to implement move and stop because that is a demand. So we'll say void move, and this is just simply going to say console and WriteLine, and what are we going to have here? We'll say, hopefully it has a brand name, so we're going to say the brand moves forward at, and whatever the speed is. There we are. And the speed, and then I'm just going to have this be miles per hour. Okay, there we go. So we have that, and we're going to do pretty much the same thing for stop, and these must be implemented. So we'll come in, just change this to stop, and then we'll just say the brand, and then we'll just say stops. And on top of that, we're going to set our speed to be equal to 0. And there we are. Okay, so now over in our program file, we can go and implement all this. So I'm going to create inside of main a new vehicle, and I'm going to call it a Buick is equal to new vehicle, and I'm going to give it the name of Buick, and I'm going to say, what do we have here? What do we have? Speed and wheels. Okay, that's what's passed in, right? In that order. Oh, wheels and speed. Okay, so we'll say that the wheels are 4 and the top speed is 160. Okay, now what I want to do is, if you want to check if the vehicle implements the iDrivable interface, you can say if and Buick is iDrivable. Well, then I can say, since it is, then I know that I have my move function that I can use, and I know that I also have my stop function that I have available to me. And if not, if it doesn't inherit that, then we're going to say, well, this didn't implement the interface that we want you to use, so we are going to say that this car is faulty and cannot be driven. So we'll say the whatever can't be driven, like that. And then we'll come down and we'll say Buick, and we will go and get the brand name set for our Buick. All right, so pretty simple example. Don't worry, the next one is going to be way more complicated. And we're going to come in here and we'll run it. And there it is, and you can see right here, Buick moves forward at 160 miles per hour, and then we call for it to stop, and it stops. Okay, so now we're starting to get more into the world of implementing objects and having them work together. Now what I want to do is take it up another notch, and we're going to simulate TVs, TV remotes, individual buttons, and even the act of picking up a remote control. All right, so the very first thing we want to do is we want to come in and we want to create an interface that is going to represent electronic devices. So I'm going to come in here and I'm going to say add and class. And what are we going to do? Well, let's call this electronic device. Okay, so there's our electronic device. And what exactly are we going to do in here? Well, basically, interfaces can be used to create extremely flexible systems. So, for lack of a better word, let's go and let's call this an interface. So, interface like that, electronic device. So, what we're going to do is we're going to model a generic electronic devices. And we're going to use a television, but you could have it work with anything like radios and so forth. And it's also going to have a remote, and we're also going to program the buttons. So everything can be very easily switched between. Now, what do we want to do here? Well, we want to list in this interface just those capabilities. We want anything deemed to be an electronic device to be able to work. So we want to be able to turn it on. So there's on. What else? We want to be able to turn it off. We want to be able to turn the volume up. And we want to be able to turn the volume down. Look at that, how smart that was. Okay, so there we go. Those are all the capabilities that we want anything deemed to be an electronic device to be able to do. Now what we're going to do is we're going to create a remote control. And let's go, did I click on it? Yeah, there it is. There's this and class. And this is going to be remote control, and we're going to interface these different devices together. So I'm going to call this TV remote, and there it is. All right, so what is this? It's a class. It's just a class TV remote. It's basically a first class type of object. All right. So now what we're going to do with this is we are modeling the action of picking up the remote with our hand. That is literally so an action. And in the next video that follows, you're going to see that I can break down a fight between multiple people, some people with superpowers and some people without superpowers and things like that, into tiny little pieces, and then have the interaction with them inside of main, even though the whole interaction is quite complex, be very, very simplistic. So I'm going to have public static electronic device, get device, and what we are going to return is a television. I'm going to actually create this in a minute. So I'll say return new television. Okay, I just wanted to start with the act of picking up the television. Let's create the television now. So we'll say add and class. Here it is, and this is going to be our television. So we'll say television and create that. All right, so what is television going to do? Well, it is going to inherit from electronic device. So let's come in here, electronic device, there it is. And because we implemented the electronic device interface, any other device we create will know exactly how to interface with this new device that we just created here. So we're going to say, and that's one of the most important reasons why we use interfaces, is it's a contract that everybody knows that if you implement that contract, you will have these certain functions and everything will just work. So I'm going to have volume and getter and setter. And then what do I need to implement? Well, I can actually come up here on this and then go down to show potential fixes and say implement the interface. And look at that. It automatically creates everything that I need to implement. So what am I going to do? Well, whenever the off method is called, I am just simply going to come in and go console WriteLine and say the TV is off and print that out. And what else are we going to do? Let's go copy this. And of course, instead of having it just simply print this, we could have it interface with an actual piece of hardware and have it work. And then we have on. And we'll say the TV is on. And volume down. We could come in and change this. And we could say if volume is not equal to 0, well, then we'll call volume and decrement it. All right, and then we'll come into this guy right here, and we'll say something like the TV and volume is at, and whatever the value for volume is after it's been decremented. All right, and then we're going to do basically the same thing for our volume up. So we'll copy this, come in here, paste that right there, and if it is not equal to 100, then we know that we can continue to increment it, so we will. And then it'll say the TV volume is set at, and whatever the volume is for that. All right, and then we have our TV remote, which just simply creates a new television. It's just like grabbing the remote. Now what we can do is we can actually go and create another interface that can line up with a button and perform different actions depending upon the state of said button. So let's say we just want to work with our power button and make that work. Well, we could come in here and we could say add and class, and here is an interface, and I'm going to call this iCommand. There it is. All right, this is an interface iCommand. And what is iCommand going to do? Well, it is just going to have two commands. One's going to be execute, and the other is going to be undo. Let's have it be undo. All right, that is all it does. All right, and then we basically leave the individual buttons to define what they should do. So I'm going to come in and I'm going to say that I want to create a new class, and it is going to be for our power button. So it's going to turn our television on and off. And by breaking everything apart like this to the individual buttons, makes it very easy to change these, just a couple lines of code, and have everything just simply work. So what do we have to do here? Well, this is going to be a class called power button. And what is it going to, what interface is it going to work with? It's going to work with iCommand, all right? And we can come in here on top of this, show potential fixes, and say, implement my interface. All right, good. Oh, I got that all set up. Now what I need to do is you can actually refer to instances using the interface. So I can say something like iElectronic device, and let's call this just simply device without, well, like this. Let's just call it device. All right, so we have that set. And now we can get into the specifics of what happens whenever a power button is pressed. So I'm going to come down here and create a constructor for our power button. And it's going to be passed a electronic device. There we are. And then we're just going to say this device is equal to device. All right, very simple. Now what happens whenever we are execute is called on this? Well, we can just simply say device like that, and then go .on and interface directly with the electronic device. Electronic device. See, there's the on, and then we're also going to use the off. All right, and now I'm getting lost. Okay, so that's good. And then undo, we can have that instantly also work, except undo is going to turn it off. So paste that there, device, and this will be off. So we're really getting this to work on the micro level. All right, so now that we have all that set up, we can just go into program and we can interface with our television quite simply with just a few lines of code. So we want to simulate the act of picking up the television remote. How many lines of code does that take? It is not going to take much. So we'll say iElectronic device, and we'll call this TV is equal to, and TV remote. There it is, and get device. See, now everything is acting like a real world thing. So that is the act of picking up the device. And then we want to implement our power button. So we say power button, we just call it power but like that, is equal to new power button, and pass TV to it. So now we know specifically we are working with a TV power button. Now to turn the television on and off a couple times, we just say power but and execute, and it's just going to work. And likewise, let's just copy this. So copy, paste, and what do we call? We call undo. So that's pressing the button twice, and then we can go like this and copy and paste and run it. And you can see that simply by calling that command a couple times, we're able to turn our TV on and off. And of course, we could get much more complicated, and I leave adding the volume up and down and the more complex parts of working with an application like that to you for homework. And up next, I'm going to cover one of an example that is probably one of my most liked examples. I'm going to show you how to implement a fight to the death between Thor and the Incredible Hulk. All right, so now we're going to have some fun. What I'm going to do here is this is going to be our final output. I'm going to create a Thor object and a Hulk object, and they are going to fight to the death. And then what I'm going to do is I think I'm going to have Thor fight Loki, because I think it would be fun to then use interfaces to give the different people fighting different capabilities. And I think that would expand upon it. So if we look here, what's happening? Okay, so Thor attacks Hulk. He does 74 damage, so that's an attack amount. And then Hulk is going to lose a certain amount of health. So what this is describing here is Thor has an attack value and Hulk has a defense value. And then, of course, they also have a maximum health. So what we want to do here, what our aim is to take this somewhat complicated sort of format, and we want to simplify it as much as possible so that whenever we are executing our code, it's very straightforward. So what we, in essence, want to have here is we want to define Thor, and we're going to say that Thor is a type of warrior, and a name is going to be defined. A health amount is going to be defined, so that would show how much punishment he can take, how much damage can he do, and how much can he block that damage, or how effective is he at doing that. And then in essence, we're going to do the same exact thing with the Hulk. All right, so we'll have Hulk, and so we'll throw Hulk right here. And then whenever they battle, we want to keep that also as simplistic as possible. What we want to do is say, okay, here's a battle, and start fight. And who's fighting? Thor and Hulk. There we go. That's our aim right there. And this is the whole goal of object-oriented programming, is to keep the execution of our code extremely simplistic, extremely short, and extremely understandable. And, you know, this is Hulk. But I said I wanted to use Loki instead. So, all right, so that is your first idea, is how can what different attributes are my warriors going to have? What different functions are they going to have? What sorts of capabilities do they have? And then I want to keep the actual creation or the start of the fight as simplistic as humanly possible, and then it just prints out all that stuff. Well, what am I going to have to do here? I'm going to have to come in, and I'm going to have to create a new class, and we're going to call it Warrior. So this is Warrior. All right, there it is. We created Warrior. Now, what is Warrior going to have to do? All right, well, like I said before, we are going to have different attributes. What are those attributes going to be? We already described them. We are going to have public and string and name. Okay, we have to define the names. And why didn't it bring up there it is. All right, so we have a name. What else are we going to have? Well, let's just go like this. And we also have a health amount. So health, we know that. And up next, didn't give me my string. Let's go public. This is actually health. It's not a string. It's going to be a double. So let's make that a double. And what else did we say we need? Well, we need a attack amount. But is it going to be a fun game if every single time they fight, they do exactly the same amount of damage? No. In that situation, if they both had the same block amount and the same attack amount, well, every single time, whoever goes first is going to win. So that's boring. So what we want to do instead is have an attack maximum. And then what we'll do is we will go and calculate a random number and multiply it times that attack maximum to judge how much damage was done. And then also, let's add that same amount of randomness to the block amount. And like I said, later on, we're even going to add like magic moves and things like that, just to make things even more cool. All right, so we need to do random number generations. So we're going to say random, and rand is equal to new random, exactly like this. And whenever you're doing random values like this, you always want to create a single random instance and reuse it. And if you don't do that, you're going to get the same value over and over again. So we're just going to stick with that. Okay, so now it gets to the point where we have to create our constructor for our warrior. Very, very simplistic. We're just going to say public and warrior, and it's going to be passed a string, which is going to be the name for our warrior. So let's just have everything auto-generate here. So we're going to have string and name, and let's give this a default value of warrior. All right, so we have that, and then I like to put all these on separate lines just so it's a little bit easier to see everything. And I don't need random. I'm just going to need these guys, and I'm not going to be passed a random. So let's get rid of that. And I'm going to give default values for all of this also. So I'll say that the health is going to have a default value of 0, and attack 0, and block also. Whoops, why did it give me that? There we are. That's also going to be 0. Okay, so then we have name is name, health, attack amount, da-da-da-da-da, and I'm going to get rid of this because I decided I do not need that. Anything else? Nope. We want to keep everything simple. All right, so there is the constructor. What do we need to do now? Well, we need to be able to generate a random attack amount. So I'm going to go public, and you're going to notice as I'm doing this that for the most part, all of the functions are extremely short in length. So I want to get them as short as humanly possible. So I'm going to say return, and then what I'm going to do is go random and next 1 through whatever the maximum attack amount is. So there is attack max, and there we go. And that is all we're going to do for our attack. And then we get over here and paste this in, and this is going to be block. So we'll just change this to block. And let's also mark this as virtual. So we'll say virtual because we might want to overload this or override it, I mean. And random next, and then this is going to be block max. So change it to block max, and there you go. Very simplistic. Anybody that looks at this is going to very easily be able to understand what this class does, what the attributes are referring to, and what types of capabilities our warriors are going to have, which is our ultimate goal. Now we get into the whole point of being able to simply say battle, start, fight, and they just fight. That's, taking it to the next level. So we're going to create another class. I'm going to go class like this, and I am going to call this battle. So there's battle. We just created it. All right, so this is going to act as a utility class. So it's going to make sense that we only have static methods inside of it. That is all it's going to be used for. So we'll say class and battle. And what types of things are we going to need to do? Well, we're going to have to start the fight, okay? So start fight. That's our very first thing because we call that, and then everything else just works its way out. Then what else are we going to have to do? Well, we're not really sure. So let's go through the process of exactly what happens whenever a fight is started. Well, we'll say warrior 1 attacks warrior, let's just say warrior 2 like this. So we'll say warrior 1 attacks warrior 2, and warrior 2, well, they'll say warrior 2 is damaged and health decreases. All right. And then what's going to happen? Well, we're going to have the warriors have an opportunity. One's going to attack, then the other one is going to attack. So we're basically going to do this, but we're just going to have it be warrior 2 and warrior 1. So we'll just go like this and paste this here. And then this is just simply going to be warrior 2 attacks warrior 1. And then warrior 1 is going to be damaged and health decreases. That's what's going to happen. So let's keep that as simple as humanly possible. Let's think more about what actually is going to go on. Okay, so within these two, what is actually going to happen? We are going to need to get a result. So we're going to say get attack result. And remember, we want to get or keep our functions as short as humanly possible. So we're going to go and we are going to want to have this part right here in a separate function, all of its own. So we'll come down here and we know that we're going to have another function called get attack result. Anything else that we're going to have to do? Not really at this point. I can't think of anything. So what we're going to have to do is just simply decide what's going to happen inside of start fight. So let's go and let's create that. Maybe we'll do it here so that we don't get rid of our comments as we're thinking through. All right, so we're going to have both warriors attack, so why don't we just loop through both of those warriors attacks and see what our results are. So we're going to say public, and remember these are utility methods, so they're going to be static, void, and I'm just going to call it start fight because that makes the most sense. If I can stop hitting my caps locks. Okay, so start fight, there it is. And what's going to be passed to it? Well, warrior 1, so we'll call it warrior 1 and warrior 2. All right, warrior 2. All right, so we have both of our warriors passed inside of here to start fight. But then we're going to have a fight between them, so we need to figure out what exactly get attack result is going to do to us, or do for us. Now, basically what I want this loop to do is to continue looping forever until we get to a point in which one warrior's health goes below 0. Then that's the end of the game. So what exactly is going to happen in get attack result? Well, we are just going to define it. So public static, and it's going to return, let's say, a string, and inside of our looping structure, inside of start fight, it's going to look for that string and cancel whenever it's returned from get attack result. How about that? Sounds good to me. So we got string and then get attack result. And what are we going to be passed? We're going to be passed a warrior. And let's call this warrior A to differentiate it from the warrior 1 and warrior 2 that we used before. So warrior and warrior B. All right, so we have both of those. What needs to happen inside of get attack result? Well, we need to calculate the warrior's attack and the block for the other warrior. So we're going to say double. We'll go warrior A attack amount, and that is going to be equal to warrior A and get that attack from that warrior that was created. And also we're going to do the same thing for the warrior B. So let's go like this, copy and paste. So this is going to be warrior B and this is going to be warrior B also. All right, so we have those attack amounts. Then what we want to do is we want to subtract the warrior B's attack from, or we want to take warrior A's attack and subtract the block amount. I think that makes the most sense. Yeah, so let's change that. Let's change this to block. So let's get the block like this. And then inside of start fight, what we can do is the first time through, we'll pass warrior 1 as the very first warrior and warrior 2 as the second warrior. And then the second time around, we'll just flip those and have this be warrior 2 and this be warrior 1. All right, that makes more sense. Okay, so this is going to be block amount. Makes more sense. Block amount. And and since they're warrior A and warrior B, it doesn't make any difference in what order they're passed in. So we'll say double, and we want to get the total amount of damage done to the warrior. So we'll say damage to warrior B is equal to the warrior A attack amount minus the warrior B block amount. All right. So now we know the total amount of damage that's going to be inside of this. Let's change this to attack. All right, like that better. All right, so now we know the total amount of damage. So what do we need to do now? Well, we need to verify that health hasn't gone below 0. If it does, that's the end of the game. And otherwise, we just subtract the damage amount from our warrior. So we're going to say if damage to warrior B is greater than 0, because it is possible for it to not be greater than 0. Well, in that situation, we'll say warrior B dot health is equal to warrior B dot health minus the damage to warrior B. Okay, got that set. And else, we're going to say damage to warrior B is equal to 0. All right, good. Then what I need to do is I need to print out the message that I originally wrote down and I showed you in the program file. So what we're going to do is we're going to say console and WriteLine, and let's go 0 and attacks, and this is going to be the other name. So 0 and 1 are going to be the names for our warriors, and deals, and we want to say how much damage was done, exactly like that. And then we just need to go and get those values. So we can say warrior, and we'll do warrior A dot name, and this is going to be warrior B dot name, and damage to warrior. So to warrior B. All right, good. And there it is. So that's going to print out the first message. Then what we want to do is provide output on the health change, because we also said that that was important whenever we were deciding what we wanted it to look like when these warriors attacked each other. So I'm going to say 0, 0, 1 has, and I want to get the amount of health that the warrior now has. Health. Like this. And that looks pretty good also. And also maybe we want to throw a new line inside of there so that everything is separated nicely on the screen. Now we're only dealing with warrior B, name, and warrior B's health. So we'll throw health inside of there. All right, so we got all those set. Now what we need to do, finally, is we need to check if the warrior has died. So I'm going to say if warrior B dot health is less than or equal to 0, well, that means warrior B sadly has died. Well, in that situation, let's just paste this inside of there. We'll say the warrior has died and the other warrior is victorious. Is victorious. Victorious. There we are. And then let's also throw a new line in that situation so that everything is divided up. And in this situation, it's going to be warrior B has died and warrior A is victorious. and we do not need anything else to be passed to that. So let's get rid of that damage amount. And then remember what we set up here is that this is going to be returning a string. And inside of start fight, we're going to look for a string. And if it matches, we're going to end the fight. Okay? Because we don't want to loop forever. So in that situation, let's return a string. And just to keep it very simple and very understandable, we'll just say game over. We could return -1 or we could return something else. But no, we're just going to say game over. And then after the return statement, we're going to say else return. And maybe we say fight again, just to make everything very descriptive. We normally wouldn't do this in a program, but I just want, everything to be understandable. Okay, so what we're going to do now is go back up into our start fight area, and we are just going to have the warriors fight until they die. So we're going to say if, what do we want to do? We want to get our attack result. And what are we going to do here? We're going to pass in our warrior 1 and our warrior 2. And we're going to say equal to game over. So if the attack result that is returned is equal to game over, let's change this to lowercase warrior, just notice that. Then we will come down here and say console and WriteLine like that. And then inside of here, we'll say game over. And there we are. And then we can call break to jump out of here altogether. But we're going to do this inside of a loop because remember, we have to have the warriors fight each other. So we'll say while true, continue looping forever. Or until, everything ends. So we got to get this part right here and throw it up into the top. So let's paste that inside of there. And there we go. And let's go and do another one because both warriors need an opportunity to try to kill each other. So we got warrior 1 and warrior 2. What's going to change about this? Well, we can change this to warrior 2 and change this to warrior 1. All right, and I can optimize this a little bit more to make this function shorter, but I just want to keep it like this because I think this is extremely understandable. So I think it's pretty easy to understand that the warriors are taking chances or taking their turns, attacking each other, and we're going to continue doing that until one of these warriors is dead. So that is the goal, and this needs to be lowercase, and this needs to be lowercase also. Save that. Do I have any other errors? Nothing I see. Okay, so let's come back over into program, and I'm going to test this out, see if it works, and then if this works, what I can do is go in and actually have the warriors fight it out with, maybe I'll give Loki superpowers or something like that. All right, so I'm going to say warrior Thor is equal to new warrior, and let's get rid of this. And I'll say that I want to also define another warrior, which is going to be Loki. Paste that inside of there, and this is going to be Loki and Loki. Then the goal is I can just run this one line of code after creating this, and it's going to just automatically work. So we're going to say battle, start fight, and Thor and Loki are passed inside of it, like that. And we'll save it, and let's run it and see if we have any errors. Boom. Doesn't look like it. All right, good stuff. So Loki attacks Thor, deals 10 damage, and Thor has 49 health, and they go and they continue attacking each other until finally Loki has -14 health, and it says Loki has died and Thor is victorious, and game over. So pretty cool. You know what would be more cool is to add even more randomness to what we have right here. And I want to add some more randomness. First off, they have exactly the same health, they have exactly the same power, they have exactly the same blocking ability. Well, we know that isn't true. Okay, so Thor is bigger, which means he can take more damage, and he's also more than likely going to be able to cause more damage, but also we know that Loki is a magic user. So with that knowledge, how can we make this fight more interesting? Well, I think one thing that we could do is we could use an interface. And let's give Loki just one superpower, the ability to teleport. So if Thor tries to attack Loki maybe sometimes, again, adding randomization to this whole entire program, sometimes Loki's able to teleport away and not get hit. So let's go, and anytime we want to add any additional capabilities, an interface normally makes pretty good sense for that. So the superpower we want to give him is going to be called teleports and add. Now inside of this, like I said, this is an interface. So we'll say interface, teleports, and what's going to happen? Well, it's just going to define string and teleport. So Loki is going to either have the ability to teleport or not have the ability to teleport. So that means we need to have a couple more classes. So we'll come in here and we'll say add and class. And what's this one going to do? Well, this one's going to be that can teleport. Okay. So maybe the hero doesn't have the ability to teleport and other heroes do. So we'll say add. And in here, we'll just say class. And then we're going to say that we want to inherit teleports like this. And it's going to give me an error message, which is good. And it's going to say show potential fixes, implement interface. Good. Writes a code for me. And all this is going to do is it's just simply going to say return teleports away. Okay, so there in this situation, Loki would successfully teleport away. Well, we also want to have the situation in which a hero can't teleport. So we'll go up here and we're going to say class, and we'll just call this can't teleport. So can't teleport. Then what we can do is we can have different heroes and we could give them certain capabilities, and some of them will work for teleportation and others will not work for teleportation. So this is how we can go about stacking different capabilities in other classes and then having them work quite differently. So I'm going to say can't teleport. I'm going to inherit from teleports and have it create my function for me. Show potential fixes. There it is. Implement interface. And then we'll say return and fails at teleporting. Okay, just throwing this in here to make this a little bit more fun. Okay, so now what do we need to do? Well, we have kind of a different type of warrior. And this different type of warrior has magical abilities. However, and that is going to affect how block works. But the attack is going to work in exactly the same way. So there's no reason for us to change it. And also, we don't want to have to completely recreate warrior. So what we're going to do is we're going to create a new class. And we are going to inherit what we want from the warrior class. And then create new stuff for our magic warrior. Okay, so magic warrior. And you can have all kinds of different types of warriors. All right, so we have the magic warrior class, and we want to inherit everything from warrior because we did all kinds of work, and we already know that warrior works, so, you know, there's no reason to go in there and mess that up. Okay, so what's different about our magic warrior in this specific situation? Well, the one thing that's different is they can teleport. That's it. So far, that's the only capability. I think it's a great idea if you're watching this video that you go and try to add like armor and different weapons and all that stuff and take them away and add them and so forth. And that's a great way to learn. That's how I started programming many, many years ago, is by making video games. So to make this more interesting, what do? We add randomization. So we're going to have a teleport chance. If they have the ability to teleport, maybe it doesn't work sometimes. That adds some interest. What else do we need? Well, we need to come in here and get the information about teleporting, whether they were successful or they were not. So teleport type, and that's going to either be new can teleport, and there it goes. And then what we can do is we can change inside of here, we can actually change this to can't teleport if there's certain situations in which the hero can't teleport, or the villain. All right, So what do we need to do now? Well, we need to create a constructor. So we'll go constructor, magic, warrior, like this. And pretty much the same exact stuff is going to be populated inside of here. Actually, not what they put here, though. I'm going to be passed a string, which is going to be name equal to and warrior, like that. And also, we're going to be passed double, which is going to be health. And let's give that a default value of 0 also. And double attack max equal to 0. And double block max equal to 0. And then we have a new one, which is teleport chance. So this is going to be like a percentage. Teleport chance is equal to 0. And then what we want to do is we want to have our base warrior class handle everything else. And it automatically popped up there for us. So name, health, attack max, block max, all done for us. So come in here. And then all we need to do is add the little tiny bit that has changed, which is the teleport change, or teleport chance. All right. Now what do we need to do? Well, our blocking is going to be completely different for Magic Warrior because sometimes the Magic Warrior is going to get attacked and they successfully teleport and take 0 damage. So we're going to override that block function. So we'll say double. Everything else is the same. So we'll say double block like that. And let's get rid of this. We need to come in here and generate a random value from 1 to 100 based off of the block chance. So we're just going to create a random rand is equal to new random. And then int random dodge like this is equal to rand dot next 1 to 100. And then what do we need to do? Well, we need to calculate and decide if the teleportation is going to work based off of the percent that was assigned. So to do that, we're going to say if rand dodge is less than this dot teleport chance. Then in that situation, we're going to say console and WriteLine, and let's go and let's just put these variables directly inside of here. So I'm going to say name, and then call our teleport type, which is going to print out the message can teleport or can't teleport, depending upon the situation. So teleport, this is type, is what we're working with. And then we call teleport, makes it very easy to work with warriors that either can teleport or can't teleport. And then we'll come down here. And how can we make it so that, whoops, let's make sure we throw our final quote in there. How can we absolutely guarantee that, remember, we're returning a double, which is going to be the block amount. How can we guarantee that the warrior has 0 damage? Just return a really big number. So we'll do 10,000. All right. No chance the warrior is going to take 10,000 in damage. So we'll say else. And in this situation, we are just going to call the block method in the superclass and let it handle every other scenario. So again, very, very simple. So we'll say base, call the base block function and have it do what it does. And we know it already works, so everything's gold. So basically, the only time we'll ever use this is if the randomization, the random number that generates, tells us that yes, we can successfully block this attack. And now we can go into program. Are we going to change a lot of code here since we added all these new capabilities? Nope. We're not going to change really anything, except we are now going to have Loki be a magic warrior. So we're going to say, let's have him be magic warrior, and this will be magic warrior. Nothing breaks. And the only thing that's different here is we have the probability of teleporting. Let's say that's 50%. On top of that, we know Thor is stronger than Loki. So let's make him 75%. He can take 75% less damage before dying. But remember, he has a 50% chance of teleporting away and not getting hit at all. Let's also say that Thor is more powerful with his attacks than Loki. So let's do that. And then let's say that their defensibility is roughly the same. Do I change anything else? Nope. Code's still going to work. Everything's good, even though we added that new capability. And now you can see that everything is much more interesting. So Loki attacks Thor, does 8 damage. And then right here, Loki teleports away. Thor attacks Loki and does 0 damage because Loki teleported away. His health is not affected. And you can see that they battle away. Sometimes he's able to teleport. Sometimes he is not successfully able to teleport. And in the end, because of the teleportation ability of Loki, even though he was weaker and couldn't provide more damage to attacks whenever he attacked Thor, Thor has died and Loki is victorious. So go ahead, have fun with that if you'd like. Like you could do things like, does Thor have his hammer? If he does, maybe he does more damage with an attack, and you could put a multiplier on Thor's attack that increases it. Maybe Thor throws his hammer to do a certain amount of damage, but maybe it's bonus damage, but whenever he throws it, it like goes away and he has to wait for it to return. You can give either of them different weapons, different armor, different all kinds of things. I've done this tutorial specific. I've changed it every single time I do it. But basically, a version is tutorial many times, and people always have a lot of fun. And in the end, ultimately have a very good grasp on object-oriented programming. All right, so now we're going to move on. All right, so now I'm going to talk about collections. Now, collections, unlike arrays, can be resized, and there's a couple of them that I'm going to cover here. Let's go and import some information. So let's go using and system.collections. This is going to be used for ArrayList, and also let's say using system collections and generic. That's going to be used for dictionaries. And we'll get into covering generics here soon enough. So what do we want to do here? Well, one thing I haven't covered is region is actually going to provide us with a way to collapse blocks of code. So we can do something like region like this, and then have this be ArrayList code or something like that, and then end region. So like this, and you'll see here in a minute what this actually does. So end region. All right, and then we'll be able to collapse these. There's a little tiny thing right here. Let's see if I can zoom in on it. See this guy right here? I can't click on it when I do that, but if I go like this, see it just says ArrayList code. Thought I'd cover that. Okay, so basically array lists are resizable arrays that can hold multiple different data types. So they are extremely useful. So we'll say array list and create one. I'll just call this A list is equal to new array list. And of course, they have numerous different functions available to them, which are very useful. So let's say you wanted to add some different values to this list. Well, we can say a list dot add and Bob. And there you go. You just added Bob. Now, like I said, you can add different data types. So we can come in and say add and 40. Okay, so that's how easy it is to add them. We can get the number of different values that are inside of them by going WriteLine, and let's just say something like count, and get these values by saying a list and dot count, and that will give us our total number of values stored inside of it. I'm going to move this up here. All right, and you can get and another thing that's important to know is that the capacity is automatically going to increase as the different items are added. So we can come in and say something like console and WriteLine and capacity, and this and that, and go a list dot capacity. There's capacity, and throw that inside of there. Let's create another array list. I'm going to call this a list2. Let's go array list. Array list2 is going to be equal to new array list. And there, that's good. And then I can also come in and add an object array. So I can say a list2 dot add range and new object like this. And then we can go and throw in a bunch of values. So we'll say Mike and Sally and egg, just to mix it up. Okay, so we have all those inside of there. We can add one array list to another. So we could say a list add range and a list 2. We can also sort the list if the types are the same. So I'll say a list and let's do 2 dot sort. And you can also reverse them. So a list2 dot reverse. You can also come in and add at a very specific position. So these are 0 indexed. So if I wanted to insert a value in the second index, it starts at 0, second would be 1. I come in and say turkey. You can also remove items. So I could come in and say a list2 dot remove at, and let's remove the very first one. And likewise, you could say list2. You could remove multiple items. So you could say remove range and 0 through 2. You can also search for a match starting at a provided index. So let's come in and do console write and turkey index and a list2 dot index of turkey and 0. And let's run this. Whoops, what's wrong with this? Oh, I forgot a parenthesis probably. Yes, and run it. And here we go. And you can see we have our count, which is 2, our capacity, which is 4, and the turkey index would come back as -1. Does that mean it's last? Weird. Not really weird, but okay. Is turkey the last index? Oh, maybe because I removed all these different items. So I had a let's try not removing all these. So let's do this, run it again. Whoops, I can't do that. There we are. Run it again. There we are. Oh, it still comes back as -1. All right. Well, either way. Okay, so we'll cycle through and then we'll see exactly what we have here. It's probably the most important thing to do, or something that makes sense. We can cycle through them as well by saying Foreach, and we'll do, let's try object O in a list, like that. And then let's just do console WriteLine. That works. And save and run that. And you can see we output all those different values that we have right there. Bob, turkey, 40, Mike, Sally, and egg. Okay. Let's go and get rid of that. What else can we do here? We can also convert an array list into a string array, which is very useful. So we'll say string array, and let's just call this my array equal to. And then what you do is you say string array is what we want to convert. It's just like we did everything in the past. Does this actually line up? To array type of string. Yes, everything's cool. So let's just do everything there. Awesome. We can also convert a string array into an array list. So let's create one right like this. And we'll call this customers is equal to and Bob and Sally and Sue. And then we say array list, and we'll call this customer array list is equal to new array list, like that, and customer array list dot add range, and customers is what we want this to be. So it says to have this be customers, right like that. And there you go. All right, so pretty cool stuff there. I'll run it. Oh, that's not going to do anything. It's just converting it into the different parts. All right. So there's a rundown of array lists, and as the video continues, we'll do more with them. But I'd also now like to talk about dictionaries. Now, basically, dictionaries are going to store key value pairs, and how you create them is you say dictionary like that, and then you define what you want to have inside of them. I'm just going to keep this format and then just change it. So I'm going to store superheroes in mine. So I'll say superheroes is equal to new dictionary and string, and everything else there is good. So to add superheroes to this, just go superheroes dot add, and I'm going to use the key, of Clark Kent and Superman, right like that, and then I'll add a couple other ones. So let's go copy this and paste this down inside of here, and then we'll say Bruce Wayne. So Bruce Wayne, and this will be Batman, and then we'll do Barry West and the Flash, like that. Okay, and if you'd like to remove a key value pair, like let's say the Flash is going off the rails and we don't want him in our supergroup anymore, we can say Barry West like that. It's Barry Allen. Who's Barry West? Barry West is that the name of the new Flash? Allen. Is that right? I think Allen's right. I don't know. You can tell me in the comments if any human being has lasted this long in this video tutorial. Okay, so that's how you remove them. You can go and get the number of keys you have inside. So you can say console.WriteLine and count, and get that, and superheroes dot count, and throw that on there. And what else would we like to do? Well, we could check if a key is present, so we can do console WriteLine and Clark Kent. And what do we want to do with this? Well, we can commit. Let's go down the next line. We say superheroes. I don't know why it's not picking that up. Superheroes. Oh, because I didn't close off the quote. Let's just throw the quote right there. Now it would have shown up. Superheroes dot, and then contains key. You can see contains value also popped up. You probably couldn't because it was so extremely small, but contains value also shows up inside of there. Close that off with a parenthesis. What else can we do? We can get the value for the key and store it into a string if we would like. So we could say superheroes and try get value and Clark Kent like this. And then we could say out string test like that. And then what's neat is we could come in and say console and WriteLine, and then let's go and get this. So we'll say Clark Kent and test gets our value for us, which is cool. Close that off, close that off, close that off. We can also cycle through our key value pairs. So let's say we're going to use Foreach for this, like we almost always will do whenever we're working with collections. Value pair, and this is going to be string, string, string. So let's do all of those. I prefer to call this item in superheroes. That works. And then inside of here, we can say console WriteLine and go and get the key and the value. So we'll get this like this, and maybe we'll output them like this. And then let's go down to the next line. And the first one's going to be the item key, and the next one's going to be the item value. Whoops. And that's all we're going to do for that loop. And also, you're able to come in here and clear the dictionary quite easily by saying superheroes dot and clear, right, like that. And there we go. And we can run this. Whoop, there was an error. Nope, I don't want to build from something that was incorrect. Try get values. What was wrong with that? It's try get value. I just remembered it wrong. There's that. Run it, and now you can see all of our different superheroes. And remember, we kicked the flash out of the group, and that's the reason why we only have 2 there. And you can see all of the other output we got from everything else that we were working with. So pretty neat stuff. All right, so there we go. 2 collections down. Now why don't we talk about queues next? Now a queue is kind of like an old school type of collection, and the way it's going to work is it's going to be a collection that is first in, first out. Let's create one to see how it works, if I can spell queue properly. All right, so queue, like that, new queue. All right, figured that out. All right, so let's go and add some values. So we'll say queue dot in queue, like that. And we'll throw a 1 inside of there, and we'll just add like 2 more values. So copy that, paste, and we'll change this to 2 and this to 3. All right. Well, we can come in and check is an item in our queue. So console WriteLine and 1 in queue. And let's find out if it is. And we do that by just saying queue, get that part right there, and this is going to be contains though. So contains, and we'll look for 1, closing parentheses like that. We can also come in and remove the first item from a queue. Why don't we just do this? So I'm going to copy this, come down here, and to remove it, you go DQ. So DQ, Q, like that. And it's DEQUEUE. Yeah, that's correct. Oh no, we don't put any parameters into it. That's why it was giving me an error. And I'm just gonna say remove 1 or something like that. And what else would we like to do? You can also look at the item but not remove it. And how you do that is by using peek. So we'll throw this here, and I'll just say peek 1. And that's fine. And then this is just peek, exactly like this. And let's come in and copy a queue to an array. So I'm going to create a object array. I'm going to call this a number array. And how you do it is you go queue dot to array. And that's a format that is very often used inside of C#. So you should be kind of used to it. What's wrong with this? Queue's not null here. Okay, don't worry about that. And let's go and print the array. You can quite simply just come in and do WriteLine and string dot join. And you can say that all the individual pieces are going to be separated with commas and number array like that. And you can also print out the items using Foreach. So I forgot a parenthesis, no doubt. There we are. All right, and how we would do that is saying Foreach object in queue. And I'm just going to say console and WriteLine, and we will go and get all those items. So I'm going to say queue like that, and O, which is our value. Let's get that, and whoops, I don't need an extra parenthesis this time. I forgot the quote. So let's come in and get the quote, and I thought I labeled that as O. Oh, I labeled that. Oh, okay. We'll just object O. There we are. Whoops. Get that extra space out of there. It would still work even if I didn't have it there. And see if you can take a wild guess on how you would clear a queue. Well, it just gave you the answer right there. All right, and there you go. And if we run that, whoops, I accidentally hit it on the wrong thing. let's go and do this. All right, and there it works. And here you can see said output. 1 in Q true. I removed it. You can see that whenever we remove a value, it's passed back. And remember, we put 1, 2, 3 in. Whenever we remove the second item, we got 2. And remember, the 1 is gone, so we only get 2 and 3, and so forth and so on. So there is our output. And up next, let's move on to the collection called a stack. As you're going to notice, the collections have very similar format to how they work, which is a good thing. So we'll say stack is equal to new stack, like that. Don't have any arguments in this circumstance. So there we are. And if you want to add items, you use push instead of Q. So I guess that's not quite so similar, but copy and we'll change this to 2, and we'll change this to 3. Okay, so I'm going to do the same things here. I'm going to do a console WriteLine, and what I want to do is I want to take a look at an item. Oh, I didn't even tell you what a stack is. It's a last in, first out collection. Okay, so the queue is a first in, first out, and a stack is a last in, first out. You can think of a stack like a stack of plates. If you made a stack of plates, you're not going to pull the plate off the bottom and break all the other ones. All right, makes sense. All right, so we don't want this part right here. That's how you convert it to a string, by the way, if you're wondering. I'm going to say that I want to peek. That means I want to look, but I do not want to remove anything. So let's go and get that item out of there. And the way that you get it is you say stack.peek, like this. And that's going to give you that. And we'll throw that on there. I'm just going to copy this because I'm going to do very similar things with each part. Let's say that I would like to remove an item. Well, we call this popping an item. So we'll say pop, and we're going to pop the first one, and you just say pop. And it's going to return the value that was popped whenever you call pop. Play this. You can check if an item exists on a stack without doing anything destructive to it. Let's just say contain 1. And then what I'm going to do inside of this is change this to contains and 1. And it'll tell me if it was or not with a true or false statement. You can also copy a stack into an array, and object arrays are very commonly used for this. So we're going to say num array2 is equal to stack.to array, like that. And what else can we do? We can also print using the separation also, just like we did previously with queues. So I'm going to say WriteLine, and then I'm going to say string. Let's go like this. And we'll say string, and we're using join again, just like we did previously. So it's join, and we're going to say what's our separator going to be. That's going to be a comma, and then we want to cycle through this number array 2 and output all of those values. And of course, we can use Foreach to go through, and we'll call this object O in stack. There it is. And output, let's just do like this. And instead of this part right here, we're going to come in and $sign like that and say stack, and this is going to output all the individual values that we have stored inside of there. And throw in a comma or quote, and there we are. And let's run it. And you can see all of our output once again. As we peaked without breaking, well then whenever we did a pop, you see that the 3 is still in there, and you can also see the fact that we're getting last in, first out, as I said previously. So all good stuff. And that is an overview of how to use multiple different collections. And since I mentioned generics previously, I'm going to cover generics right now. All right, so now we're going to focus in on an example that will demonstrate generics, and we're going to do some work also with delegates. Now, basically, anytime you need many overloaded methods that differ only by their parameter, a generic is normally a great solution. And what we're going to do here is I'm going to create a new class. like this. And just for the heck of it, I'm just going to call it animal. It's going to be doing other different things, though, that have nothing to do with animal. I'm just going to call it that. Okay, so there we are. We created this. All right, so what we're going to do is I'm going to have this be class animal, and I'm going to give it a name. So I'm going to say public string name, get our getters and setters, and then I'm going to create a constructor, and it's going to be passed string name equal to, and I'm just going to say no name. Like I said, this isn't going to have much of anything to do. Let's just throw that in there just to get that done. Okay, so now we're going to have our generic, and this is going to be a getSum method. So I'm going to call this public and static, doesn't return anything, getSum. And then how you define a generic is you are going to define a letter that is going to represent this unknown type. Then you're going to go reference T, and we're going to have number 1, and also reference T, the T representing the unknown data type for your parameter that you're working with. All right, so we got number 2. And then what I'm going to do is I'm just going to take whatever was passed inside of here, and I'm going to go double x is equal to convert it into a double, and it's going to work for us. And I'm going to do the same thing for my number 2. So I'll take this, paste this down inside of here, and here is 2, and then I'm going to just output the information. So double WriteLine, and let's get this, and just put in our information that we want to provide. So there's that. And then I'm going to go double x plus and double y is going to be, whoops, have to change this to y. Whoops, y like that is going to be equal to, and then we'll just go and perform our calculation. So I'll say double x plus double y like that. And that's all it's going to do. Like I said, it has absolutely nothing to do with animal, but I just wanted to do this just to demonstrate. Okay, so now what we're going to do is we're going to go over into our program area, and we'll start playing around with this stuff. And now what I need to do is if I'm creating a list that is going to be a generic, I need to define my data type inside of here. So I'm going to say animal like this, and then let's just call this animal list is equal to new list of type animal. And there we go. And another way of creating a list of standard types is to just go list like this and int. And I don't want to call this, I don't like that name. I'm going to call this number list. Number list is equal to new list. And I'm going to come in here and just add an integer inside of here. So I'm going to say add, and I'm going to throw in 24. And then I'm going to add some animals to this. So I'm going to say animal list dot add and new animal, and throw in a name. So we'll say something like name is equal to, and Doug seems good enough. So let's keep that like that. And let's throw a couple other different animals inside of here. So I'm going to say copy, paste, and paste. And then I'm going to name this other animal Paul. And then the other one is going to be called Sally. All right, so I got all of these inside of here. Now I want to insert into a specific index. I can say animal list dot add new animal, and no, let's put it into our first, or into the number 1 index, and I'll say new animal, and I will give this one the name of Steve, like that. Okay, good. And then if I want to remove at a specific index, I can just say animal list and dot remove at and 1. So there's that. And whoops, it auto-completed and put add inside of there instead of insert, which is what I meant. Okay, so what else would we like to do? Well, we could get our number of different animals inside of here. So let's go console.WriteLine and get our num of animals. And that is going to be stored in the count. So we'll say animal list dot count like that. And I can go and cycle through all these different animals as well. A in, and we'll say animal list, and just output them on the screen. Dot WriteLine and a name, perfectly fine. And now I want to go and also, let's go and run this just so you can see what's going on here. Okay, and you can see that I just simply cycled through the animals, and also we printed out the number of animals, which was 3. All right, now I want to demonstrate what I talked about previously, which is generics. All right, so what I'm going to be able to do is I'm going to say int x is equal to 5 and y is equal to 4. Now, with our getSum method we have inside here, we can basically put any type of data type in here that would make sense for summing these values. And we could also go in and make things that normally wouldn't make sense also make sense in that situation. All we need to do, because it's marked as static, is say animal dot and getSum, and then we have to define after the getSum what the t is going to represent in this circumstance with this specific method, and it's going to be an integer. Then we say reference x and reference y, exactly like that. Now we can do it for other different data types. So let's do it with other types. I'm just going to copy this. Let's do it with strings. So I'll come down and just put it right here. And in this circumstance, I'm going to say string, and I'll say string x, like that. Keep the 5 and a 4, and string y. And for these to be strings, however, they need to be surrounded with quotes. So let's put that there. So we'll say like this, or that. I don't know why it's not doing that part. Okay, that's good. And then in this circumstance, when we call the function, we just say, hey, we're passing strings this time. And it's going to automatically work for us. So we'll say string x and string y, exactly like that. And you're going to see that both of them work. So we'll save it, run it, and if we come in here, you can see 5 plus 4, they both work. Okay? So it's what a generic is allowing you to do, is basically to go in there and be able to work with multiple different data types. Now what I want to do is I want to show you how to do basically a similar type of thing using structs. So I'm just going to come outside of our main function that we have right here. And I'm going to define a struct. And this is going to be a struct called rectangle. So we'll say rectangle like this. And what you need to do here is define that it is a generic, which I just did with that right there. And I can move this up, don't need to do anything else. And I'm going to say that these are both going to be, I'm going to have to define a height and a width. Whoops, didn't mean to do that. Let's just say private t, and this will be width, and then private t again, so that it can work with multiple different types. This will be length in this circumstance. All right, and then we can also set up a generic property. So we can say public t width like this, and we can create getters and setters for it. So let's go in here and manually do this. We'll say return width like that, and then also we're going to do set, and width is going to be equal to whatever value we have assigned there. Oops. Value like that. There we are. And let's do the same thing for our length. So I'm going to copy this and bounce down here. paste that inside of there. Whoops, this needs to be uppercase for this property. And of course, this is going to be length like that. And then we just need to change these to length also. So this will be length, and the length right here will be this guy. So length, there we are. All right. And now if you want to create a generic constructor, what you're going to do is you're going to say public rectangle and define T, and let's just have this be W and T and have that be L. And we can come in and say width is equal to W and the length is equal to L, right, like that. And just to make this a little bit more useful, let's go and calculate our areas. So we'll say public string get area, and like that. And then we need to do our conversions to a double that we will be able to work with. So we'll say double, and I'll call this double width is equal to convert, and 2, this is going to be double. There it is. And throw our width inside of there. And then we'll do exactly the same thing with our length. So copy this, paste that there, change this to length, length like that. And this was going to be length also. Okay, good stuff. And then what we can do is return our string with our calculation inside of it. So we'll say string format and $, and go and put our different information inside here. So we'll have our width times our length is going to be equal to, and then we will use our converted form. So we'll say double width times our double length. And is, oops, forgot my quote. Throw that there and throw that there. All right, so that's good stuff. All right, so now let's come back up inside of main and let's mess around with throwing different data types into this struct and see how that works. So I'm going to just say rectangle, and this has to be uppercase. So rectangle like that. And just like before, we're just going to define what type T is going to represent in this situation. So it's going to be an integer. I can call this rec1 is going to be equal to new rectangle like that, and then pass in 20 and 50 for our width and our length. Then we can come in and let's get some output here. So we'll say WriteLine and call rec1 dot get area, right, like that, and like this, and there we are. And then we're going to do the same but with a different data type, and we're going to use strings in this circumstance. So paste this here, and let's call this rectangle2. Again, the T is now going to be considered a string, and likewise must put a string right here. And what we're going to have to do is to come in and have these be strings, of course. So let's go get rid of that, and 50, and this will be rectangle2 that we're working with this time. And let's run it, and you can see that we are able to come in and perform those calculations regardless of the data type. Okay, so let's get rid of that. And what I want to talk about now are delegates. And delegates basically allow you to reference methods inside what we call a delegate object. And the specifics is the delegate object can then be passed to other methods that can call methods assigned to the delegate. And it can also stack methods, and then it's going to perform executions in a specified order. So what I'm going to do is I'm going to come down and create a delegate. So we're going to go after this closes off, this struct. So it closes off right here. So there we go. And I'm going to say public delegate like this. And what we're going to do here is declare a delegate type that performs different arithmetic operations. So we're going to say void and animal delegate. No, I don't want any of that. So I'm going to say void arithmetic like this, and it's passed a double num1 and double num2, right, like that. And then we can assign different methods to the delegate. So I'm going to say that I want to create public and static void add, and we'll say double number 1 and double number 2. And then inside of here, we can just output this information. So I'll say console and WriteLine, and then inside of here, I will just output the adding of these two, or the sum of these two values. So we'll say num1 plus num2 is going to be equal to, and this will be num1 plus num2, exactly like that. And then we're going to do the same, but we're going to do a subtraction in our next situation. So let's go get this, copy, and paste this down inside of here. And here I'll just say subtract. So subtract, double, all the rest of that stays exactly the same, except down here we're going to subtract. So let's do that and like that. Now what we can do is we can come back up inside of main and figure out, okay, so right after this, and let's go right about here. And we are going to say arithmetic, and I'll define add, and I'll define sub and add and sub. Whoops, like that. And this is pretty neat because you can stack these and then have them be executed in order. Okay, so I want to assign just the add method to the object add that we just created. So I'm going to say add is equal to new arithmetic add. And then let's go and add just sub. So I'll say sub is equal to new arithmetic, there it is, and subtract. And then after that, I will perform the operation of adding and then sub, and then using subtraction. So I'll say add sub is equal to add plus sub, right like that. And now we can go and print out our results. So we'll say console dot WriteLine and add, and we'll say 6 and 10. And I have to close that off like this. And then come in here like this. Let's copy that. Paste that there. And what I want to do here is call both methods with add sub. So again, I'll say add and subtract, and change this to 10 and 4, right like that. And then we can go like this and say add sub 10 and 4. And I forgot to come in here and change this. So let's come down here. Forgot to call the add. So we'll go 6 and 10, right like that. And if I come in and run it, it's going to call all those methods. So remember, before we zoom in here, 6 and 10, we're adding those. So we should get 16 as an answer. And then here we're doing add and subtract. So we have 10 and 4. So we're actually going to, first off, add 4 to the 10, and then afterwards we are going to subtract 4 from the 10. You're going to get two different outputs, as you'll see. So we can zoom in, and you can see that's exactly what happened. Zoom in a little bit more. So we said we wanted to add 6 and 10. We did. We got 16. And then we said we wanted to add the values, but then subtract the values also. And we got two outputs just by calling one method. So pretty neat stuff. And we'll get more into that as we continue. But now what I want to do is show you a whole bunch of different functions you can use to work and manipulate lists of data, as well as show you another example of using delegates. All right, just so I can show you another example using delegates, what I'm going to do is I'm going to create a delegate that is assigned a lambda expression. And I'll show you what a lambda expression here is in just a second. So I'm going to say delegate and double, and I will call this double it, and it receives a double value. All right, this is really neat. Okay, so what we're going to do is we're going to come down inside of here. And basically, what a lambda expression is going to allow you to do is use anonymous methods that define the input parameters on the left and the code to execute on the right. So I'm going to say double it and double it and assign a lambda to the delegate. So this is going to be equal to x, and then it is going to basically multiply what is provided by 2. Exactly like that. All right, so what's neat here is I'm going to say console and WriteLine, and then let's just come in here, get rid of that, and I will say 5 times 2 is equal to, and I'll say double it. So double it like that, and pass 5 inside of here, and our closing quotes. Right like that. And I got an error. I accidentally put this in the wrong place. So let's get this out of here and throw it right here instead. All right, so there it goes. And that looks much better. Let's get rid of these extra spaces. All right, so there we are. Got that set up. And let's run it. And you can see that we were able to come in here and perform that calculation. But it gets a lot more. That's just like extremely simple version. Let's go and make this a little bit more complicated. You don't have to use delegates, by the way. Let's tab these in. You don't have to use delegates. I can also just go do something like list and int and number list and say equal to new and list and integer, define this, and then we'll say 1, 9, 2, 6, and 3, and then I can put the number in the list, and then what I can do is I can create a new list, like a list of evens, just by putting only those even values into my list. So I can say var and even list is equal to num list dot where, and here is the input of a as it cycles through the list. And I can say a modulus 2 and define who gets into the list ultimately. And then I can go and convert this into a list. Just throw that inside of there. And I can cycle through all of these guys. So I can say something like var j in even list. And then let's just do console, WriteLine, there it is, and output all of those values, which will all be only the even values. So let's run it, and you can see that yes, indeed, it outputs those even values, which is 2 and 6. Those are the only ones that are even out of those potential values inside of our list. Now what I want to do is I want to add values in a range. So let's come in like this, and I'll just call this range list equal to, take our number list we had before, and I'll say where, and here's our input, and there it is, x is greater than 2, or x is less than 9, and then convert that into a list. So to list, like that, and run it. And why didn't that work? Oh, because I didn't output it. So I'll just cycle through this again. So we'll say for each and copy. And this time I'll work with our range list. So range list range list, and output all of those values. So there we are, run it. And you can see we went 1, 9, 2, 6, and 3 as our output. All right, let's get out of that. Now I want to do a more interesting example. Basically, I want to find the number of heads and tails that are randomly generated, okay? So I'm going to create a list, int, like this, and let's call this flip list is equal to new, list, like that. And they're going to be integers. And I'm going to say int I equal to 0, random rand is equal to new random. And I'll say while I is less than 100, I'm going to say flip list and add a randomly generated head or tail. So I'll say this will be rand next, and I'm going to say 1 through 3, and I will just increment the value for I in that circumstance. Now what I can do is after I generate this, I can print out the number of heads and tails. So let's just do this, and I'll say heads, like that, heads, and get that value out of there. So I can say flip list. Let's put this on a separate line so that it's easier to read. So I'll say flip list, and then I just use my where clause again. So I'll take each of these individual values where A is equal to 1, then it gets put in the list. So I'll say to list, and I specifically want a count for this, and throw that right there. And then I'm going to do the same for my tails. So let's go down here, paste that in there, and this is going to be tails. So TALS, and here I'll say where it is equal to 2. Okay, so I got that, and I got that. All right, so let's run that. And you can see that we randomly generated heads and tails, and we got 54 and 46. So just all kinds of really cool ways of interacting and doing some pretty neat stuff. Let's do some more. So now what I want to do is I want to create a list, and then I want to find all names inside of the list that start with a specific letter. So I'm going to go var and call this name list is equal to new list and string, and we'll have Doug and Sally and Sue. All right, so to find those, let's say I want to find everything that begins with a letter S. So I'm going to say S name list is equal to name list dot, and then put my condition inside of it. So I'll say X, and X starts with, so that I'm going to check whether the string starts with the letter S or not. And if it does, it goes inside, and if not, it doesn't. So we can say for each and var m in name S name list, and then whoops, I should have left that there. There we are. Console, and print those out. And if we run it, you're going to see that it goes and shows us Sally and Sue, but it doesn't show us Doug because his name doesn't begin with a letter S. All right, let's do some more examples. I'm going to talk about select. Now, what select is going to allow us to do is to execute a function on each item in a list. So let's go and generate a list from 1 to 10. And I'll just call this 1 to 10 is equal to new list and int, and throw that right there. And then I'm going to say 1 to 10 dot add range, and I'll call enumerable range 1 through 10, and got that. All right. Now let's say I wanted to get the squares for all these values. I'm going to say squares is equal to 1, 2, 10 dot select and say x like this, and then multiply each of the values in that list times themselves. And then we can come in and say for each and var and L in squares, and then console dot WriteLine, and output all of those different values. Run it. Whoops, what did I do wrong? 1 to 10. Just change that to 1 to 10. Save. F5, and you can see that it did indeed multiply all those values up to from 1 to 10 by themselves and output that value. Okay, good stuff. Now let's talk about zip. And zip basically applies a function to two lists. So what I want to do here is, let's say I want to generate two lists, and then I want to add the values in those two lists times each other, or to each other. So I'll call this list 1 is equal to new list int, and then new int like this. And no, I don't want that there. And I'll go and say 1 and 3 and 4 is what we want to place inside of there. And then I'll create another list that's almost exactly the same. So let's paste this here and change this to list 2. New list, da 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 da. Let's have this be 4, 6, and 8. 4, 6, and 8. Now I can use zip to add those together. I'll say var sum list is equal to list 1 dot zip, and then go list 2, and I'm going to get x and y values, one of those values from each of it, and it automatically did it for me. And then I can come in and say to list, right like that. And then we can go and output that. So we'll say for each and var item in sum list. Looks pretty good to me. And then I will go and output this. So I'll say console dot WriteLine and item. There it is. Run it. And you can see that we were able to add values in separate lists and create a brand new list from them. Pretty cool. Now let's say you would like to come in and you'd like to be able to, well, let's keep this part right here. You'd like to go and sum all the values inside of a list. Let's change this into num list 2. And the naming conventions I'm using are just so whenever you download the code, you don't mess up anything. All right, let's come in, and I just want this part, right? Yeah, let's get rid of this. Oh, let's just get rid of the whole thing. So here's our number list, and I'm going to say 1, 2, 3, 4, 5. All right, just to keep it simple. And then I'm going to say console WriteLine, da 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 da. But what I want to do here is sum these values. So I'm going to say I want to get the sum like that. And how I can do it is using an aggregate. So I can say num list 2 dot aggregate like that, and A and B, and then we will pass this inside of here. Let's throw our closing parentheses, pass those together, and what it's going to do is it's going to perform an operation on each item in the list and then carry the results forward. So we'll say A plus B, because that is what I want to do in this circumstance. And did I get all of this right? What do I need, another parenthesis? Yeah, and there that goes. So let's run it, and you can see that we were able to successfully sum all those values all on one line of code. So good stuff. We can also very easily get the average. I'm just going to leave everything here exactly the same. I'm going to say average like that. And to get the average, you're going to say number list, and then you're going to have to say, let's just get rid of all this. So get rid of all, well, not that ending part. Let's get rid of this. And you say as queryable, like that. And then average. And it'll get you the average of those items inside of the list. And once again, that works out to 3. Okay, what else can we do? Well, we can go and determine if all items in a list meet a certain condition. So let's say here's our list. We're just going to use the same one. And I'm going to say all greater than 3. All right, does our list meet those requirements? Well, you already know the answer to that, but so let's come in and say all. Just get rid of this. All like that. And let's get rid of average. And then inside of all, we'll define our condition. So does everything meet this condition, which is that x is greater than 3? Throw in another parenthesis and run it. And of course, as you know, the answer to that is false. Another useful function. We can also determine if any items meet a condition. So we're just going to use the same list again, and we're going to say any items greater than 3. And we just change the all into an any. That's all we have to do, and run it. And you can see in that circumstance, it comes back as true. All right. What else would I like to do? Well, we could come in and easily eliminate any duplicates inside of a list. So let's just do 1, 2, 3, and then we'll do 2 and 3 inside of here. So 2 and 3. And we use the distinct to do this. So we'll say distinct. And here, I'm going to have to get rid of all this. So let's get rid of all that. And it said we're going to say string dot join. And I want to join everything in here separated with commas and spaces. And then I can just say number list 2. There it is. And call distinct. Like that. And closing parentheses. Did I get them all? There you are. Got it all. Run it. And you can see here that it is only going to show those values and not repeat any values unless they are distinct. We can also go and receive 2 lists and return values not found in both of those lists. So let's say I have our number list here. 1, 2, 3, 2, 3. Let's just leave it that way. Let's create another list and copy, paste that there, and let's call this number list 3. And in this one, I'm just going to say 3. So let's say we want to find out which values in this list are not found in this new list down here. Let's call this except, because that's what we're going to use to find it. And we'll go string join, all perfectly fine. And this is going to be number list 2. And we'll say except, like that, and number list 3 inside of here. So number list 3. There we go. Run it. And you're going to see those values also in a list. 1 and 2 are not found in the second list. You can also go and return values that both lists have. And you're going to use intersect with that. Let's go and change this to intersect. Intersect. Whoops, sect. Like that. And here we'll join them. And I'll just say intersect. Intersect. Like this. Intersect. Like that. And number 3. And we'll do it. And run it. And you can see that it shows that only 3 is in both of the lists. Okay, so a whole bunch of different functions for manipulating and working with lists. And up next, I want to talk about enumerable. All right, so now let's learn about enumerables. I have my regular animal class I've used many times, and now we're going to make a whole form. So we're going to come in here and we're going to go to add and class, and let's make an animal form. So animal form. There we go. All right, so what are we going to do inside of our animal form? Well, we are going to go and have animal form be, or inherit from IEnumerable. And what that's going to do for us is, let's come down inside of here, is we're going to create a list of animals. So I'm going to say private list of animals. And let's just go like this. And then I'm going to call this animal list is equal to new list and, of course, animal. All right, and I should have just thrown this here. There we go, and there we go. All right, so we have to create a constructor for it. So we'll say public and animal farm, and it's going to be passed a list of animals, and we are going to call this animal list. That sounds good. Whoops, it didn't take it. All right, so animal list. And there we go. All right, so we got animal list passed inside of here. And then we just say this animal list is equal to the animal list that was passed inside of it. And then we can create also a empty constructor animal farm. And there we go. So got it. Okay, so what do we want to do here? Well, we want to create an indexer so that we can sort through our list. And we can come right here and go to show potential fixes. And what do we want to do here? Go up to using system collections, and that error should go away. And now it says it wants me to go and get the Git emulator. So implement interface, and it's going to throw that in there for me, which is very useful. And what this guy's going to do for us is it is going to return an enumerator that's going to be used to iterate through our collection of animals. So we can just say return and animal list get enumerator. There we go. Pretty simple stuff. Then, like I said before we got all those errors, that I wanted to create an indexer for our animals. So we'll say public and animal. And to do so, you type this, followed with whatever you want the indexer to be called. And then inside of here, we go and create our getters and our setters. So here, I'm going to return animal and animal list. There it is. And fill this with index. Right like that. And what else? Oh, we have to also throw a semicolon inside of here. And then for our setters, we're going to go set and animal list and insert. And we'll insert index and whatever our value is. Right like that. Okay. So now what we want to do is, let's say we would also like to be able to get the number of animals that are stored. We can continue to add functionality to this. So we can say something like count, and then we can go get and return animal list count. Just that easily. And for now, I don't think I want to add anything else to this. So now what we want to do is go and actually test this out. So I'm going to go back into my program area, and I'm going to create myself an animal farm object. So animal farm, and I'll just call this my animals is equal to new animal farm, like that. And then I can add animals by going my animals and just start at our first index, new animal, and let's call this animal Wilbur. And let's go and add a whole bunch of additional animals. So I'm going to copy this and just throw in some more little guys. So let's make this second index and have this be Templeton. So Templeton. And then in our next, we're going to throw Gander inside of here. So Gander. And then finally, if you're not catching on what I'm talking about, maybe this will give you a hint. Charlotte. There's Charlotte. Now, if I want to cycle through these, I can say for each and animal I in my animals. And just output those onto the screen. And I can say I, and what I specifically want to get is name, which is set up inside of my animals. All right. So we can go and we can run this. And you can see that we are able to cycle through Wilbur, Templeton, Gander, and Charlotte. All right. All of our different animals in our animal farm. And this is a great way to create very customized collection types. What I'd like to do now is create another class. So let's go into here and we'll say add and new class. And I'm going to call this one box. So there's box and click on add. And now I want to show a bunch of examples where we can use operator overloading. And what that will allow us to do is allow our users to interact with very customized objects in really interesting ways. So we're just going to call this class box, and I'm going to create public, and this will be double length, and getters and setters, there we go. And we're going to do the same for width and breadth. This is very interesting. Okay, so I'll throw this inside of there and that inside of there, and we'll go width and breadth. So BREADTH. Okay. So we need to create a constructor, and there it is. And I'm just going to have it be exactly like that, have it auto-generate. But actually, you know what? Rather than do, well, let's do that. And we'll have our length be equal to whatever this is passed in. So this is going to be length like that, and width and breadth. Yeah, let's just leave it that way. That works out pretty good. Likewise, we could come in here and say public and box like this. And then we can quite simply, actually, don't do it that way, better way. We can just go like this, and then colon and this, and pass in our one values, exactly like that. And this is kind of sloppy. Let's get rid of that. Let's bring this up here and just have this be at the end. Just think it looks a little bit better. Okay. And then let's start adding some more additional functionality. So let's say that we would like to be able to add two of these boxes together. How could we do it? So we could say static and box. We type in operator, and then the operator we want to work with, which is going to be just our regular addition operator. And I'm going to say box 1 and box 2. And what we can do here is define exactly what it means to add two boxes together. Well, what it means is we're going to say box, exactly like what they did right here. So let's just allow them to do that. However, I am going to define what's going on here. So I'm going to say length of the output box, and it figured out exactly what I wanted it to do. So that's good. And then we can say width, and it's going to add those. So it picked the most logical thing that I would want to do and automatically generated the code, which is cool. And there we go. And that is a great way to add those together. And then we can come in and just say return, and this will return a new box with all of those formatted for us. Oh, I named this box. So let's just have it be box. All right, cool. And we can also do the same thing. Basically, let's get the total list of different things, different operators we can add here. So there is a list of different things we can define for operator overloading. I'm going to show you a couple more. So let's go and show how we are going to subtract them. So we're going to say, again, static returns box. We define the operator we want to work with. We want to be able to subtract them. So I'm going to say box, and again, box 1, and box, and again, box 2, right like that. Then what we can do is, again, we're going to generate almost at precisely the same exact thing. So we might as well just copy this, come down inside here, paste that in, and what we're going to do here instead is subtract So we'll just subtract them right like this and return those values once again. So how do you define if they are equal to each other? Why don't we just copy all of this right here? So I'll just say copy. And you're basically just defining your own rules. So what we want to do is the operator we want to use this time is that equality operator. And we're just going to say inside of here, if, and define our rules. So we're going to say box 1 dot length is equal to, oops, I think it was going to do it for me. Yes, it did. So there's those, the length and the width, but I also want, why don't we go and put this here, go down to the next line and also say, and again, and it wasn't quite smart enough to figure out that I also was very interested in breadth being equal. That's okay. So we'll say breadth here, breadth, and breadth, like that. So all of those things are equal. If they are, well, in that situation, we want to not return box 1, we want to return true. And otherwise, we want to return false. And have that all set up. And oh, this is a bool, not a box. That's why it messed up. I messed up. All right, Visual Studio never messes up, only I mess up. Now, if you want to check for inequality, we're going to go like this, paste this inside of there, and we're going to say not equal to, like that. And then we'll say if the box length is not equal to, so we'll just throw not equal to in every single one of these. And it's not going to be and, they don't have to all not be equal to, just one of them. So we're going to say or for all of those. And again, do the same exact thing. You also are going, let's make sure I don't, okay. Yeah, you also can define how your object is converted into a string. And how you do that is you can say override. This returns a string. And we are overriding to string. And what we need to do here is return, and then we need to format this. So we're going to get rid of this whole entire thing like that and go string dot format, and output is box with height, and go and get that specific height. And then we'll just say width and get that specific width, and then we'll say and breadth and get that specific breadth. So this is a way to customize your string outputs. And then of course we can just come in and go length, width, and breadth, like that. And there's customized output. You can also convert from a box into another data type. So let's say we wanted to convert into an integer. How can we do that? Well, we're going to just say public and static explicit operator and int. And if you're past a box and you want to convert it into an integer, this is how we can do this. And it looks like I accidentally deleted, yes, one of my curly brackets. And then what you're going to do inside of here is just return and int like this. And we're going to sum them together and then divide by 3. So we could say something like b dot length, and we're going to add them. So we could say b times width, that works. And then it doesn't like breadth for some reason. So we'll say b and breadth. There's breadth. And then what we're going to do after this is divide by 3. So we'll say divide by 3. I don't know. I'm just doing something to do something. You can also convert from an integer into a box. So we're going to do implicit instead of explicit. So we'll say static implicit operator, just like before, and box, and we'll say int I. Whoops, get rid of that. And then what we can do is return a box with the links all set to whatever integer is passed, because I don't know, that seems to make sense. So we'll say new and box, and it'll just be whatever they passed. Okay. So there's a bunch of interesting ways of overloading operators to do some pretty interesting things with. Let's go back into our program section and mess around with this. So I'll leave that there. It seems fine. I'm going to create a new box, and we'll call it box1 equal to new box, and I'll say 2, 3, and 4, just to be simple. Create another box after this. So we'll go copy, paste that in there. Let's call this box2, just to be original. And then let's have this be 5, 6, and 7, 5, 6, and 7. If you want to add them together now with your custom object, you can do so. So you can say box, and let's just have it be box 3. That seems perfectly fine. And I will just add my boxes together, and it'll just work. Box 1 plus box 2. And now we can add boxes. Let's go and convert the box into a string with our toString override that we went and created. So WriteLine like this, and go and output this. I'm going to say box 3 and pass in box 3, and it's going to automatically generate that string of text that we said that we wanted before. And also, let's just copy this. Let's call the conversion into an integer just so you can see what that looks like. Paste that there, and I'll call this box as an integer. And to get this, we just go and get our value, and then we say that we want to convert it into an integer. And of course, this works with the other different data types. And like I also created, we're going to be able to convert it into a box. So we can say box 4 is equal to, and then we'll say box. Of course, this is going to cause some manipulation. So there's box 4. That's how easy that is to do. And let's go and run this. And if we do, we can see that we were able to get our custom string generated for box 3. And also we were able to convert our box into an integer, which was also interesting. And another thing is that sometimes you're going to feel the need to build a simple class that contains fields. And anonymous types are going to work great in some situations. Let's pull out the old Shopkins from the past and say, I'm going to create new, and I'm going to say how much a Shopkin is worth. It's a toy if you don't know what a Shopkin is. So Shopkins. And if I can spell Shopkins, yeah, I got that little extra B in there. And we're going to say that a Shopkins costs $4.99. So $4.99, exactly like that. Well, we're going to be able to go and output these. So we can say console and WriteLine. And we can just simply say that we want the name and the price for the Shopkin. So we'll say cost and $, and there we go. And go and get those individual names. So we'll say Shopkins dot name and Shopkins dot price. And there we go. And what's cool about these is these anonymous types can also be stored inside of an array. So we can say, let's say we want to create a toy array is equal to new, right like that. And then we're going to define this by saying new, right like this. And then go and define a name. Let's say Yo Kai. These are playing cards. Again, toys. Whoops, what did I accidentally do there? I accidentally jumped way up there. Let's come back here to this and define a price equal to, and we'll say this is $4.99 also. And then after this, I have an extra parenthesis inside of here. So we'll say new and get rid of this parenthesis. Whoops, accidentally did that. And then let's go and do something similar. So we're going to say new, just copy this, because there's no point in retyping it. Say new, grab this whole thing right here, jump down to the next line, paste. Whoops. Let's move that new up here just so it's a little bit neater. So new, and we're going to do another of my curly brackets and name, and maybe we'd have Legos or something like that. Okay, so there's Legos, and they're $9.99. Of course they are, because Legos are expensive. There we go. All right, so got those all set up, and now what I can do is I can cycle through them just like anything else. So I'll say for each and var item in our toy array, and output our information. So we'll say console.WriteLine. And then inside of here, let's go and just copy what we did before. So we have all of this. This is all going to be the same, and we'll just change it to item instead. So paste this inside of here, and then we'll change this to item like that, and item like this. Is there anything else I want to do? I don't know. I think that's a good enough example. And then we can go and run it, and we can go and look at our output. All right, and you can see how we were able to go and create those lists and go and output that information. All right, so good stuff. All right, so now I want to talk about LINQ. And LINQ stands for Language Integrated Query. And basically it provides a whole bunch of different tools for working with data. And it is quite similar to SQL, but it can work with data aside from just working with databases. And let's just come in here and let's just do a couple little examples. So let's say we want to create a string array, and let's call it dogs is equal to, and I'll throw in some like famous dog names. So I'll say canine, and there you go. So there's no reason for you to watch me type all that out. So there's some different famous dog names. Now what I'd like to do is I would like to get all the dogs that have spaces in their names. So I'm going to say var and dog spaces is equal to, and you say from, and this is a reference to where you want to pull data from. So let's say, well, let's mark this as dog. This is dog in the dogs array that we have here. And let's go and put this on a separate line as well. I'm going to say where dog, I'm saying each individual dog is going to contain what? I said I want dogs with spaces in their names. So there is a space, and then I want to order by, see, it looks just like SQL, dog, and this will be their name in descending order. And then I want to say select dog. All right. So here is our example code. Now what I can simply do now is if I want to cycle through all of my results, I just say for each and var I in dog spaces, and we could output all these names, everything that matches anyway. So console, WriteLine, good, and I. And that is all we need to do. We could save that and run it, and it is going to list only the dogs with spaces in their name, okay? And we can get much more complicated than this. So let's go and get rid of that. And let's get rid of this also. So there we are. And for our next example, what I want to do is actually create a function. So I'm going to say function right here. And I'm going to call this static int. And it's going to return an integer array. I'm going to say query int array. And like this and like this. Okay, so what we want to do now is I want to create an array of integers. So I will let's just get part of this. All right, so we'll go like this. I'm going to call this nums and equal to, and then I'm just going to throw some values inside of here. So let's say I want to say 5, 10, 15, 20, 25, 30, and 35. There we go. So I have all of those values stored inside of that array. Now, let's say that I would like to be able to get all the numbers that are bigger than 20. How could I do that? Let's go var, and greater than 20 is going to be equal to, and I'll say from num, temporary holding space, and in nums, which is the array we're working with. Then I'm going to say where number is greater than 20, and I'll say that I want to order by num, and then finally I am going to select num. There we go. Now I can go in and cycle through those results again just by saying for each and int num in nums. That's not right. I want to get greater than 20, gt20, gt20, and then I can go and output all of those. So we'll do console, WriteLine, and num, exactly like that. And whoops, where do I have a bug at? Oh, I know, I didn't call this. So there we go. And I'm going to also generate a couple other little examples here, and also I have to return an integer. That's the reason why we have an error. Okay, so what do we want to do? Let's say I'd like to get the type for this. I could come in and say console and WriteLine, and then I'm going to say that I want to get this type, so get type, like that, gt20, get type, and anything else. Oh yes, I want to close off those quotes. Let's say that I'd like to convert it into a list or an array. I could say var list greater than 20 is equal to gt20 dot to list, and I have to designate this as an integer, and then like this and like that, and I could say var array greater than 20 is equal to, and I'll say gt20 and convert this into an array like that. There we go. If you change the data in the query, just understand that it's going to automatically update, which is also good. So we can say nums 0 equal to 40. Whoops, I forgot to hit the equal sign, equal to 40. And we could go and cycle through those values once again. So let's get this and paste that right there. There we are. And then finally, we can return our array, which is what we designated we would return after this was done. So we'll come down here and we'll just say return and array gt20, exactly like that. And there we go. And now what we can do is just simply go and call this function, and then we can maybe cycle through some things or something like those ideas. So I'm going to come up here and select this so I don't have to type it again. Go down inside of main, and then I can say int like this, and let's call this int array is equal to query int array, and there we go. And then I could go and cycle through those values again. So let's just copy this guy right here and paste that inside of there. And this is going to be int array. So we'll say int array like that. And then this will be number. So again, like that. Don't think I have any errors. No, I don't. And you should remember greater than 20. And what did I have? Let's close this so we can look at it first. Whoops. 5 through 35, and we said we want everything greater than 20. Let's go and run it again. All right, and if we cycle through, indeed greater than 20, didn't say greater than or equal to, it said greater than 20. We get all of those different values, and you can see that this is represented as an enumerable, and also we were able to return all of those additional values that were passed inside of there, and you can also see where the 40 is, where we inserted the value, and how that also automatically was updated, which was also very useful. Let's do another example. I went and again, I used my basic animal class that I've been using over and over again. You could pause your screen if you'd like to go and type all that in. Of course, all the code's on GitHub. Can I get everything in one place? Well, you can pause your screen there and then pause your screen. Yeah, that's everything. So there's that. And then also I went and created another class, and it's just simply called owner. So there's that. You can pause your screen and type that in if you'd like. Leave your curly bracket in there, though. Don't get rid of it like I just did. Okay, so you have all those set up. Hopefully you got that. All right, so now let's go in and do another example. Now what I'd like to do here is go and create an array list, and family of animals or something like that is equal to new array list. And then what I'm going to do inside of this is I am going to throw in my curly brackets, and I'm going to go and generate a whole bunch of animals and store them in this array list. So I'm going to say animal, and I'll define name is equal to Heidi and Heidi. There we go. And I will designate that the height is going to be equal to 0.8, and the weight is going to be equal to 18. And there we go. And I'm just going to plug in some additional animals here just so that we have everything. Maybe put some equal spacing there. And then what you have to do, of course, is put a semicolon here at the end. Now what we're going to have to do is come in and convert this into an enumerable. So we're going to say var and fam animal and enum like that is equal to fam animals dot of type, and this is going to be animal. Then I can go and query this, so I can say small animals. So let's say that I want to get animals who have a weight that is less than or equal to 90. So I'm going to say from animal in fam animals enum, this guy right there. I'm going to say where animal dot weight is less than or equal to 90, and order by, and I'll say animal name because it's more specific, and select animal. So it's almost exactly like SQL. It's just basically the main difference is that you are flipping the select at the end versus the beginning. So we'll say for each and var and cycle through all these different animals in small animals. And there we go. And then what I can do is go and get the name and how many pounds each of these animals weighs. So let's go WriteLine, and then I'll say O like this, 0 weighs, and go and get the number or the actual weight. And I'm going to use pounds in this situation. And then I can say that I want to get the animal name. So there's the name, and I want to get the animal weight, which is right there. And there we go. And there's another example of how we can cycle through and do more complex little ideas. And you can see here that our animals, whoops, hit the wrong button. Congo weighs 90 pounds and Heidi weighs 18 pounds. Okay, so there we go. And another example. What do I want to do this time? Let's change these up a little bit. Let's make this a, let's just make this a animal list. Animal list, and I'm mainly changing the name only so that I can keep everything consistent in my code that people download. So I'm going to say Shepherd, German Shepherd, and height. I'm going to set this for 25 and the weight for 77. And I will make Chihuahua. I think that's spelled right. Oh boy, what'd I do? Let's get rid of that. There we are. Okay, Chihuahua, there. Yeah, don't need that I inside of there. And little dog. So make this 7 and make the weight on it be 4.4. And then we'll do a Saint Bernard. So Saint Bernard. I think that's right. And make this 30 and make this weight of 200. There we go. Now what I want to do is I want to find animals where the weight is greater than a large number as well as the height. How do I stack those? Let's call this big dogs. So big dogs, And I am going to go and cycle through all of these. So I can get rid of this. I'm going to be cycling through them. So leave the Foreach inside of there, even though it's giving me an error right now. No big deal. So I'm going to say from dog in animal list and where, and to put multiple conditions, you say dog dot weight greater than 70, and then you just say and I'm going to say dog dot height is greater than 25, like that. And then I can do order by, and I'm going to order by the dog name, and then I can just do select dog, like that. All right. And then whenever I go and output this, I'm going to say, I'll just leave that as animal and just call this big dogs. So big dogs. And then I'm going to say a, and it's going to give me a name, weighs, and there is the number or the weight for it. And then this is fine. And the weight, I could also print out the height if I would like to, but I'm not going to. And then we can go and run. Whoops. Okay. What do we have an error at here? Animal list. Animal list. Says animal list right there. I forgot to turn this into an enumerable. That's exactly how we do that. And let's go and run it. And you can see here that the St. Bernard is the only animal that qualifies for our condition. All right, let's do another example. All right, so this time what I want to do is I want to go and create another list, which is going to be owners, and I want to match those up with dogs. So let's come in here and let's create a couple more animals. So I'm going to go and copy this. Let's go and copy this whole thing like this and paste this right here. And also I'm going to say that I want this to be called pug. So there's pug, and pug is going to be 12 and 16. And then let's throw one more animal in. So we'll throw this in, and I will say that this is going to be a beagle dog. And we'll say 15, and we'll say 23. All right, so there is 23. And then on top of that, I want to add some additional information so that I can match up owners, which I'm going to create here in a minute, with all of these different animals. So I'm going to give all the animals an additional piece of information, which is going to be their animal ID. So animal ID. And we'll say that this is ID1. And let's go and just copy that right there. So we'll copy this and come down inside of this area and paste this here. And this animal's animal ID is going to be 2, like this. And also we'll add another animal. Let's have this be owned by owner 3. And let's just get these consistent. And then we will also come in here. And for this animal ID, let's have this be owner, who owns the pug? Let's just say 1. And let's get this out of there. And then for the beagle, I'm going to say that the owner of the beagle dog is going to be whoever owner 2 ends up being. All right, good enough. All right, so now what I want to do is I want to go in and create all of these owners. And if you don't remember, I went and created this class right here for owner, and then here is the animal class also. So let's go create some owners, and then let's tie them up with the dogs using an inner join. So I'll say owners is equal to new, like this, and I can define all of my owners. So I'm going to say that I want a new owner, and the owner's, curly brackets, name is going to be equal to Doug Parks, like this. And this is an important part. You have to put in the owner ID. Otherwise, you can't match them up with the dogs. So there we are. And then we will do pretty much the same thing that we did previously. Oh, this is going to be owner, not owners. And let's copy this and paste this inside of here. And then this is going to be Sally Smith. So Sally Smith, like that. And she's going to be owner 2. And then we'll come down here and we'll also add in another one. And this is going to be Paul Brooks. And he'll be owner 3. All right, and don't forget your semicolon down here. All right, so let's say that I would like to come in and remove the name and height. I could say var name and height is equal to from A in animals, and I could just designate select new and then a dot name and a dot height, just as an aside there. You can experiment and test all kinds of other different things. What did I do wrong here? Combine this owners list with our animals list. But I also want to show how to convert to an object array. So you can also say array name and height is going to be equal to name and height dot to array. There we go. And I could cycle through this. So just to show you what it looks like. So I can come in and let's just call this var I. And then we're going to cycle through this guy right here. So let's get it and paste that right there. And I'm going to say for each, and we will output let's just keep it very simple and just output all of that information. So let's get this and convert this to a string. So to string like that. And I need another parenthesis. There we go. And we can cycle through. Whoops, we've got another error. Let's figure out what that is. Oh, that's right. I meant to actually have this be set up as an animal array. So let's just change this to animal. Oops. Animal and array. There we are. And then this will just be new and array like this, like that. And, oh, I forgot to put animals. There we are. Okay. Now that should work. And let's come down here. And this needs to be uppercase because that's the way they are in a class. And I think I got rid of all the errors. Okay, so let's run that. And there you can see we're able to come in and get all of that information in regards to the name and the height for said animals. All right, so cool stuff. All right, let's do what we were originally planning on doing, however, which is actually going in and combining the owners with the animals. And let's just come right here. And we'll use the for each this time to cycle through all of our additional information. Now, if I want to be able to join multiple different tables, what I'm going to have to use is an inner join. And the two that I want to join are or I guess they're arrays, is the owner array and the animal array. So to do so, I'm going to say var, and I'm just going to call this inner join because that's what it is. And I'm going to say from animal in animals join owner in owners on animal ID, because those are going to be the two fields that both of them share, where the owner dot owner ID, and then we will say, whoops, there we are, select new owner name equal to the owner dot name and animal name equal to, we can just throw it here, equal to the animal's name. All right, and that's going to be how we're going to be able to join those. Now what I can do is say for each I in, and I'll just call this inner join. Then what I want to do is output the information in regards to which owners own which dogs, or yeah, they're all dogs. And let's just have this be inner join like that. Okay, so console and WriteLine, and I can come in and this is going to be the owner name, and I'll say owns, and then this will be whatever the dog's name is. And then under here, I'll say I dot, and I want the owner name, and also I want the animal name. And there we go. And now we can run that, and we can see that we're able to get both the owner name, if I can get rid of that one irritating thing. Let's just get out of this altogether. Oops. All right, let's run it again. And, okay, this time it works. So there you can see Doug Parks owns a German Shepherd and blah, 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 blah. All right, so there's all the information that we were able to do or pull together by combining those multiple different tables. Now, you can also create a group inner join. So let's say I wanted to get all animals and put them in a newly created owner group if their IDs match with our owner's ID. So I'm just going to put this right here. I'll just ignore the inner join here in this situation. And I'll call this group and join. And that's going to be equal to, whoops, that's fine. I could say from owner in owners, and I want to order by owner dot owner ID and join animal in animals on the owner dot owner ID, where we have an equality, so equals animal dot animal ID into, and I'll call this owner group. And then we're going to say select and stack these by saying select new. Whoops, spell select correctly. Select new. And then I can come in and go owner equal to the owner name and animals equal to from owner to in owner group and order by owner to name and select owner to. This is where that's designated. And in this, for instance, I have to put a semicolon down there. And let's say that I go and I want to track total animals. So I'll go int total animals equals 0. And then I want to cycle through these different owner groups. So I'm gonna leave this for each block here also. And then let's do like a console WriteLine. Whoops. Like this, just to put a space. And then I'm going to do another for each. But in this situation, I have to say for each, and let's move this up here. Whoops, I accidentally put a space in there. For each var owner group, like that, in group join, and down here, say console dot WriteLine, and let's output the owner that's stored in the owner group. So I'll say owner group, there it is, dot owner, and then for each I can cycle through all of the animals owned by that owner. So I can say for each var animal in owner group animals, there we go, and output that, and I could do something like total animals and increment that, and then on top of that, this is just getting a little crazy, just for fun, I can say, oops, I accidentally had cap lock, and I can do WriteLine, and let's say that I want to output, I'll say star, and go and get the animal name on top of that. So you can see we can do rather complex examples here. All right, looks good. and I don't see any errors. Let's run that, see what that looks like. So this is pretty cool. So let's cycle through here. You can see our original information in which we see ownership for each of the individual dogs, but there's some duplication there with the owners. In the second situation, we are outputting the owner's name and then the dogs that each of those owners owned, all with little bullets next to them. So pretty cool, much better example than what we did previously. So there's a rundown of a whole bunch of different things we can do with LINQ, and it might come up later on in the tutorial as well. And up next, I want to talk about threads. All right, so with threads, you can basically execute multiple pieces of code that are going to share your resources and the data also. And what we're going to do is I'm going to take you through a whole bunch of examples to demonstrate them. So what I want to do here is I'm going to randomly just print either a 1 or a 0. Okay, very, very simple. So I'm going to say thread, and I'll call this T is equal to new thread. And I'm going to call a function, some sort of function. All right, so let's create a function here. Come up here, and all it is going to do is call it print 1. And then what is it going to do? What is our amazing function print1 going to do? It's going to have a for loop inside of it, and I is equal to 0. And let's print 1,000. Oops, not 10,000, 1,000. And there we are. And all it's simply going to print is the number 1. All right, so there we are. Pretty simple function. So what are we going to do now? Well, inside of main, I am going to also, let's call print1. So we're going to say print1. And straight out of the box, whenever you're working with threads, it's important to understand that you can't guarantee when your thread is going to execute. And that's basically the whole point of this whole entire demonstration. So I'm going to start the thread that's going to try to print 1,000 ones on the screen. And then what I'm going to do is I'm going to start another for loop. I might as well just copy this. So let's just copy this and paste this inside of here. And what this is going to do is it's going to print 0. That's it. All right, and there's your thread example, and we can go and run this, and there we are. Whoops, maybe let's do, let's get rid of the WriteLine, and let's just do write. I think that'll look better. So get rid of that, and save it, and run it again. Okay, so here you can see. All right, so what did I do? I said that I wanted to call print1 first, right? And I wanted to print 1,000 ones. Well, you can see that that is not necessarily what happens. Because basically when you're working with threads in this circumstance, they are sharing resources. So we start off print 1s, and then the 0s click in, we printed all of them, and then we continued trying to print the rest of our 1s thereafter. And you can just see we're sharing resources here. Pretty simplistic example. Now we'll take it up to a next level, and I'll demonstrate how sleep works. So basically what sleep is going to do is it's going to suspend execution for a certain period of time. So let's create an integer, just call it num equal to 1, and then let's create another. I didn't save that for loop, did I? Yes, I did. All right, let's just do this to 10, and then I'm going to do console and WriteLine, and I'm going to output my number, and then I'm going to come down here and I'm going to say that I want to pause for 1 second. Look, it did it for me. Then I'm going to increment my value for I. And then maybe after this, I want to say that the thread is ended execution. So we'll just come in here and we'll just say thread ends exactly like that. And we don't need to do anything else. We can just save it and run it. And you're going to see that, even though I'm slow, that it is slowly every 1 second printing out an additional video or an additional value. Well, it stopped because of my thing that I'm using, but there are all of the values printed out with a 1 second interval. Now what I'm going to do is take this up to another notch, and I'm going to simulate using another keyword called lock, or another command called lock, which is going to, whenever a thread is executing, lock is going to block another thread from executing until the other thread is done. But we don't need these guys anymore. Owner and animal, let's get rid of those. Yes, I don't want that. And owner, delete. That's from previous example. And I am going to create another class. And we'll come up here and I'm going to say, I'm going to simulate transactions at a bank. So I'm going to create a new class and let's call this just bank account, like that. All right, so there's bank account. What are we going to do with our bank account? Well, I have to put my lock inside of here. So I'm going to come in and I'm going to say private object account lock. And then we're going to withdraw money from our account from this guy. All right, so we have that. And what do we need for a bank account? Well, a balance would be something that would be useful. And just generate my getters and setters for that. And we'll also have a name. And I'll generate getters and setters for that. Whoops, there it is. Okay, got that. And then we're going to need a constructor. So we'll say public and bank account, and it will be passed a starting balance. That's good. And we do not need anything else here. What is it? It's trying to give me all the other stuff. Don't want all that other stuff. I just want my balance set inside of here. And then whenever this is created, it's going to be assigned to the balance. And then what else do we need? Well, we need an ability to be able to withdraw money from our bank account. So this is going to return a value, and we'll just call this withdraw, and then we'll say how much do we want to withdraw from this account. I'm going to have an amount, and this is going to be a little bit more complicated. I'm going to say if and balance minus amount is less than 0, then what am I going to do with it? Well, I'm going to say that I want to stop that and put an error message on it. So I'll say something like, let's return balance after this is done. Well, let's just do this and then return balance to the user. But inside of here, I want to do it like an error message. And it is going to say something like, sorry, and another $sign, balance in account. So it's going to output our balance that we have in our account and say like, hey, you can't take that much money out. Whoops. Let's get this. Cut that out of there. Throw that there in account. Let's get that extra space out of there. All right. And, oh, there's the excess. Let's throw that there. Okay. So there you are. There's our error message, and it's going to return a balance. Now, if we don't have that problem, that means we can take money out of the account. So what we're going to do is we're going to say lock account, lock, and then go and perform the operation. So I'm going to say if and balance is greater than or equal to amount, then let's go like this, and I'll have another message print out here. So let's do WriteLine, and I'll say how much money was removed. So I'll say removed and how much money, and then I will say how much money they have left, which is their balance left in account, like this. And then we can come in and we can go and get the amount, and then after that we go and get the balance minus the amount that was withdrawn, just like that. Then we have to go and decrement this. So I'll take that and then I'll just throw a minus sign in there to decrement that. And then after we do this, once again, we are going to return our balance amount. So there is our balance. What else are we going to do? Well, we're going to want to allow the user to easily withdraw $1 from the account. So I'm just going to create another method here. Let's get outside of withdraw, And all it's going to do is whenever you call it, it's going to automatically withdraw $1. So I'll say, this is a poor person here we're dealing with. Issue withdraw, and like this. So it's not going to return anything. And we're going to just say withdraw, and we'll say we want to withdraw $1. All right, that's all we need for our bank account. So now over inside the program is where we're going to do the more complex stuff. So very first thing I want to do is I want to create a bank account, and I'll just call this account equal to new and bank account. And what we're going to pass inside of it is $10. That's all we have in our account. We're very poor. Okay, so what we can do here is we can actually go thread, and I'm going to show you a whole bunch of side things you can do. So you can go current thread dot name is equal to and main, like that. And current thread is going to provide a way for us to get the current executing thread. Then I'm going to create a whole bunch of other threads. So I'm going to say int I is equal to 0. And let's create 15 of them. So they're going to try 15 different threads. Are going to try to withdraw $1, and we only have $10 in our account. Now it's very important to understand you can only point at methods without arguments that return nothing. So we'll say thread T is equal to new thread and new. And then what we're going to do is say thread start and call account and issue withdraw. And you know what that does because you just saw it a minute ago. And there we are. Okay, so then we're going to say t dot name is equal to, and convert this into a string, and get this like that. There we are. And then I'm going to say threads, this array, is going to be equal to t. Right like that. But I'm going to have to create this. So we'll say thread array is equal to threads. That won't make sense. And there we are. And we said we wanted to have 15 of these. All right, so 15 of them. Good. All right, so we got all that set up. And this is going to be threads, not thread start. Threads. What was I thinking? Okay, threads. Threads. There we go. Now I got it all set. All right. So now that I have these threads, what I want to try to do is to execute them. So I'm going to do another for loop, and we're going to do basically the same type of thing here. So let's just copy this guy right here and paste that inside of there. And what we're going to do is we're going to check if a thread has started. So how you do that is, let's just output this. So we'll say console, and we will say, whoops, WriteLine, and I'm going to say thread, and this is going to be the thread's name. So we'll say alive. And this could get completely crazy if we weren't dealing with smaller dollar amounts. So to get the thread's name, I'm just going to go threads, I, and name, like that. And then I can come in and find out if the thread is alive by saying threads and I, like that, and calling is alive, like that. And there we go. That's going to provide us information in our output in regards to what's going on. Now we need to start the thread. So we'll say threads, and let's just keep that and just change this to start, like that. And then we can also come in and check if the thread has started again. So let's go. I'm just trying to get a lot of output on the screen here. Just throw this right there. So there we are again. And those are just going to execute on their own. And then what we can do, let's get rid of this excess line. We can come in here, and what we can do is we can get our thread priority. Now, normal is what is called default. Basically, changing the priority, however, isn't guaranteed to even work. But it's really best not to really mess with this. But what the heck, I'm just going to output this just so you can see. So I'm going to say current priority like this, and change this to 0. And then to get it, you just come in and get rid of all that, and we just say thread dot current thread dot priority like that. And there we are. And then what we can do is also output, I have that saved, whenever our thread is ending. So we'll say this, and we'll say blank, and this is ending like that. And then we can go and get our current thread. Didn't I type that out here somewhere? Where did I type that? Yeah, so it's going to be thread, current thread, and then I just want the name is what I want to output. And so we'll get rid of all of this, put that right there, and then I'll say that I want the current thread's name. I think I did everything right there. So let's get that there, save that. And if we go and we run it, whoops, what did I do? I have an error. I think I have an error. Do I? Do I have an extra, or am I missing one? Yes, missing a curly bracket. Save that, and let's run it. And you can see how the threads are going to come alive here. So we'll come down here, and then we gotta start getting crazy errors. But basically, you can see here, thread 0 alive, and it's cycling through and turning those threads on. So we go 0, 1, 2, 3, and then we have the first act. So we created a whole bunch of threads here, but then thread 1 then goes and takes $1 out of the account. You can see we started creating more threads. Then we removed $1, $8 left, and continued moving and deleting and taking money out of the account until we get to a point where there's no money that is even left in the account. Let's zoom out of here so we can come down a little bit further. And then what you're going to see is, let's go back in. Here is us trying to take money out of the account whenever there's no money left. And then we just continually get that there is no money in our account. Okay, so they're taking their turns, jumping in there and trying to take money out of the account, even though there is none left. All right, and that is sort of the process of going through and allowing each thread to take its time executing. Now you can come in and actually set it up so that you can pass arguments to a thread, and we're going to create a function that's going to allow us to do this. So we're going to go static and void, and I'm going to call this count2, and it's going to be passed a maximum number we want to count to. And let's go put this inside of there. Let's go and create a for loop. I'm going to say int I is equal to 0, and we're going to cycle as long as I is less than our maximum number. Go like this, and then we can come in and console and WriteLine. And then in this situation, we're just going to convert this. We're just going to print that value out because there's nothing else really to do there. Okay, so we got that little guy up there, and it is just simply counting to a maximum value. What we're going to do now inside of main is go thread, and I'll just call this t equal to new thread. And I'm going to use a Lambda expression to actually pass arguments to this thread. So I'm going to say new thread, and then inside of it, like this, and we will do nothing there. So let's just close that off and have this be like this, and then we can count to, we can call our count2 function, and then we can pass a value of 10 as our maximum number into it. And then we can say, hey, let's get going, start that thread up, get rid of that, and there we go. And another thing that's neat is you can use a multi-line lambdas. So we can say new thread and throw another one inside of here is this. And then we will just simply go like that, and make sure that you close this part off. Actually, it's going to be start at the end of this. So we'll say start like that, and there that is. And then we can come in and we can count to multiple different maximum numbers. So I'm going to say count2, and we'll try 5, and then we can do count to 6 also. And count2, whoops, Let's mess that up. There we go. Count 2 and 6. That looks good. All right. And then we can come in and we can execute this. And you can see how we were able to print these out. So I said count to 10, count to 5, count to 6. That was what I did, right? And oops, let's go and escape out of that. Get this over here. All right. Okay, so count to 10, did it. Count to 5, did it. Count to 6, did it. So there we are. We're able to go in there, pass those values inside of there, and mess around, do some neat stuff with threads. And of course, just like anything, the more you practice with threads, the better you will get at them. Now what I want to do is I want to come in here and show you how to mess around with directories and files. You might get an error, however, unless you might want to start Visual Studio with administration rights. If you do get any type of error where it says you can't read or write to your file, that's going to be completely up to you. So let's say we want to get access to the current directory. How would we do that? Well, we could say directory info equal to current directory is equal to new directory info, like that. And then we're going to just put a dot in there for our current directory. Now what would we like to do? Well, we can get access to a directory also with a path. And we could say directory info again, and we'll call this Derek's directory. This clearly is more than likely not going to be on your system, because unless you have a Derek directory in your users directory. But you know, hey, that's possible, I guess. So let's go C:\/ and users and / Derek, like that. And that's how to get to a specific directory. Now you can go and get the directory path if you would like. So let's go and console and WriteLine, and I'm just going to say Derek's directory and full name. Look at that. Just printed out exactly what I was looking for. Let's get a couple more of these. So I'm going to go and copy this and just change what exactly I'm getting out of it. So let's say that I wanted to get the directory's name. That's the very first thing that seemed to pop up. I can get this. So this is full name. There is the name. I can then get the parent directory by just going parent like this. There we are. I can go and find out what type it is by going attributes. There's attributes. You can go and find out when this was actually created. You could find out when exactly this was created by saying creation time, like that. And you can also come in, if you have administration rights, and create a directory. So we're going to say directory info data directory is equal to new, and this is going to be directory info. And let's say that we want to create this. Let's create it roughly at the same place. Something like this, and users and Derek and C# data, and there we go. And then I say data dr directory create. So I created all those. Let's go. Let's run this. And there we have all of our information. So we're able to get that directory. We're able to get the specific directory name, the parent directory, what type it is. Well, of course, it's a directory. And also whenever it was created. All right. So a lot of information there. And also you can see over in my directory, if I zoom in here, where is it? There it is, C# data. It's right under Apple. I don't even know what these things are, but okay. So that is stuff in my users directory. So we did create that directory. Now, if you'd like to delete that directory, well, we can just highlight this part right here and copy. And you can just say directory like that and delete, and then pass in all of that information. So same exact data that we had before, and like that. And let's see if it gives me an error message because the directory already exists. Okay, because I tried to create it again. It doesn't. It was smart enough. So let's go in here. And where is it? Oh, opened the wrong directory. Derek. There we are. And we can see here that the C# directory doesn't exist anymore. All right, so good. Let's close that. What else would we like to do? Well, let's go and start reading and writing data from our files here. Well, I'm going to get rid of this part. I want it, next time I execute, to actually create this data directory, because that's where we're going to be saving everything to. I'm going to create a string array right here, and let's call this customers equal to, and I'm going to throw some people in. So let's throw my buddy Bob Smith in here, and Sally Smith, and also Robert Smith. There's a lot of all my customers are named Smith. Okay, so there we go. Got all of those. Now what I want to do is I'm going to define the path to this actual directory, or the actual file name that I want to create. So I'm going to call this text file path equal to. And did I save that? Yes, I did. So there's that, and that's the directory where I want to save this to, except I have to also put my file name inside of it. So I'm going to call this test file 1.text. All right, good. Now I can come in here, and if I want to write the array to that file, I can just simply say file.write, and I'll say write all lines is what I want. Write all lines, and I'm going to put my text file path in first, and then it was smart enough to know that I wanted to go and print in the customers. Now what I want to do is that just wrote it to the file, and whenever I execute it. Then if I want to read strings from the file, I can say Foreach, and let's say string and customer in, and here I'm going to say file.read all lines. Good, got it. And this is going to be text file path again. And then inside of this boy, what I want to do is I want to just output that information. So I'm going to say console, WriteLine, and I do want the customer's name, but let's make it a little bit nicer than this, just so you can see what's going on in our output. So I'm just going to say customer like this, and cust like that, and close that off, and there that goes. Any other things I'd like to do? Well, let's say that I'd like to be able to get some file data out of here also. So let's come in. Oh, I can just run this just so you guys can see it. So, oops, there's a build error. What's wrong here? Looks like I accidentally left off a curly bracket. There we are. Save it, and I think that was it. Whoops, hit the wrong button. Here we are. I'll do it again. All right, so you can see here that we were able to, well, it's all the same information. The only thing that's different is right here where we have customer. We wrote that data, and then we pulled it out, and we used it and displayed it on our screen. And we can come down here and actually go in and look. So C# data, there it is. And what is going to open up when I click this? Oh, the notepad. All right, and you can see there it is. It's written in there. So very, very, very simplistic process of going in and actually accessing that information. Now let's go and get some additional file information. So again, I'm going to create directory, and I'm going to use directory info, and I'm going to call this my data directory equal to new and directory info like this. Why isn't it taking? There we are. Directory info doesn't like that. Let's see. I don't know. All right, so let's just go directory info like that. And then, did I save it? C, and C#. All right, good. So we got that guy right there. Now let's say we would like to go and find out all the text files that exist inside of there. So I'm going to say file info like this, and text files, and equal to my data directory, there, my data. And then I'm going to say get files, and then my conditional is quite simply just going to be anything that ends with text.txt. Then come out of here and go to the next line, and I'm going to use the search option of all directories. So let's get every single thing that exists out of there. Now what I can do is I can go and see how many of these I actually have just by saying that I want to get my text file's length. And let's go and put a little bit more information. We'll say matches for the number of strings that we have inside of there, like that, just to keep that simple. All right. And on top of that, let's say that I would like to go and get the file names and output them. I can say for each, and I'll say file info, file in the text files. And there we go. And what I want to do here is I want to output, output the file name. So there's only going to be one in there. We'll do file name like that. And I would also like to get the number of bytes in the file. Let's just copy this right here, paste that right there. And to do that, you say file and length. I'm going to wait on executing all this because I have so many different things going on. Why not? Let's just execute it. So let's run it. And here you can see that we're able to get our customers. There's only one text file. It outputs the text file and the number of bytes that are in the file. All right. So a whole bunch of other additional information. Now, there are numerous different ways to access your file data. Another way is through the use of what are called file streams, and they're used to read a byte or an array of bytes. So let's go string, and let's call this text file path 2 equal to, and inside of here, I am just going to call this test file 2, like that, and close that off. Now what I want to do is create and open a file stream. So we'll say a file stream. Let's just let that be FS. That's perfectly fine. But then I'm going to instead say file dot open. You're going to have to close these after you're done with them. And I'm going to go text file path 2. There it is. And then we're going to say that we want to create it. So we're going to say file mode and create like that. Now what I can do is I'm going to go and create a string that I'm going to write. So I'll say random string is equal to, this is a random string, like this. And then I need to convert it to a byte array. So I'm going to say this, and let's call this rs byte array for random string byte array, and equal to, and we need to say encoding dot default like that, get bytes and random string. All right, good. Now to write to the file, I'm going to say fs dot write and rs byte array, and this is going to be 0, and the byte array length is what needs to be passed inside of it. Now, another thing that's interesting is we can move back to the beginning of our file, if we would like, by just calling position like this and 0. And then we can create a byte array to hold the file data. So we'll say byte like this, and let's call this file byte array equal to new. And this is going to be byte, rs byte array, and we have to pass in the length of that byte array. Then we can put the bytes into our array by saying for int I is equal to 0, while I is less than rs byte array length, and everything was automatically thrown in. Good. And then we can say file and byte array, and each of those individual pieces. However, in this circumstance, we're going to get rid of this and instead convert this to byte fs dot, and we will call read byte like that. And there we go. Now to convert, go outside of this for loop. Now to convert from bytes to a string, and then output that information, we can do WriteLine. Then we say encoding dot default dot, and we call get string and file byte array. There we go. And then, like I said, it's important to close the file stream whenever you are finished. And we can go and run that. And you can see here is our output. This is a random string right there. And if you open up the file, you can also see that there is our string once again. All right, so good stuff. Let's continue here. I don't need that open. Let's close that. Now, in actuality, if you want to work with strings and read and write them to your file system, it's better to use what are called StreamWriters and StreamReaders. Let's create another one, and we'll just call this 3. Works fine. Change this to 3 also. All right, so we have both of those set. Then we want to create a StreamWriter, and I'm just let that be the default StreamWriter and pass in my path. And then what I need to do is, if you want to write to a file, you can just say SW, and this is not going to create a new line. If you just simply say write, say this is a random and whatever. Okay. And then if you want to write with a new line, you can say SW dot and WriteLine, just like we're very, very used to doing. And inside of here, we're going to say sentence, like this. And this will create a new line. You can go and write another one. So just keep writing as long as you would like. So WriteLine again, and we're going to say, I don't know, this is boring, but this is another sentence. There we are, and there we go. And then after we're done, we can close our StringWriter, exactly like that. Now, if you want to open the file for reading data from it, we can go and we have to call StreamReader. And should I just keep everything here exactly the same? Why not? All right, then what I can do is there's a bunch of different ways to access. We can use peek, which is going to return the next character as a Unicode, if we would like to convert that. And we can convert it to actually show the characters. So let's say I wanted to go console and WriteLine. Whoops, there it is. And there we are. And let's get rid of this part. And this time what we want to do is peek. So we're going to say peek like that. And get this information out of here. Come down here, and I'm going to say convert dot to character sr dot peek, and pull that information out of there. And I think, yeah, that's how many I need. You can also read to a new line, so we can say console, do WriteLine like that, and we could say first string. And get that information out of there. And let's come up here a little bit so you can see this. And I'm going to say sr dot read line and close that off and doop doop. There we are. You can also read to the end of the file, starting where you left off reading. So if you want to get everything else, you say console WriteLine and everything else like that. And then we can just say sr dot read to end. And of course you could do that from the very beginning if you would like. And then after you're done, of course, you need to close it. So close. There we go. Don't think of any errors. Let's run it. And here you can see our output. Peek just grabs you the very first character, but of course it gives you a Unicode that needs to be converted into a character. Then you see up to the first new line, and then you see everything else that was stored in the file. And I think you can trust me that everything is in that file. Now the last thing I'm going to demonstrate is what are called binary writers or readers, and they're used to read and write data types. Very useful. So we're going to say 4 and then change this to 4 like that. And then we'll come back inside of here And the very first thing we want to do is we want to go and get our file. So I'll call this dat file is equal to new file info. And we will pass in our path. If you want to open the file, you say BinaryWriter and BW is equal to new and BinaryWriter. There it is. And yeah, we have to pass inside of it the dat file, and we want to open it for writing. So open write, boom and boom. Good. And now what we want to do is we want to create some data to save to the file. So I'm going to go string random text is equal to and random text. And then we're going to create an age. So int my age is equal to 47. And then double height is equal to 6.25. And then we can write our data. So we can say bw.write and random text like that. And there we are. And let's just copy this. I'm going to print all the other stuff also. So paste that in there, paste that in there, and I'm going to put in my age. So my age and also the height. Oops, there we are. Height. There we go. All right, so we have that. Now I want to close this. So I'm just going to say bw.close. And there that is. And then I'm going to open the BinaryReader for reading and writing, or reading data. So I'm going to say BinaryReader is, I'll just leave this be like that and leave that be like that. Everything else is exactly the same. And to output the data that I just put inside of there, I can come in and just say WriteLine. And then what I want to pull out and print onto the screen is going to be br dot and read the strings of information that we have inside of there. So I'm going to say read string like this, and then you're going to use different functions to read different types of data. So I'm going to read the string, and I am going to read the integer, which is an age. This is int 32, and then I'm also going to read what's the last thing, the height. Well, that's a double. So there is a double. There we go. And save that. And then just don't forget to close it after you are done. There we are. And we run it. And you can see that we got our information just as we put it into our file. All right. So cool stuff. There's a whole bunch of different ways of messing around with files. And up next, I'm going to talk about serialization. All right. So now let's talk about serialization. Now, with serialization, what you're going to be able to do is actually store the state of an object in a file stream, and you can pass it to a remote network, whatever you'd like to do. So what we're going to do, let's go in and create our old buddy here, animal. All right. So this is going to be a good one, though. All right. So I'm going to create my animal class inside of here, animal class. There we are. Whoops, I spelled it wrong. I was trying to be fast, and then I spelled animal incorrectly. Let's not do that. All right, let's get rid of that. And let's create it right here. All right, so class, and I'm going to take my time this time. I'm going to say animal. There we are. All right, so here we are, and let's create it. All right, so what we want to do here is we want to define what we want to serialize with this class. So we're going to come in here right after the namespace and put serializable. There we are. Okay, good stuff. So we got that set. And then this is going to be a public class animal. And we'll say I serializable. Let's see if it'll pop up here so I don't have to type that all out. Serializable. There we go. All right, good stuff. Now what we can do is we can come here and click Show Potential Fixes and implement our interface. All right, so we got some stuff done for us. That's always good. And we'll come in here and I'm going to define my constructor. So I'm going to say public class and, whoops. Now what I'm going to do is define everything I want to store in this class. So I'm going to, there's name, that works. And what else would we like? Let's get rid of this extra line we have here. No, it's not. My next one is not description. Let's just copy this line here just to save a little time. Paste this inside of here, and we're going to have 4 different pieces of data. I'm also going to have a double, and it's going to be my weight that I want to store. So I'll say double and weight. And I'll have double, and I'll have height, like this. Did I get it all? Height. There we go. And then I'm going to have an animal ID, which is going to be an integer. So we'll have this be animal ID. Animal ID. All right. Have that all set. Let's create our constructor. So we'll say public animal and just keep it simple there. And then I'm also going to have another constructor inside of here. Let's have this be public animal and we'll have string name is equal to, and I'll have this be no name. Go down to another line. I'm going to have double weight equal to 0 and double height also be equal to 0. And then we can come in and define everything. So we'll say name is equal to name, and weight is equal to weight, and height is equal to height. All right, good. All right, so now what we need to do is I'd like to override toString for this class. So I'm going to say public over, we did this in the past. So anytime they call toString, I'm going to define here what I want to occur. And what I'm looking for here is just to say return and string dot format and go and get some information. So I'll say whatever the animal's name is, and I'll say weighs and go and get the weight. I'm going to have this be in pounds, and is, and go and get the height, and I'll just have this be inches tall, like that. And then I can go and, of course, get all this information. Let's just keep it on the same line. So I'll say name and weight and height. All right, good. Now we get to our serialization function, which is what was automatically placed inside of this for us. We don't need to change anything in regards to the parameters. But what I want to do here is assign key value pairs for all of the data. So come in here, get rid of this, and I'm going to say info dot add value and assign this with name. And of course, it'll just be name. And then we're going to do this for our other additional information. So let's take all this, copy that, and let's throw that inside of there. Then we're going to have our weight. So weight, and of course this is weight. Whoops, weight. And our height, and height, and height. And then we're going to have our animal ID, and this is animal ID. All right, so we have all that set up for us. So now what we want to do is create the deserialization function. And what it does is it removes object data from the file. So we'll say public animal, and we're going to say serialization info and streaming context also. So let's grab both of these, paste those inside of there, and come down here. And here what we'll do is we'll say name is equal to, and this is a string, and we're going to get the values from info and assign them to the properties in this situation. So I'll say info dot get value and name, and this is going to be type of, and we'll have this be string. Then we have to do this for everything else. What do I need? An extra parentheses? What did I do wrong here? String info get value name type of, and this is going to be string. I'm not sure what I did. Maybe it's, what is the error message here? Info is not null here. Oh, okay. Don't worry about that. Okay, so we're just going to go name, and we'll go and do this for our other different data points. Okay, so we'll have this be weight, like this, and this is going to be a double. So we'll say double, and this is going to also have to be converted into double. And then we'll have our height, and this of course becomes a double. So we'll say double, and yeah, don't forget to change this also. This is going to be weight, and this is going to be height, and this is double. And then we have animal ID, so animal ID, which is going to be an integer as we defined it, and animal ID, and then this is going to be an integer as well. All right, good stuff. All right, so now that we have all of that set up, let's go over into program, and we can start using it. Do I have system IO inside of here? I don't think I do. So let's go and say using and system.io, and this is going to be used for writing to a file. And also I need an additional library to serialize an object, and I'm going to serialize in binary format specifically. So I'm going to say system.runtime.serialization dot, and this is going to be formatters dot and binary. There we are. And then we also can serialize into XML. So we can say using system dot XML dot and serialization, which is right there. Serialization, good. And also that is all that I can think of. All right, so let's go and try this out. So we got this, and inside of our main function, I am going to create a new animal. So I'll say animal, and let's call him Bowser, equal to new animal and Bowser, there we are, and 45 and 25. Now what I want to do is serialize the object data to a file. To do that, you say stream, and stream is equal to file dot open, and I'm going to say animal data dot dat, and it doesn't exist, so I'm going to mark this as create, and whoops, I accidentally hit that. All right, good. And then I'm going to go and create a binary formatter. So binary formatter, and there, that's fine, but let's just shrink this down to BF, like that there, and there that goes. All right, so we can move this up here so we can see more on the screen. Another thing that I'd like to do is send the object data to the file. So I'm going to say bf.serialize and stream and Bowser. Good. And then say stream close, right like that. Now what we can do, if we wanted to delete our data, we could say Bowser like that is equal to null. That's one way to do it. And if we want to read our object data from a file, we go and open it again. Let's go and let's just copy this guy right here. So grab this, or actually, no, I can just copy this. So I can go stream, copy that, and let's grab the binary formatter also. So let's go here and here, like this. Paste that inside of there. And what I need to do is change this to open. So let's grab this. And then I don't need the binary formatter part here. It's already been set up. So there's that. And then I can come down here and I can go Bowser is equal to and animal and binary formatter dot deserialize and stream like that. And then I can go stream dot close like this. Now what we can do is I can go and call toString to see this information. So let's do WriteLine like that, and then just say Bowser dot toString, and it's going to output everything I want in a nice, easy way. One thing I just figured out is I'm passing the height and weight and name and all that, but I didn't, over in the constructor, I don't think I assigned animal ID, which I did not. So let's come in here and let's get this and then put animal ID inside of here. And this is going to be an integer. And let's go and give that a value of, I don't know, let's just make it 0 also. And then I can come down here and go animal ID is equal to, and let's have it be animal ID like that. Animal ID. There we are. And there we go. All right, good. So let's come back over here and Bowser, and let's give him a 1 for his value. And let's go and run this guy. I closed it, right? Yes, I did. All right, so let's run it. And you can see here is the data that we expect. Bowser weighs 45 pounds, 25 inches tall. All right, so good stuff. Let's go and close that. Now you're also going to be able to write object data as XML. And to do that, you go XML, serializer, where are you at? There it is, XML serializer, there we are. And this is going to be equal to new XML serializer, there we are, and type of, and this will be animal. All right, then we're going to say using, and you go text writer. Where's text writer? There it is. And let's just call this TW is going to be equal to new, and this is going to be, whoops, I should have just taken that, new and StreamWriter. And here inside of StreamWriter, I'm going to get rid of our stream part, and I'm going to replace that with the path where I want to store it. Now, this path has to exist. So, see, if you just use my code, it won't exist. Like I said before, unless you have in your users directory a Derek directory, which I find highly unlikely. Okay, data, and let's go and call this Bowser.xml, and close that, and then what we can do is go serializer like this and serialize like that. Okay, and if you want to come in and delete your Bowser data, let's come down here. We can just say Bowser is equal to null like that. Now, if you want to deserialize from XML into an object, of course, you wouldn't normally put all this stuff in your main file. I'm just doing it to keep it simple. We could say XML serializer, and I don't like the name of some of this stuff, but I'm just going to keep it this way. I'm going to call this deserializer like this and get rid of that part. And this part is fine, and the animal part is also fine. But what you're going to do now is say text reader is equal to new, and then this is going to be a StreamReader. There that is. And what are we going to do here? Well, we're just going to reference this directory again, so might as well just copy this, copy that, and StreamReader, throw this right here, and paste this inside of here. Throw in your semicolon. Then we're going to go object as equal to deserializer. There it is. Deserialize and our reader. Then we can say browser is equal to and animal and object, like that. And then we can close our reader by saying reader close. And then we can call toString again just to prove that it worked. So let's WriteLine and let's throw browser and call toString like this. And then I just realized since I am already doing this, I want this to show that something has changed. So up here, when I called browser toString, I want to change something about browser, just so you can see in the output that something changed between the first and the second. So let's just change his weight to 50. I don't know, just to do something different. All right, so now what I need to do is, let's say this. Let's say that I wanted to, well, let's go and actually just output this. So we'll run it, and you can see up here that in this situation, we changed the weight for browser, and we're able to pull both of those files and all of that data from said files. And if we come up here and go into my C# data area and open up browser, what do I want to open it in? Why didn't it just open it in something normal? Here, let's just open it in Notepad. All right. You can see here that it is actually XML. All right. And that's how it was stored. So let's get out of that and get out of that and get out of that. All right. So now what do we want to do? Well, let's say we wanted to save a collection of animals. So let's go create a list, and these are going to be of animal type. Oops, forgot to put my bracket inside of here. So let's go like that. And then I'm going to say the animals is equal to new and list animal. All right. Now that I have that set, what I can do is just throw in animals. So I'll say animal, and I'm going to throw this here. Say this is Mario, and 60 and 30 and 2, something like that. And let's go and copy this. So I don't have to type it all. So we'll go copy, paste, and we'll type in Luigi. So Luigi. And let's make him 55, just to make him different. I'm just so that the data is different, just random stuff. And then at the end, I'm going to say Peach, and let's say 40 and 20 or something. I don't know, 40 and 20, and make this 4. Okay, don't forget semicolon. All right, now that we have this set up, let's see if I can keep this all in one little window here so you can see it all at once. Then I'm going to say using and stream fs is equal to new, and we're going to be using FileStream. Didn't pop up yet. There's FileStream, and I need to get the location for my data. So I'm going to go and grab all of this stuff right here. And this is going to be, I'm just going to change it slightly. So I'm going to say FileStream and come down inside of here. And then I'm going to paste in the location where I'm saving this information. I'm going to change this to animals XML though. Animals XML. And I need quotes around this. There that is. And then what am I doing here? I'm creating a brand new file. So I'm going to say file mode.create. And I also want the ability to write. So I'm going to say file access dot write, and file share I'm going to mark as none. All right. And now what I can do is, do I need, yes, I need another closing parenthesis there. And then after this, I'm going to say XML serializer is, and I'm going to call this serializer, let's not call it 1, let's call it 2. This is going to be equal to new and XML serializer type of, well, this is not going to be a type of animal. It's going to be, why don't I put this down on the next line? So serializer, this is going to be type of list animal. So we're working with a list in this situation, like that. And then what I can do is say serializer. Did I get it right? Yeah, to serialize and for my animals. Now, if I want to delete this data, I can say the animals is equal to null. And if I want to read the data from XML, I can say XmlSerializer. And we'll call this Serializer3 equal to new XmlSerializer. And I just type it in again. Type of, and what type is it? It is a list of animals. And everything else there is fine. I guess I can't get everything all in one window at one time. I need more space. And what I want to do here is I'm going to say using, and again, FileStream. Basically the same as what we did in our previous example, but look at another example, why not? And what we want to do here is open this file for reading. Do I have? Yes, good. Okay, so I am going to say equal to file.open read, paste that in there, and of course this is animals XML, so animals XML, and then we can go and get the animals, and I did that right? Yeah, it looks good. And I'm going to say the animals is equal to, and I go list, and the animal type is what we're working with. Close that off, and then say serializer3, and call deserialize. Serialize like this. Pass FS2 and close that off. I have probably a quote problem here. That's exactly what I have. All right, and now what we can do is we can go and cycle through all of these. I think I forgot to put a closing curly bracket here. Yes, I did. Okay, so I got all those. And then what I can do is just cycle through all of them. So I'm going to say for each animal, and I'll just say A in the animals. And then I can just call toString on them to print all of that information out. I called this the animals, right? The animals. Yes, the animals. And then I can just say, boom, like that. All good stuff. And that is all I need to do all that. So cool, cool. All right, and then we can cycle through here and look at what we got. So we have our first two lines, which we did before. We have Mario weighs 60 pounds, and it outputs all of that information. And then just to verify that it actually does still exist, we can come in here and go into animals and that it exists as XML. Ask me later, I don't care. Okay, and you can, where'd it go? There you go. So you can see all of this information has been stored as XML. All right, so good stuff. Learning whole bunches of stuff. And up next, I am going to start talking about databases and how to use those with C#. All right, so now what I want to do, we need a database to be able to start working with databases. So I'm just going to use SQL Server. If you go and type in SQL Server Developer, you're going to get to this page. You might want to put download on top of that. So we're going to use the free version, 100% free. So you're just going to click on this. And then you're going to see something like this pop up. When what we want to use in this circumstance is the basic option. And then you're going to have to accept the privacy agreement. And then you decide where you want this to be installed and click on install. And I messed my system up as much as humanly possible so that I could potentially catch any error that you could ever come across. All right, and then this is going to install, and it's going to take a while. And then whenever it's done, you're going to see something that looks like this. Now what you're going to want to do is click on Customize. And whenever you do, you're going to want to click on Microsoft Update. And use Microsoft Update to check for updates, recommended. Click on Next. Whenever you do, you're going to see something along these lines. Just click on Next. And then what we're going to need to do is go and look specifically for SQL Server 2019 Installation Center. It's been installed in your apps, and you want to click on that. And then you want to click on New SQL Server Standalone Installation, which is at the top here. Whenever you do that, you can go and you're going to need to find your installation media where that's located at. If you want a hint, it is right here. It says installation media folder. So this is where you're going to have to locate that. And so that's exactly what I did right here. And then I click on OK. Now this is going to pop up. Just leave this selected, perform a new installation, click on Next. And then specify free edition, which is going to be developer. Click on Next. You're going to have to accept these agreements. Click on Next. Then make sure you put a check mark here where it says Database Engine Services, and everything else will be perfectly fine. Click on Next. Then I changed this to a named instance, and I just called this Derek Tutorial. You can call it whatever you'd like. Click on Next. And then this is going to pop up. You don't need to check this. That's all fine. Click on Next. And then here you are going to want to click on Mixed Mode, and you're going to type in a password. And the username for this is going to be systemadmin, which is just abbreviated as SA. So just so you know that later on. But here's where you're going to type your password. Click on Next. Here, this is going to pop up. Click on Install. And then that's going to take a while to install. Whenever it's done, you're going to see that this has succeeded. So click on Close. Then what you're going to want to do is go and get the SSMS installation. So this is SQL Server Management Studio. And here you can click on this to open that web page, Install SQL Server Management Tools. And this is what you're going to get. You're going to click on this guy up here. And then you're going to want to open this and execute that, of course. And whenever you do, you're going to see this. So you can go and change your location, do whatever you'd like. Likely you want to keep it where it is. Click on Install. And it's going to take a while to install that. And whenever it's done, you're going to see this. Now what you want to do is you want to go and look for this newly installed SQL Server Management tool. Click on that. And then it's going to load up. And then here is where, see I said login, the user ID is SA. Then you're going to type in whatever password you set up previously. And you can click on Remember Password if you'd like, and then click on Connect. And then you can see everything's set up here. Now what we need to do is basically get this to work with Visual Studio. So I'm going to open up Visual Studio, and it looks weird because I enlarged everything, so it's a little bit easier to see on your screen. You're going to say you want to create a new project, and then C# and Next. And then whatever you want to name it and wherever you want to store it, click on Next. And .NET 6 is fine. Click on Create. Then what you want to do inside of Visual Studio is go to View and Server Explorer. We're going to have a little bit of a hiccup here, but I'll show you how to fix it. And you can see here are our data connections. What we want to do is right-click on that and say Add Connection. And then you're going to say the SQL Server. Click on Continue. And it's going to say that it's missing some packages potentially. And so you want to click on OK to install those packages. And you're going to see this. Click on Install. And then it's going to install. Then I'll go back to View and Server Explorer again. Add Connection. SQL Server. Continue. And you're going to see this pop up. And you're going to be like, what's my server name? I don't know what to put inside of there. And nothing's going to show up more than likely. So what you want to do is you want to go back into SQL Server Management Studio. You want to right-click on this, and you want to go to Properties. Whatever you do, this is what's going to pop up. And you're going to select whatever it says here next to name. In my situation, it says Scarlett Derek Tutorial. Remember whenever we named that? Well, that's where that went. And you're going to want to copy that and then paste it directly inside of here. Then you're going to type in your username, SA, and whatever password you have, save my password. And then you can see here I selected my database name, and I'm going to click on OK. It's going to say that it doesn't exist, or I might not have permission to use it. Would I like to attempt to create it? Yes, I do. So click on Yes. And then you can see it shows up right here. And that is basically the steps you need for installing the database and connecting it and all the database software, and then finally connecting Visual Studio to your database. And in the code that follows, I'm going to show you how to work with databases. All right, so now I have the database set up. So what I want to do is set it up so that we'll actually be able to work with it inside of Visual Studio and start writing some code. So what I'm going to do here is I'm going to say File, New, and Project. And again, this is I made this extra big, so that's the reason why it looks different than probably what you're seeing. And what I want to make here is a WPF app.net application, not a WPF application. They're different. So if we look here, so Windows Forms app. So if we go through this WPF application, don't want to use that. I'm going to make a gigantic video on .NET MAUI, the next video I make. But for now, I'm just going to stick with WPF because we have so many other things going on. This is what you want, WPF app.NET framework. Click on Next. And then we have to give this a name. So let's just call it WPF app 1. That sounds perfectly good. And everything else here is fine. Let's go create. And I'm going to say, don't save for that. Something else I was working on. Okay, so now we have this all set up here. So what we want to do is we actually want to go and create our database. Now, you may not see these things, even though I showed them before. If you want to find them, just go to View, and then you can look for whatever tabs are not showing up. So here's Server, Explorer, and so forth. So this is what I have right now, and this is where we were at whenever I left the last video. So what I want to do is I want to go into our database, and I want to right-click right here where it says Tables. And I would say I want to add a new table, and this is going to pop up, and there's going to be all types of information here. So what I want to do is I want to, well, basically, we already have an ID here. This is going to represent a primary key, but it's currently not in a primary key format. So what we want to do is we want to select it, and then under Properties over here, so let's just go Properties. All right, so whenever we create this table, it is going to have an ID inside of here, and as you can see, it's going to represent our primary key. But one thing we want to make a change to is we want to make sure we select Properties down here, this tab in the lower right-hand corner of my situation, and then select this. And then we want to go to where it has Identity Specification. Let's move this out here so I can actually see it. And we want to change this to True. So set this for True. Oops, you have to open this up first. Is Identity. This is going to be True. So just click this tab right here and then click on True. And then that's all set up for us. So that's good. We can move this over here. Now, what I want to design with these databases is basically just a pretty simple system. I'm going to have some stores. I'm going to have a list of potential products that I have in those stores. And then I'm going to have the actual inventory in each store. And then as we program this, I'm going to allow you to add products, delete products, change products' names, and so forth. But what we're going to do with this guy is to start off, this is just quite simply going to be called store. So we're going to say its name is store. And then we're going to go in and we're going to add additional fields. So I'm going to say, okay, I want to know the name of the store. And then we come to this part. Now, when we have a character here, what this means is this is going to be a fixed length of 10. What I want is a variable length. So I'm going to set this to 50. And then on top of that, I'm going to come in. You can go and work down here or at the top or whatever you want. I want to set this to 100 length because I think that's going to work. And I'm also going to say that I do not want to allow null values, which is the same as saying no value. I'm going to also come in and throw in a street. And likewise, I'm going to change this to a variable number of characters also. So let's throw that there. All right. And you can see it updates up here. I'm going to also have a city and the variable number of characters again. So like this, 50. I think that sounds perfectly fine. I'm also going to throw in a state. Now in this situation, I think it should be a fixed number of characters. And I'm going to mark this as 2. This isn't a database tutorial. This is just, the basics of allowing you to set this up. Maybe we'll have a zip code, and in this circumstance, a int value is going to work pretty good for me. So let's just go and mark this as an integer, and everything else is fine. So we have a primary key, we have name, street, city, state, zip code, and we changed the name of our table to store. Now what we can do is click on update, and it's going to go and update our database. So it's just preparing that right now. All right, and then after it comes up with this message that everything's ready to update, just click on update database. And by the way, if it crashes and you get stuck on that screen, just restart Visual Studio. That's really the only thing you can do to fix that. Now what we want to do is to put some store data inside of there. And we can go into our tables here, and we see that there's nothing showing. Click on update. Now you can see that the store is showing. Then you're going to go to store, and you're going to right-click on it. And you're going to go show table data. And there's not going to be any table data. So what we want to do here is we want to go in and we want to fill in some names and streets, all fake stuff clearly, and state and zip code information. All right, so there's some fake information I threw inside of there. Then you're going to want to go over here where it says data sources. And if you get an error, there are no data sources to show for the selected project. I'll show you how to fix that. You want to make sure that you have your Solution Explorer open over here. So just go Solution Explorer. Where is it? There it is, right at the top. Solution Explorer. Make sure you have that open. And then you're going to go over here where you have your project, WPF App 1. You're going to want to right-click on it. And then you want to go to Add New Data Source. So Add. All you need to do is come over here where you have your app name, WPF App 1, and click on it. And whenever you click on that, go to Data Sources, and now it allows you to add a new data source. So just click on that, and let's open this up a little bit so you can see it a little bit better. You want database. You don't want these other two things. Click on, now let's open the whole window up so you can see everything that's written on here. Click on Next. Data set. Click on Next. And then you're going to see which data connection should your application use to connect. Yes, this is the correct one. You're going to want to come down here where it says yes, include sensitive data in the connection string. And then you also want to check right here where it says show the connection string that you will save in the application. So here is that guy. Then you're going to click on Next. And this right here, you want to copy this and save this because you're going to need it. So I'm just going to copy it. Make sure you don't copy something else and lose it. But it's just, you know, whatever this is. So I'll show you in a minute what we're going to use it for. So we're going to copy that and click on Next. And then this is going to pop up. Here you're going to want to make sure that you put a check mark where it says Tables. And then click on Finish. And there you go. Everything's set up. Then what you can do is over here in the Data Source tab, you can open this up. And you can open this up and you can go to Store if you want to see what this looks like in a prettier sort of vision. You can right click on it and then you can click Edit Dataset with Designer like this. And it'll show you your store and all of your additional information. But we don't need that right now. So I'm just going to close that. Now you're going to open up this code window right here. And we need to import some information to be able to work with this, but I'm going to go and paste in. This is going to give me an error. So what I need to do is take what we just copied and save it inside of here, which is our connection string. So connection string is equal to, and what we want is configuration and manager. It's giving me an error. I'm gonna fix it. Don't worry about that. And then connection string, and then inside it's connection strings like that. And then what we're going to do is throw this bracket in here, not parentheses, and you're going to say WPF app 1, which is the name of your application, and then properties dot settings dot, and here is what we copied from before. So you just paste that inside of here. And then at the end, you mark this as connection string. Right like that. And in the videos, and in the code that follows, I'll show you how all of this is going to work. But we need to go and get this guy. So what we want to do is we want to go over here under your Search Solution Explorer, and under References right here, you're going to want to right-click on References. So there that is. And then go Add Reference. And then you want to make sure that you have Assemblies selected up inside of here. And then what we're specifically looking for is System Configuration. So let's open this up. So make sure we get the right thing. So System Configuration, this is what we want. Just put a little check mark inside of there, and then click on OK. And there we go. All right, so now what we need to do is go and import that. So right here, we're going to come up here and say using System Configuration. So configuration, there it is. There it is, and there it is, and your error went away. And there you go. And up next, we're going to start playing with our database. All right, so now I'm going to add some more tables. So let's just go over to Tables over here in Server Explorer, say Add New Table. Now, I actually kind of prefer to just type everything in. That's normally what I do because I'm just used to doing it this way. So what I want is, remember, we're going to have a store, we're going to have products, and then we're going to have a relationship table that's going to lie between them and sort of merge what's in the product and the store tables. So I'm going to call this product. And this is all fine and primary key, except I want identity at the end here. And then what I'm going to do is I'm going to have manufacturer. These are going to be shoe stores, if I didn't mention that. So we're going to have the manufacturer and var character, just like we did before, 100 and not null. And why don't I just copy this? So I'm going to copy this and throw in one more column, and this is going to be brand. So manufacturer will be something like Nike, and the brand is going to be something like Air Force One or something like that. All right, not null, and I don't need this here. And now I can click on Update, and then whenever it takes, Update Databases. Like I said, if that crashes, just go and restart Visual Studio. All right, so now that we have that set, we can close this, and we're going to create another table. So let's just come in and add new table. And for this, what we're going to be doing, actually I should have, why don't I do that first? I'm going to go into here, and I'm going to go into tables and product, and I'm going to add some new products here. So I'm going to say show table data. And I'll just go and add a couple products. So I'm going to say Nike is what I want to have here. And let's go, whoops, like this. So we'll have some room so we can actually read what we're writing here. And then here I'm going to say Air Force One. And I'm going to say Nike. And I don't know, it's Nike or Nike. I really don't care. I grew up thinking it was Nike. And if it isn't, well, I don't know. Okay, so if you're actually hearing me talk about this, I'm just glad that you stayed this long for the video. And if you did, why don't you take a second and tell me, because I will be absolutely amazed. Okay, so I'm going to say Brooks and Ghost, and I don't know. I'm trying to just throw some random different types of shoes inside of here. Zero. Brand, I think that's what those are called, and New Balance 327. I think that's a shoe. Okay, so we have all of those inside of there. Now let's go and create another table. So we're going to go to Tables, Add New Table, and then I'm just going to type everything in just like I did before. And this is going to be the individual store inventory for each store. You know, what shoes do each of the stores carry? So int not null primary key, and I want this identity again. And what I'm going to just simply store inside of here is the store ID, and this is going to be an integer, not null. And I'm going to do the same for, say, this is going to relate both those tables together through the same type of ID. Okay, so this will be product ID. Get rid of this. There we go. Click on update. And then update database again. All right, so good stuff. Now what we need to do is select our application over here, and then you're going to go Alt, Shift, and D, like that. And here are our data sources. And we want to right-click our database. So right-click on this, and then we want to say that we want to configure our data source with wizards. What we need to do is to basically set up our foreign keys. So we have our tables right here, and we want to make sure we have product and store inventory selected, and then click on finish. And there we are. Now what we want to do is let's come over here to this guy, and let's refresh this. Okay, there's store inventory. And we want to right click on store inventory and click on open table definition. And we're going to set up our foreign keys for this store inventory. So how you do that is, let's move this up here so you can see everything all at one time. You just come in and say constraint, and let's call this store foreign key, something like that. And this is foreign key, which is going to reference our store ID. And then we say references and store. This is the table name store and the ID inside of it. And make sure you put commas everywhere. And we're going to copy this. Let's put a comma there also. And copy this right here, because we're going to basically do the same thing. So we're going to go here, and we're going to say product, foreign key, product, foreign key, and then this is going to reference the product ID. Here's the product ID, here's the store ID. So this is going to be product ID, product ID, and references, and in this situation, it's going to be the table named product and the column named ID inside of that. And then of course we come up here and click on update again and update database. And there we are. Now what we want to do is to populate this store inventory table that we have. So I want to go and get this. There's store inventory. I want to right click on it and I want to show table data because there is none currently. And I have no idea what I have. I just realized. Okay, so we got product. And you can see there are our different product types. Actually, what I want to do, let's just close that. I want to go over into my Server Explorer, and I want to right-click on this, and I want to say New Query. And inside of here, I'm doing this only to see what I put in there, because I totally forget. So I'm going to say, select everything from product, like that, and then you hit this little run thing, execute. And it shows I have 6 items inside of here. Now what I want to do is, so I'll just remember product 6. And from this, I'm going to say, how many stores do I have? Because I don't remember. All right, so let's do this. And I have 5. Too bad I didn't have 6. But I have 5 stores. All right, good enough. So what I want to do is I want to populate this guy, which is going to be my store ID. So I have 5 stores and 6 products. So I'm going to say that this store, here, let me open this up so you can see what exactly I'm doing. I'm going to use the identification number for the store, so like this, and I have 6 products. Let's say store 1 has the first item, and store 1 also has the second item. And I'm going to do 2, and whoops, can't do that. Whoops. All right. Let's say it has 1 and it has 3. And there you go. I went and updated everything that was inside of there. I didn't think there was any reason for you to have to sit there and watch me type a bunch of random numbers. But basically, I have stores 1 through 5, and each of them has different products. So that's what the products reference here. So store 2 has product 1 and 3 and so forth and so on. I think that's understandable. Now let's go back over where we were creating our queries. And what do I want to do? I want to do an inner join just to make sure that that took with the store inventory table that I created. So I'm going to say I want, let's say, product, and this is going to be a product, and I'm going to say that I want the brand returned. So that's not the manufacturer like Nike, it's something like Air Force One instead. And I'm going to say that I want to get this information from my product table. And I'm going to do an inner join. Sorry, this is just a way of joining tables. This really can't become a SQL an SQL Server tutorial also. And I'm saying SI. I'm just going to type out everything, and then I'll explain what every single thing means. So PID is equal to SI dot product ID, and I'll say where SI. I'm going to explain this. Just give me a second to put it all inside here. Okay, so I have all of this here, and we can go and run it as long as I didn't do anything wrong. Whoops, what did I do wrong? Oh, I see. I forgot to reference this. Okay, make this P. I think everything else there is fine. Let's run it. And yeah, so it worked. Okay, so what I did here is I said I want you to select all brands from the product table, and an inner join, what it does is it merges the store inventory table with the product table. So it's like they're the same sort of thing. But on this is an abbreviation, so I don't have to keep typing out, or an alias, so I don't have to keep typing out product. And this is an alias, so I don't have to keep typing out store inventory. Okay, so that's what's going on there. So what I'm saying is I want every product in our store inventory where the product ID is equal to the product ID for the store inventory. So in essence, I'm saying I want everything that store one has, and where we're going, and this is the condition, where the store inventory store ID is equal to 1. Okay? So hopefully that's understandable. Like I said, you can leave questions in the comments, and I'll expand upon that. But I'm basically just saying I want all the brands that have a store ID for store ID 1. All right? Hopefully that's understandable. Got a lot of this SQL out of the way, at least for now, and now I'm going to start coding. All right, so now let's create our interface. This is going to be pretty simple. One thing I did here is I went and put Store Inventory Manager in the bottom part. I typed that in. So that's the only thing that's changed since. Okay, so what are we going to do here? Now, this isn't going to be the prettiest interface ever, but it doesn't matter. By the end of this, you're going to know how to be able to use databases, and that's the ultimate goal. So what we're going to do is click on Common WPF Controls right here, and then just start dragging some stuff over. All right, so what do I need? I need a label. So let's bring this over, and I'm just going to stick it inside of there. And then let's see if I can double click on this. Yes, I can. And I'm going to say that this is going to be stores. That's what we're representing there. Don't hit enter at the end. Just go like this. What else do I need? Toolbox. I'm going to need a list box. So I'm going to grab a list box, drop it over here. Don't drop it on top of your stores. And let's just move it up so that it looks okay. It's way too big. So let's go and shrink this down dramatically and place that. And then down here, or I don't know how it got down there, but let's move it up here so that it fits the different samples we have here, 1 through 5. All right. So now what I'm going to do is I'm just going to select both of these, and I'm going to copy them and paste them and drag this over here. And let's just put some distance between the two of them. And come in here, select stores, and we're going to call this store inventory. After you see this interface, I think it's going to help a lot for understanding what's going on here. All right, and then let's do another paste, and we'll drag this over. Whoops. We'll grab this over. What happened? I thought I did it. Let's undo that. All right, let's undo that all together, and let's go. Let's check down here to see if we went and created it or not. No, we did not. All right, see, we have one label and one list box, so we know that we've created 2 of them. Okay, so I'm going to go and let's move this down a little bit more. All right, so let's select this and this, copy, paste, and not sure why it is not pasting that in there. Okay, it wants to be difficult with me, so I'm just going to say undo. And yeah, can't do that. All right, no big deal. So let's just go and create another one. So we'll go and label, drop that there. There it lines up, so you don't have to worry if it's being testy with you. It doesn't matter. And we're going to select this. I'm going to call this all products. All right, so what we're going to have is we're going to have the store names. We're going to have the inventory for each individual store. And then we're going to have a list of products that can be carried in any of the stores. So hopefully that's understandable. And let's go. And after I get the whole interface done, you'll be like, wow, this is so simple. For some reason, it insists on having my list boxes take up the whole screen. I just realized. All right, so let's bring this over here. Sometimes Visual Studio can act a little bit weird. And let's come down here. Let's shrink this down to right about here, which is roughly the same as before. And we'll drag it over here and throw it in right there. All right, that looks good. And it looks like it lines up pretty well. Okay, so good. So we might want to move that around because I'm going to have to put all kinds of other things. What else are we going to need here? Well, I'm going to need the ability to add stores and delete stores. Same with inventory and products. How am I going to do that? Button sounds good. So let's go get a button, drag a button over here. And let's just bring it so that it's under here a little bit, but up against that. And inside of here, oops, you see what it did? It actually created a function that is going to allow me to define what happens when that button's clicked. Well, I'm not going to name it button click. I'm going to give it a better name than that. So what I want to do is, let's say content button. So you can see I can change the text that's inside of here with the content area. And I'm going to call this add store like that. And also, I think that let's make it a little bit wider. So let's go like that. All right, good. Copy, paste, and let's see if it messed it up. No, it didn't. All right, good. So let's go like this. And then for the content on this one, this is going to be called delete store. So we'll say delete store. All right, so we got all our buttons there. They're looking fantastic. Let's see if we can copy and paste them, save ourselves a little bit of time. And there we go. And over here, what we're going to do is we are going to have add inventory. So we're going to be able to go and get inventory from here, from all these lists of potential products in the store, and just pop them over there. And we'll go to delete store. This is going to be called delete inventory. And we will be able to do that as well. And let's go and select these, copy, paste, and drag them over here. And you can see here that our list box is not the total perfect size. So let's go and try to make it just a little bit nicer. Take that extra minute to fix that, no problem. And here we're going to say add product and delete product. And then we're going to have the ability for the users to go in and add new products and manufacturers and brands and all that other additional information. So it says delete inventory. This is where we are, right? And yep, see, this is slightly highlighted. I'm not sure if you can see that or not. And let's come in here and go to products. So we're going to be able to add and delete products. So we need the fields to be able to facilitate that. Can't do it just with buttons. So we're going to need another label. I'm going to go label, and this label right here is going to be called product manufacturer. There it is. And we'll just drag that and put it over here. And we're going to be labeling, giving these all names so that we will be able to, I mean the fields, the buttons, the list boxes and such, so that we'll be able to reference them inside of our code. Come over here. And for this, we want a text box, not a text block, a text box. So let's drag that right there. And let's put it in the center. I think that looks the best. And how much space do we want to give it? Let's stretch it out a little bit more so it lines up with that. That looks a little classier. Copy, paste, and we will also allow them to enter a product brand. And this is all coming from the different fields that we have inside of our database. If you don't remember, Server Explorer. And what are we doing here? Well, this is going to work for inventory as well as products. So let's just look at products, manufacturer, and brand. That's where they show up, and that's good. If we go over here and look at the stores, what do we have? Well, we have a name, we have a street, a city, state, and zip. So we're going to have to put all that information here also because we want to give them the ability to add new stores. So let's go over here and get a label, throw that there. And this is going to be store name. And how should I line this up? Maybe line it up with the top here. Store name, and maybe spread this out a little bit. Yeah, let's try that. That looks good enough. And then we're going to go and get another text box. So text box. And let's drop that there. And throw it there. And we're just, do you want to stretch it across so that it sort of fills the area? Something like that looks pretty good. All right, so we got both of these. Let's copy and paste. And then let's come down here. And for this one, this is going to be store street. So just highlight this and street. And that's good. Let's grab this and this, copy, paste. Drag this down, and the next thing I believe I had was the store city. Yes, that's normally how I do it. Why won't it let me select that? Hello. All right, you want to be difficult? Let's just go city. No, you can do it either place. And city. And normally we would line this up much better, but like I said, I'm just trying to keep everything as completely understandable and simplistic over the prettiest interface you ever did see. All right, and here's store city, and let's highlight this, and store, and after the city, I had the state, and let's highlight this and this, copy, paste, and then I'll go give them names after I finish this. So there's that, and for this one, I am going to have the zip code, and we'll just call this zip code, because that looks good enough. All right, so there is our complete interface, and now I think you have a pretty good idea what's going on here and what we're going to have to utilize to make this guy work in our database. Now what we need to do is name all these parts. So this gets a little bit more complicated. So let's go and highlight the store and then decide what we want to do with the label. I am a big believer in going and labeling everything. So let's come in, and I don't believe this has a name. I'm looking across. No, it does not. This guy's the one I'm talking about. And I could come in here and I could name this. A lot of people don't name everything. You know, it's a label. If you don't plan on changing it, then why name it? But whatever, I'm just going to do it here because why not? Okay, so we have a name for our label up here. What would I like to do now for our list box? Well, the list box absolutely has to have a name. So we're going to come in here, and what I want to do for this is go and give it a name that is equal to, and I'm going to call this store list, and that's good. And am I going to have to click on anything? I would think there is a chance, and what I'm referring to is if they click on a list box item, am I going to have something happen? Well, yes. If they click on a list box item, I'm going to, or one of the stores that's listed here, it's going to show the products in that store inside of our center area. This is never going to change unless something's deleted or added. This is never going to change unless something is deleted or added. This will change every time they click on a different store. So yes, let's go and look and see what that's called. So does it have a click event assigned to it? It does not. All right, why don't we just put a click event on it? So I'm going to say that selection changed. This is what you use when you're using list boxes. And I'm going to call this store list. And I normally have some consistency here, but in this situation, I'm going to call this selection changed. And that is just going to point out that it is a list and it's going to make it stand out. It's just something that I do to make the list selection stand out versus the clicks on buttons. which are going to have less convoluted names. All right. Then we have store inventory. I'm just not. I'm in this circumstance. Do I want to have it? Oh, why not? Why don't we just take the time and do it? Okay, we might want to dynamically change the names or something at some point. So let's just come in and let's just do that also. So I'm going to paste that inside of there. And what should I call this? Let's just call this store inventory. Whoops, what happened? Did something incorrect. Store, maybe just simply because that's the same name. I bet you that's what it is. Inventory, and let's just keep it brief. Inventory label. I bet you it's mad because, yep, I gave it the same name. That's what got it all upset. All right, so up next we have this guy right here, and I'm going to give that a name, of course. And do I need to give it a clickable event or a changeable event? No, I don't need any of that. So I'm just going to call this name is equal to, and let's just keep it simple and call this store inventory. Inventory. Oops, no space. All right. Then we have our label again. Name is equal to, and for this one, I'll call this all products label. So all, maybe lowercase, all products label. And like that. And then we have another list box, which is going to be this guy. And I'm going to call this product list. Name is equal to, and product list. Like that. All right, so we have all of those all set up. Now we get to the button part. And for this one, I am going to go, and first off, I'm selecting Add Store. And I want to see if there is a click assigned to it. It's third up from the bottom. And the generic name it gave it was button click. That's not a very good name, so I'm going to go and change that. And what should we call it? Let's call this add store click. Much better. All right, and then the one under it is delete store. So let's go and get rid of this. And, well, let's move that over there. I can leave the click part on there. And for this one, I'm going to call this delete store click. Delete store click. Very understandable what's going on whenever you click on those. All right, now I have add inventory. So I'm going to call this, and I'm going to keep its consistency even though it's getting a little bit long in the name. Add inventory click. And whoops, I already have click there, so let's get that out of there. And let's continue. So for the next one, we have delete inventory. So I'll call this delete inventory click. Delete inventory click. And for the next one, we have add product. Guess what this is going to be called? Add product click. And then we have delete product click. So delete product click. Anything else? Well, whenever they select these boxes, do I want anything to change? No, not really. One thing that is very irritating, though, is I don't like the fact that it says text box in all these. So I'm going to get rid of all those. So I'm going to select this, and here it is. And it looks like I have to scroll to get rid of the text box part. So the text is just going to be nothing. So you'll see that go away whenever I save. Here, I'll just save it. See? Went away. And let's move this up so that I can see this a little bit better. All right. There's another one that has text box inside of it. Let's get rid of that. Let's get rid of this one. Let's get rid of this one, and this one, and this one, and the last one. All right, so I think I got rid of all the text boxes. Looks like I did. And I think that is probably all that I have to do. Yep, all the text boxes are gone. The interface in general looks pretty good. So let's save it. And if we have to make any changes as we go, no problem. And I'm going to generate all the functions largely just by double-clicking on these boxes, which will be really cool. All right, so what are some things that we're going to have to think about whenever this loads? What's the very first thing? Well, one thing is I want a list of stores to show up here, and that is going to come from the database. So let's jump over into our code and let's just start making that happen. So I'm going to come over right outside of the main window method we have inside of here. And I'm going to go private. And what this is going to do is just update the store names in our little interface. So I'm going to call this display stores. And there we are. And anytime we're accessing a database, you are going to want to surround everything with try-catch blocks. So let's just go and do that right now. Now, the very first thing I want to do here is I want to define a query that I will be using to pull the store names out of the database. So that's going to be select everything from, and the name of my table in my database that has my store information is store. So there it is. So I'm just defining a query inside of here. And if you go, there's, see, store, uppercase S. All right, select everything from the store. Well, what do I need to do now? Well, I'm going to show you at least 3, maybe 4 different ways of pulling information from a database. Clearly, in your code, when you're writing this, you're going to use the same style of pulling information. You're not going to use an adapter sometimes and not an adapter another time. I just want to make you aware that there are different ways of connecting and pulling information from a database. So I'm going to show you all of them. I'm going to show you like 4 of them. Okay, so SQL data adapter. And what this will allow us to do is both connect to the database, run queries, and also close the database connection. And I'll just call this whatever they named it, SQL data adapter. Sounds good. And what you need to do for this is you need to pass it the query that we just created, and then also an SQL connection, which is that guy right there. All right, so now what I'm going to do is I'm going to say using SQL data adapter, I am going to go and use our queries and the connection to populate the list with the different store names. So what am I going to need inside of here? Well, I'm going to need a data table. So I'll say data table, and let's just call this store table, which is equal to new and data table. There it is. And there we go. All right, so there is our data table. And this basically is just going to act as an interface between the database and the code that we're going to be using. And then I'm going to go SQL data adapter and fill. And we will be using our store. We will be putting information into our store table. And then I need to define the column we are going to displaying in our list box. Well, that is our store name. I want to display the name inside of there. So what we're going to do is I'm just going to say store list dot and display member path, and that's going to be equal to the name that we have here. And what else? And store list is the name for our interface. So store list, if we click on this, look, store list. So we're referencing these names, and we're both pulling information from these, as well as later on we will be changing the information that shows up inside of there. What else would I need to do? Well, I need to define what is unique about each item in our list. Well, the names potentially could be, but I know one thing that will always be unique, and that's going to be the name. So we'll go store list, and we'll say selected, or the ID. Is that what I said? I don't know. So I've been making this tutorial for a while, so I apologize if I said something incorrect. The ID is unique. Okay, good. Then I need to come in and say store list item source, and the content we will use to populate the list is going to be defined here, which is going to be our store table, which is right there, and we call default view, like that. All right, so now that we have that set up, what do we need to do? Well, we have this inside of a try block. You might not notice it. There's a little red line here and it says, hey, I don't like what you got going on there. Well, that's because I didn't put the catch part in here. So I'm going to say catch exception, and let's just have this be EX, and I'm just going to make this extremely simple. I'm just going to say message box show EX, and maybe we'll do like toString or something. So toString, like that. And close that off with the parentheses. And yeah, that looks like that's going to work out. So what we can do now is we can come in here and test it. Actually, it is going to crash. I know it's going to crash because I defined the buttons and gave them names and things like that. And then I did not go and create functions for them. That is a requirement. Here, you want me to prove it? I will run it. So we'll run it, and it's going to give me all kinds of errors. See, that's the error that it doesn't like it. If I define a button and I give it a name and things like that, it insists on those functions existing, which is fine. So let's just go and write some more code just to think about the simplistic things we need. Well, one of the things I had up here was for this guy right here, the one that I actually have selected. Remember, I had this is highlighted, and it says selection change, store list selection. Let's go and double click on this. And look at that. It went and created the function for me. So what am I going to have this do? So anytime one of these items is in the list is selected, what I want to do is I want to display my store inventory. Okay, well that means I need to create a function for that. So let's do it. Let's do it here. Okay, so what we're going to do is we're going to say private void and display store inventory, like that. There we are, and there we go. All right, so what I want to do, and what this is going to do is just display the shoes the store has in inventory. And again, we're accessing a database. What should we do? We need to go try, and we also need to do the catch block. So let's go and copy this, and let's paste this down inside of here. Now, what are we going to do here? Well, I need to go and find the shoes that match for a specific store, and that means I'm going to be merging tables and such. And what does that mean? That probably means we need to create an inner join. I don't think I even need any of this. I'm just going to do this. Okay, so I need to create a query that is going to give me all the products that are held in a specific store. So I'm going to go string query. I apologize that I can't also teach SQL Server. I have many videos on databases and such. And if you guys decide you want me to go and make a SQL Server tutorial, I will. Just leave information in the comments. So what I'm going to say is I want to select everything from the table name product, and I'm giving it an alias of P, so I don't have to type product over and over again. And then I'm going to say how I want this data to be joined together. So I'm going to just type inner join. And then I'm going to say I want to look in store inventory, the store inventory table that I'm going to call SI just for convenience, and on. And in this situation, I'm looking for situations in which the product ID is equal to the store inventory product ID, like this. And also, I'm going to say where SI, store inventory, dot store ID is equal to, and this is going to be the past store ID that is going to be provided, and how it's going to be provided is whenever they select the store in this list. So whenever they select one of these stores, that's how we're going to be able to get that additional information. So now to be able to use past variables, you have to use something called SQL command. So I'm going to go SQL command, and the past variable is going to be the store that was clicked in this list box. So that's where that's coming from. So SQL command, let's just call it SQL command because I think that's what it wanted it to be called anyway. So that's good. Is equal to new, and this is going to be SQL command query and SQL connections passed inside. It wrote all the code for me. I don't even have to do anything. Okay, so now what I need to do is go in here and connect to the database, run the query, then close it. I'm going to use a data adapter again. Probably going to do like some data adapter stuff, and then I'll just give it this name right there. And then I'll show you how to do it without a data adapter. And SQL data adapter, right like that. And with this guy, we need to pass inside of it the SQL command, like that. And there we go. Now what I'm going to do is I'm going to go and populate the list box with the store names. So I'm going to say using SQL data adapter, and we need the ID click to be able to perform this query. SQL, and this is why we use SQL command, parameters, and this is going to be called add with value. And the value, what I'm doing is, see, it has store ID here. Well, I need to get the store ID that was selected and then put it here so the query can actually be executed. And how I do that is I just say store ID, like that. And then I define where it comes from. Well, the name of the list box is store list. And what I want is the selected value. So I'm just going to go allow that and get rid of this part. And the value that they selected inside of it. Okay, so now what do I need to do? Well, I'm going to go and create a data table again. And I'm going to call this inventory table equal to new data table. There it is. And like I said before, this acts as an interface between the database and the actual code that we're writing. Then we'll go SQL data adapter dot fill that inventory table like that. And I can move this up here. And then after that, I need to define the column we want to display in the list box. So this is going to display, let's say this instead of the manufacturer, because Nike obviously manufactures numerous brands, as does every other shoe company. So we're going to say store inventory display member path. And what I want to display is the brand. I don't even know if that's the right term, but like if you have Nike Air Jordans, what I want to display is the Air Jordan part of it. What is unique about each of these? Remember, we talked about this last time. The unique thing is more than likely always going to be the ID in this table. So ID. And what else do we have? The content we will use to populate this list. So we'll say store inventory dot and items source, and that's going to be equal to the inventory table and default view, just like before. Now down inside of here, we're going to have our little message box, and everything else there is probably going to be fine. So what other things am I going to have to do with this interface? Well, another thing I'd like to do, I don't think I need to do anything else here inside of the code part of this. Okay, so what else would I like to do? Well, I'd like to display all the different products that are here. And then after I do that part, then I'm just going to double click on all these to create those functions, and then I'll make them work. But I want to make sure that what I've done so far is working properly, because if not, well, then that's a problem, isn't it? For the last one, for store list selection changed, what do I want to do with that? Well, I said that I want to go and call this function. So I will call display store inventory. Copy, paste it down inside of here, and there we go. All right, so we have all those set up. And now I just want to list all of the different products that we have. and it is largely going to be exactly the same as this. So I'm just going to copy this, and I'm going to come down here right after this method ends, paste that inside of there. And then this one's going to be called display. Why don't we call it display all products? Display all products. And to do so, I need to say from, and this all needs to go away. Don't need all that complication stuff. What I'm going to say is I just want everything from the products table that we have created. And this line stays exactly the same, and the adapter stays exactly the same. To differentiate this, I don't need this part right here, so I can just get rid of that altogether. This is going to be a product table, so instead of just leaving it be inventory, which wouldn't make any sense, I'm going to call this the product table. And of course, if that changes, all these other ones have to change. So we'll say product table and product table. Actually, I don't even know what parts I need here. Okay, so I have this. I don't need this fill part, so I can get rid of that. And what else? Oh, no, I do need that. I need that. So SQL adapter fill product table. Of course, yes, of course I need that. And this is going to be called the product list. Let's get this out of here. And product list is the name that I gave for the list inside of my interface. Again, I'm talking about this guy right here. So product list is the name of that list box. Let's paste this inside of here. Product list and product list. All right, display member path. What are we going to display? We'll display the brand. That works. ID's fine. Product table. All of that is fine. So that all looks good. All right, good stuff. So what else am I going to need to do? Well, now it gets to the point where I'm going to go and double click on all of these buttons inside of here so that the functions are automatically generated so I can go test everything. So there's that, add store, and after my store is added, let's do add inventory. Let's do those first. And go back here and add product. Good. And then we'll do the delete part. So delete inventory, and then we will go and create those. All right, have all that set. Now I think I have every function or method for every single one of these. Let's run it and see if it works. And it is not. It's not grabbing the data from my database and displaying it. Why is that? I probably forgot to type something in. And of course I did. I need to call these methods that I created inside of the main window. Otherwise, guess what? They don't do anything. So I'm going to say display stores, and I'm going to say the other one is called display. What did I call it? All products. There it is. There it is, and close that and close that. All right, now it should work. And I'm going to go start, and hopefully it is going to, yes, it did. Look at that. Look how awesome this is. Look, we have made progress. So I am trying to get this to work. Let's go this. And hopefully you can see that. There's the names of my stores. There's the names of my products, and I can go through them. And now that I'm looking at this, maybe I want to give myself a little bit more space. So let's go and select all of this information, and let's move it down. Got all kinds of room here to work, so I might as well go and actually have these all be a little bit longer. Can I do that without breaking the whole interface? I think that I can. All right, good. So I think that looks a little bit better for now. So let's save that. Nothing broke. All right, so great. We got a couple things working here. We're pulling information from our database. We're displaying that information, and now what we need to do is to make all our buttons work, and then allow us to add new products and new stores, and also change the inventory that we have in our stores. All right, so let's do add store click first. Now, what I like to do when I first create a button is verify that it actually is working. So I'm going to go message box dot show, and I'm just going to say add store clicked. And that's going to display if I click on that button. So let's come up here and run it and add store. Hopefully a message box pops up, and there it did. Add store clicked. shows up right there. So good stuff. We know that our button works. And I could do that with every single one of my buttons, which I normally would. All right. So what I want to do now is I want to add a store. Well, I have to add the name, the street, the city, the state, and the zip code just to get the store name to show up over here. So there's a lot of information that we're going to need. So what I want to do is I'm going to actually go and create an SQL parameter list, and I'm going to store everything inside of it. So I'm going to say list, and this is an SQL parameter. And why don't we just call that parameters? That's good. SQL parameters, except this is going to have curly brackets, and then we're going to, no, I don't want that. All right, let's just do this. And let's go and get this and put it on the next line and go new SQL parameter. That part's good. And then I need to define all of the individual pieces. Now, just like we did up here, where did we do it? We did it right here. See, at store ID, we are going to use this at symbol, but then tie it to a place where we're going to pull the information, like the, I did it somewhere else. Where did I do it? Where did I do it? Store ID, data table. Oh, maybe I didn't do it. I thought I did. I didn't. Okay, so this is the first time I'm going to do it. So I need to pull this information from the text box that is right here. Did I give these text? Yes, I did give these text boxes names. Let's just verify that. So store name, here it is, and text box. And did I give it a name, or did I forget to do that? I did. Okay, so for each one of these, I'm now going to have to give them a name, so I'll be able to pull information from them. Actually, while we're at it, why don't we do it for this also? So let's select this. There's the text box, and it needs a name equal to, and let's call this product menu, just to give it a little bit shorter name. And here, this is going to be the name is equal to product, and this is going to be, let's just call this brand. It's a pretty short name after all. Then we're going to do the same for here. So we'll come in here, and this is going to be name is equal to, and do I want this to be lowercase? I think I do. I'm going to make this store name like that. And this, I'm actually not going to change much. Let's just copy this and go to the street area. That's selected. So let's paste that in there and change this from name to street. So street. And then go and select, oops, what did you not like? Store street. Oh, didn't like it because that's there. Okay, so store street, store city, and paste. Make sure I put a space there. It will get upset, as we see. And city. And then I need the state. So store state, like that, and that. And then finally, the store zip code. I know I could put the telephone number, but I think this is enough information. I think you get the point. And what should I call this? Let's just call it zip. And like this and like this. All right, so now all those have information that I can pull from and also add to, more importantly. So, new parameter. I'm going to reference the name. So, name like this. And then then you have to define what type of data it is. It is a variable number of characters long. Look at that. It automatically populated it for me. The only thing is, it forgot to allow me to put my value in and where I'm getting it from. So the value is going to be equal to store name. That is the name we just gave to our text box. And if I want the text out of the store name, I have to type in text. And now I got it. So I'm going to be able to pull that out of there and then use it to be able to add new stores every single time they click on that. So that's cool. And the next thing I have is the street. And put these in the same order that your database is set up. So name, street, city, state, zip. All of them in exactly that same order. So we have street, also a variable number of characters, but this is called store street. So let's change that to street. and then on to the next one, and grab this. And this is going to be the city, and this is okay. This is going to be called store city. And come down to the next line, and this is going to be the state, like that. Fine. Oh, state is different, isn't it? State is not state. Let's go into our store area and a table definition. And our city is, our state is n characters. Okay. So there we are. So we'll change that. And this is going to be, just get rid of the variable part. And that's cool. And this is going to be store state. And yep, it found it. And then on to the next one. And this is going to be the zip code. So store zip. And the zip code is an integer. So let's change this into an integer like that. And the name of this is zip like that. And text is cool. You don't need this. I think you don't, it doesn't bother you if it's in there, but I got rid of it anyway. Okay. So now what I need to do is go and create a query to access this. And this is going to allow us to insert values into our database. So I'm going to say the query is going to be equal to, and this just simply says insert into the table name store the values that we pulled from our text box, and we're going to put them in order. So remember, n name, we're getting these from the text boxes that we have. At street and at the city and at the state and finally at the zip code. And there that is, and there that is. All right, so now what? Let's go SQL command and SQL command. There, just let it do it for me. There we are. And here we're going to go SQL connection and open. And then what I'm going to do is go SQL command and parameters dot, and we have a range of parameters to pass. So we're going to go add range. The only problem is we want to put our parameters inside of there, and we're going to have to convert that into an array. So array like that. And there we go. All right. Then again, data table, just like we did previously multiple times. I'll call this store table is equal to new data table. And then there's an abbreviated way to use the adapter. Why don't I just show you that right now? So I'm going to say using SQL, and this is going to be data adapter like that. And let's call this adapter is equal to new and SQL data adapter, SQL command. And then at the end of this, I can just say adapter fill with our store table. There we go. All right. Anything else we need to do? No, that's it. All right. So actually, the whole thing needs to be put inside of a try block. Forgot to do that. Let's go try like that. And then let's go and copy this, all this stuff, and cut that out of there and paste this inside of here. And there, that looks good. And it's complaining because it wants me to catch an error. I'm just going to use this default. And I'm also going to show you finally, which actually finally has a use. And its use is that it is going to close the database. We always want to close our database. So we're going to say finally. And inside of here, we'll go SQL connection and close. Look at that. And then I want to call my display stores so that we are able to go and see the stores all show up inside of there, obviously. All right, let's run it. And this is supposedly going to allow us to add new stores. So will it? We'll find out. let's just call this ABC and 1, 2, 3. I don't know, South and city and state, and there's one. Add store. Oh, it gave me an error. Why was it? Incorrect syntax near zip. Doesn't like the zip. All right, let's figure out what's going on with that. I know what the problem. I forgot to put a parenthesis at the end. There we are. That's it. Just that one little simple problem. Let's run it again. And let's go ABC. It doesn't matter what this is, so I'm just going to throw anything inside of it. And like that. And add store. And there it is. ABC. See, it shows up. Nothing else is going to work yet because we haven't implemented anything else yet, but we will get to it. So what's up next? Well, I'd like to add inventory. So let's go and set it up so that we can do that. So test your button. I'm not going to do it this time, but it's always a good idea to do it. All right, so except when I don't want to. All right, so this time I'm going to be inserting both a store ID as well as a product ID. So I'll say insert into the table called store inventory, the values, and those values are going to be store ID and the product ID. And don't forget the parentheses. And there it is. All right, now what am I going to do? Basically the same stuff. So I'm going to need all of this, and I'm going to need open. That's good. Add range, I do not need. I'm also not going to need. Okay, so I just need these two things. So let's just copy that, just so I don't have to type two things, and paste this down inside of here. There it is. Okay, so got the command. I opened the database. Now what I'm going to do is I'm going to say, let's do it different. So we'll say SQL command dot, you can also do it this way. So we'll say parameters and add with value. See, I said I was going to show you multiple different ways of doing things. Well, here's another way. At store ID and store list dot selected value. And that's the value they selected in the list, the list box. So that's where that comes from. And down here, paste this here. And this is going to be our product ID. So product ID. And this is going to be the product list. That's the name of it in our interface we defined over here. I don't think I need to show you that again. And then you can just simply come in and say SQL command dot execute scalar, like that. Good. And we can go and copy this verbatim. This is exactly the same. So copy and paste that inside of there. There we go. And now we will be able to add inventory quite easily as well. Up next, I'd also like to be able to add products. So how do I want to do this? Is there code that I can copy? It's always nice to copy code. This, I think I'm going to copy like all of this one because it has multiple different parts and I like that. So let's just select that and copy this because it's almost identical. And I could almost definitely put this into a separate method to save code duplication, but you know, this tutorial is very long and I'm just going to do it this way. All right, so I just pasted it in there. What do I need to do? This is going to be a list of parameters that we're going to be defining again. So what are they? Well, then we're going to have a manufacturer, and this is the name it has in the table in the database. And this is going to be a variable number of characters. And where are we going to get this from? Well, we have a text box that's called product manufacturer. That's the text box name. And I want the text from it. And that's good. And I do not need this. We're only getting the brand and the manufacturer, nothing else. And this is called brand. And this is also a variable number of characters. And the value it is going to be coming from is going to be called product brand. Product brand. Product brand. And just so you're 100% aware, the name that this is where it's coming from. The name of that is product manufacturer. The name of this is product brand. I know sometimes things don't click, and so I want to make sure that you understand exactly where all of this information is coming from. Okay, so now we're going to have a query. What is the query? Well, I'm going to be inserting into, and I'm going to be inserting product this time, and values, and the specific thing I'm inserting is manufacturer. That's where that goes, and brand. So let's go put this here, brand. All right, so that's where they're going to go. And then after I have that, I do need the SQL command. I obviously need the ability to open this. Range, yes, I'm going to be adding a range of products. Data table, for this one, let's go and call this product table, just so that there's consistency, because this has absolutely nothing to do with a store. So product table, this is fine, this is fine. Do I need to do anything else? Using I do not think I do. I think everything else here is perfect, except for this part right here. This is going to be called display all products. All products. And that is going to be called just so that it updates the information that is in the product area. All right. So we're able to add products. We're able to add inventory. We are able to add stores. So we have all of that awesomeness inside of there. Now what I'd like to do is be able to delete all those things. So inside of here, what do I need to change? And can I copy? More importantly, can I copy what I already created up here? Yeah, let's try this one. So let's copy this through this. Copy. And even though we're deleting, a lot of the things we're going to be doing are going to be very similar to what we did before. Now, what's going to change here? Well, this is going to completely change. So I'm just going to get rid of that. I'm going to say delete from the table called store. And then I have to define how to delete. I'm going to say where the ID is equal to the store ID that I'm going to pass it. And I'll show you how to get the store ID. And I have this command. I have open. I am not going to be, add with value. I don't need two of these. I just need one of them. So let's get rid of that. Add with value. And this is going to be store ID just like before. And it's going to be store list selected value. So it's going to delete whatever is selected in the list box. And execute scalar. All good. This is good. That's good. The close is good. And guess what? I'm deleting from stores. So I want to update the stores, the store list. So that's also very, very good. All right. Anything else I'd like to do? I don't think so. I think that's pretty good. Well, one problem, however, is if I delete a store, then this is not, it's going to mess up my other table that I have, my store inventory, because if I have store IDs inside of here and I delete stores, well, that's going to cause all kinds of problems. So what I want to do is I want this to update. And how you can do that is by right-clicking on the store inventory. You can have the database basically do it for you. We're going to say open table definition, and come up here, and let's see. Did I already add it? On delete cascade. I added it. I guess I added it previously, and I didn't know that. Go and verify, but yeah, just type in on delete cascade. And what it's going to do is it's going to automatically delete all of that information that doesn't pertain anymore because stores have been deleted. All right, good. Well, that saved time. All right, anything else I need to do? Well, we got that all set up. And I need to go in and delete inventory. So I'm just going to select this. and see, I think most of it's the same. So delete inventory. Let's paste this inside of here. Now this time we're going to say that we want to delete from, and this is going to be not store, but it's from a table called store inventory, where the ID is equal to, and in this situation, we're going to be deleting product IDs. And what else? Okay, SQL command, that stays exactly the same. We open just like we did before. And here, what I need to do is add value, and what we're going to be passing over are product IDs. And what else? The selected value that we have here, also good. And execute. Look at that, so good. And the thing that's going to display here is I need to say that I want to display store inventory because that changed. So the store inventory changed, and I want to update that list view also. And did I don't know if I copied anything else. Let's just copy this and let's continue. So let's say I want to delete a product. How can I do that? Well, this is largely going to be the same also. So I'm going to say delete from, in this circumstance, I'm going to be deleting from product. So product like that. And where the product ID is equal to the product ID, of course, the SQL command, the open, add value. The value I want to add is the product ID. And this is going to be product list, not store list. So product list. And execute, and everything else is good there. Now this is going to be called display all products because that's what it's called, and that's going to update the view. And there we go. All right, so if I don't have anything wrong here, everything should work. The whole database should be working now, which is awesome. Okay, so we added some new stores. So let's just go here to this store. And let's say we would like to add this shoe to that store. Both were selected at the same time. And I am going to say add inventory. Uh-oh. Okay, so we got a problem here. It says that parameterized query, store ID, select from expects parameters store ID, which was not supplied. Okay, so inside of that for adding inventory. So let's go and let's take a look at what's up with that. Well, in reviewing the code, I actually saw a couple problems. Okay, so this right here, the data adapter, let's go, and this is not SQL command is not passed to that. What is passed to that, as you saw with every other circumstance, is the query and the SQL connection. Like that. Okay, so that is going to fix that problem that came up. Another thing that came up, this is down in add inventory click. I don't need to display the stores. What I need to do is display the store inventory. That is what changed. See, that's what happens whenever you rush through typing code. You sometimes call the wrong thing. No problem. Let's continue. Down inside of delete inventory click, what I'm looking for is I had where ID. That is not correct. What this is supposed to be is product ID is equal to the product ID that was provided. And I think I saw another problem here. Also, my parameters, add with value, product ID. This is going to be, store inventory. That's what's wrong. This is store inventory. See that? I got that messed up. So this is store inventory is where I need to update that, obviously, because I'm working with the inventory. And now let's go and see if everything, that was the bug that it threw, was the last one that I did there. I just noticed those other two bugs as I was looking at other things. All right. What did I say I wanted to do? Oh, I wanted to go to my new store. It's called XYZ. Oh, looky, it did update. So it updated, but then something else messed up. So we're going to go there, 327, add inventory. Hey, look at that, it works. And now what I'd like to do is add a new product. So I'm going to add product. I'm going to have to go manufacturer, Nike, and we'll say Air Jordans 1. I don't know. Add product. Is it going to show? I think it did. All right, so that works. And let's say I don't want the Air Jordans. I'm going to select them, delete product. Also works. Awesome.
I already showed you that I can go and work with a store, and I guess the only thing I haven't done is go in here and delete inventory. Is this going to work? It did. So there you go. We're able to add new products, new inventory, everything, and the database automatically updates. Thank you to any human being that has sat through this entire tutorial. I'm just testing new things and trying to provide the absolute greatest content that I can possibly provide. If you are one of the probably 5 people that watched this entire course, please take one moment and put a comment at the bottom saying you watched it. I will be shocked. And if you want to see more gigantic, all-encompassing courses like this, tell me and I'll do it. And like always, please leave your questions and comments down below. Otherwise, till next time.